Hey there, welcome to this AWS Masterclass, which is for developers as well as DevOps engineers. So we are going to master AWS Cloud, and here are some of the highlights. So I'll quickly take you through as to what to expect, and of course this is a long course. So I would also have a plan mentioned in the timestamps as to how you can take this course day-wise to finish it comprehensively. Okay. Now, first thing is, yes, this course is beginner friendly, and like all my courses, I make sure I consider beginners really well, and examples are also thought out from the beginner's standpoint. So we literally start from cloud computing fundamentals, as you can see over here. So if you're just a beginner who does not know what cloud computing is, if you don't know that, that's completely fine. You can just come in, you can enroll, start, and watch this complete course and learn a lot about AWS. Okay, so it's beginner friendly and hands-on. Yes, that is my teaching style. So people who know me, who follow me, they are aware of this, that I don't spend a lot of time on slides. Of course, I use them wherever needed or when explanation is required, but I prefer going hands-on, showing you things rather than just talking about it. So you see, you understand, and you grow. That is how things work. Okay, we cover the most in-demand AWS services right now. This is just researched, and as per the job market, I have made sure I have included a lot, like only valuable AWS services that are being used a lot. Okay, and this course will also build a strong foundation for certifications and also for real-world projects and job scenarios. Okay. So what are we going to cover? We are going to cover a lot, let me tell you, and let me give you a gist of what we'll cover. Now, if you're not aware of any of these topics or keywords, for example, Amazon S3, you're not aware of what it is, don't worry, I have you covered inside the course, okay? But just to give you a gist, we are starting with the ultra basics, like what is cloud computing, why does it exist today, why it's growing today, all of that we discuss. Then we talk about AWS Essentials. We talk about IAM, which is Identity Access Management. This is important. We then talk about EC2, like you can see, which is Elastic Cloud Compute. So if you want to boot up virtual servers in the cloud wherein you can deploy your Python apps, Java apps, Spring Boot applications, Spring apps, whatever you want to deploy, you can make use of EC2 servers, and I'll show you how you can launch EC2 servers for yourself. Okay. We have Amazon S3. So this is also an important service for storage standpoint. Amazon RDS, AWS CLI. So RDS basically is the database, Relational Database Service. Then we have AWS CLI. So how you can manage your AWS services, your AWS account through the console. So yes, we all are developers, and using console is really important. So that is what we cover. Going serverless with AWS Lambda. So I covered that. Okay, serverless is gaining a lot of popularity recently. So yes, we take a look at serverless applications there. API gateway. What is API gateway? How you can set that up? Why is it needed? We talk about networking basics in AWS. So of course, if you have multiple projects running, you can create your own network and make sure who accesses what. So it's good and important from the security standpoint. Security best practices. That is something we touch upon. AWS Fargate, ECR and ECS. ECR is Elastic Container Registry, and Elastic Container Service is ECS. So we cover all of this, and we talk about, and we also see how you can run serverless containers in cloud, okay, without managing any servers. Okay, so we talk about running serverless containers, and also we talk about with AWS Lambda running serverless code. So both of these things are covered, and these are in-demand technologies that every DevOps engineer or developer would aspire to learn. So yes, I won't spend a lot of time on introduction. I hope you are familiar with what we are going to cover. You can take a look at timestamps for basically knowing what is covered where. And yes, if you love this sort of content and if you want me to bring more of this, I would encourage you to like, subscribe, comment below and let me know. Okay. And also share this with people who want to learn AWS, okay, but they could not buy an expensive course, So this is being put out for free for everyone. So you can share it with everyone. And if you learn something from this, do mention this on LinkedIn and tag me over there, okay? And yes, do subscribe. I know a lot of you who are watching me don't subscribe, okay, but you love my content and you keep coming back. So that is something I got to know from analytics. but I would love to have you on board with the subscription, because number of subscribers impact the ability of me bringing in content on this platform. All right, without further ado, let's jump right in. So now it's time that we begin talking about cloud computing and understand what it is. So here on my screen, you can see the definition of cloud computing. Okay, so cloud computing is basically using computers, storage, software over the internet instead of owning and managing them on your own computer. Okay, so let me explain this better. Okay, so if you take a look at this term over here, okay, which is cloud computing. Okay, so you can see there are two words within this single statement or single thing over here, right? Cloud computing has two words. One is cloud, and then you have computing. Now, what do you mean by cloud? So cloud means over the internet, and computing means the computing that you do, the processing and storage and everything that you do over the cloud. So cloud computing is basically doing computing over the cloud. Okay, so let me explain this even better and let me make it clear over here. Okay, so when you talk about cloud over here, you are already using cloud daily, okay, in your daily life without realizing it. Okay, now if I have to give you an example of cloud, you must be making use of Google Drive, right? You must be making use of Dropbox. You must be making use of Gmail, Outlook, Netflix, YouTube, Zoom, Microsoft Teams. These are all the services that you are making use of over the cloud. Now, what is Gmail? Gmail is nothing but it's a email service or a software that runs on the cloud, and you are making use of it, right? Are you installing Gmail onto your system? Not really. You're making use of it over the internet. It's hosted somewhere and you're using it, right? You are never updating Gmail. So if the software is installed onto your local system, you will have to update it whenever there is a new version release, right? So are you updating Gmail ever? Are you getting the latest version of Gmail ever? No, it's automatically updated to the latest version. You are not installing it onto your system. It's basically available to you over the internet. Okay, so that is what cloud is. Okay, and computing meaning it's just you are making use of processing over here, right? Now, cloud itself, cloud has this thing of doing things over the cloud has gained a lot of popularity, like in the last like 20 years or so, right? And if you see, there are tons of benefits over here with this term cloud over here. It's accessible everywhere. You just need internet to access anything that's hosted over the cloud. You pay as you go, right? So basically, if you're making use of something over the cloud, you pay as you go, and it's not like you have to purchase entire thing at one go, but it will be sort of a monthly subscription or as you use it, right? It's scalable, right? So you can increase or decrease the capacity. So on Gmail, Google Drive, you can buy more storage and decrease the storage as well over a period of time, right? There is good security and there is no maintenance from your end, right? So it has gained a lot of popularity. Now, when we talk about cloud, so I'm just talking about cloud right now, and we'll go a little bit deep over here. So I'll just duplicate this over here. I'll come over here, okay, and I'll just get rid of computing for now, okay, for a while. Now, when we talk about cloud over here, okay, so there are three main categories when it comes to cloud services. So I'll better get rid of this and I'll create this in a rectangle. Okay, so I'll say over here, I'll come over here and I'll say cloud. Okay, and there are three main types of services is what I meant to say. So first is SaaS. Okay, we'll understand all of this. Other is PaaS. Okay, or I should write it like this. Okay, and this should be written SaaS like this, and the other one we have is IaaS. Okay, so let me talk about SaaS, PaaS, and IaaS. So what is SaaS? SaaS stands for Software as a Service. So if I have to say, it's Software as a Service, like so. Okay, and yeah, this is what it is, right? So what is SaaS? It's software as a service. Now, what does software as a service mean over here? Software as a service means that you are making use of software as a service, like the name says, software as a service. Okay, so you have software that is already built over the internet and you are just making use of it. You are not installing the software onto your system, right? And examples that you can think of it is Gmail, Google Docs, Zoom, Canva. All of these examples are software as a service because you are not installing anything. You are not setting up anything. You are just accessing a URL over the internet. You just need internet connection and you are using the software in your browser. Think of Canva, think of Gmail, think of Google Docs, right? Canva basically is a full-fledged, you can create images in the browser itself, right? But are you installing anything locally? Not really. You are just making use of Canva in the browser over the cloud, right? So that is software that is presented to you as a service, right? And this is a category of cloud, right? So cloud services have three main categories. Like I said, SaaS, PaaS, which is platform as a service, and then you have IaaS, which is infrastructure as a service. Software as a service, you are clear, right? You get access to software as a service. Now, what is PaaS over here, right? So, okay, so I'll just highlight this a bit so that we know this is at the center. Now, what is PaaS? Okay, this is not highlighting. I don't know why, but that's fine. Yeah. What is PaaS, which is platform as a service? Now, what does platform as a service mean over here? So, platform as a service means that you are making use of platform and you're using it for your own use as and when needed. Okay, so basically, what is a platform? A platform is basically something wherein you can build and run your applications. Okay, so you can think of stuff like Google App Engine or Heroku, right? So if you take a look at Heroku gives you a platform wherein you can just host your applications, right? And you don't have to manage the servers and all. Okay, so it's platform as a service. Now, you don't have to manage the platform. This is one very important distinction over here, right? So in platform as a service, you don't manage the servers. So for example, if you are building something solo, let's say I have an idea and I decided to build something on myself, right? And I don't have a team right now. So I don't want to hire people and they will be managing servers and all. I don't want to do that, right? I want to build things very lean. So what I would do is I would choose a service that is offering me platform as a service. For example, Heroku is one such thing wherein you can sign up for Heroku. You can connect a GitHub repository or any sort of Git repository, and then basically whatever code you're pushing to Git repository is going to be published, right? And you don't have to manage servers. If your traffic increases, you can scale up the servers. If your traffic is decreasing, you can scale down. So all of that with just one click. You don't need a big team basically to manage the entire server stack and technology and all of that. You just build and ship. That is it. The platform is taken care of by Heroku itself. Okay. So that is platform as a service, wherein you are given access to platform as a service, and you have all the software installed on the platform. And if you want any specific software to be installed, you can do that as well. Okay. Then comes IaaS, which is infrastructure as a service. Now, what is IaaS? Now, here you don't get platform as a service, but you get infrastructure as a service. So let me copy this, and here let me add something over here like so. So instead of platform, you can say infrastructure like so. Okay, and what I'm going to do is I'm going to just expand it like this. Okay, like so. So infrastructure as a service. Now, what does this mean? So here in platform as a service, you were renting a platform, right? But here you are not renting a platform. You are renting a infrastructure. Okay. What do you mean by infrastructure? So to run your application, you are going to need a server. You're going to need networking abilities. You're going to need storage. So you are renting raw infrastructure. Okay. And this is suitable if you have the ability to manage the infrastructure on your own. Because if you're renting the infrastructure, you're going to need DevOps engineers. You're going to need server engineers. You're going to need someone who is managing your servers, taking care of them, scaling when traffic is high, scaling down when traffic is low. So all of that you will have to do if you are making use of infrastructure as a service. Okay. So platform as a service, I gave you the example of Heroku. You have Google App Engine. But when it comes to infrastructure as a service, you have something like Amazon EC2. You have Microsoft Azure VMs. Okay. So that is infrastructure as a service. And here in infrastructure as a service, you as a technology person, you get complete control and you have the ability to manage the infrastructure the way you want. Okay, because you're getting the raw infrastructure. Now you do whatever you want to do in it, right? That is how it works. But here in platform as a service, you don't get full control. But of course, both are better depending on the scenario. Okay, so basically, if you want to build something very lean, you don't want to worry about infrastructure, then you will go ahead with the platform as a service. If you want better control and if you are okay investing over a service team, a bigger team, then you can go ahead with infrastructure as a service. So depending on your requirements, both can be chosen. Okay. So talking about cloud, okay, we had 3 main categories that we spoke about when it comes to cloud services. So it's better instead of cloud, if I say cloud services like so. Okay, so this would be way better. So let me have it like this. Okay, so when we talk about cloud services over here, okay, so So when we talk about cloud services, okay, there are 3 main categories of cloud services. One is SaaS, which is software as a service. Then we have PaaS, which is platform as a service. And then we have IaaS, and it is infrastructure as a service. So this is important that you understand what is PaaS, why does it exist, what is SaaS, and what is IaaS. This is very, very, very important. Okay. And this is all a part of cloud. And these are the services of the cloud. Okay. Now, I spoke about cloud services because it's important that you understand this, because if you are moving towards cloud technologies, okay, you are going to hear these terms of software as a service, platform as a service, infrastructure as a service very often. So it's important that you're clear right now itself, right? Now, talking about cloud computing, I've already mentioned cloud computing is nothing but using internet-based services instead of owning physical computers. So you can compute on your physical computer as well. Right, so you can get a processing power, you can have a physical computer set up, and you can deploy your own websites over there as well. Okay, it can be connected to the internet, but this is going to be cost, and you won't be able to scale fast. Tomorrow, if your application scales, you will have to add or buy more servers locally, right, and do the setup. And if something crashes, you will have to deal with it on your own. Okay. But with cloud computing, what you do is you make use of computers, storage, and software over the internet. Okay. And instead of owning and managing them on your own, someone else is doing that job of managing. You are just paying for what you use. That is what cloud computing is. I hope this is making sense, and this entire thing of cloud computing has given you some clarity of what is cloud, what is computing, and what are the different categories of services when it comes to cloud. Now let us talk about why cloud computing is there first of all. Okay, so what I'm going to do is let us come over here. Okay, so what used to happen early on. So we'll start with what used to happen early on. So when we start talking about things like what used to happen early on, you will also get a gist of what problems people faced early on. Okay, so let's say we have a company. Okay, this is one company. Okay, and let's say they are building a product. Okay, so this is company A, and this is building a product, and this product can be anything like a website or an application. Now, to host this particular product, they are going to need servers, right? So what these used to do is, so in early days, they used to buy physical servers. Okay, so what used to happen is they used to buy physical servers. So I'll write physical servers. Okay, they used to buy physical servers. Now, physical servers, what is the drawback of physical servers? You have to buy physical servers. You have to store them in your office or like any sort of place wherein they can be stored. Of course, they will generate a lot of heat, right? So you need to install cooling. Okay, you need to set them up in the room. You need to provide them with electricity. You need to have security. So you need to make sure that they are secure and no one can hack into it. Okay, because if someone hacks into your physical servers, then it's going to be a problem and you are going to face problems on your website. Okay, and in short, they also need an IT staff to be maintained. So if your application scales, now let's say you bought physical servers, you launched an application idea was hit. Okay, and suddenly so many customers started coming in. Okay, now what is going to happen is, instead of having 1 or 2 servers, you're going to need 10 servers over here, or 5 servers, depending on the traffic you are having. You need to scale, right? Because the traffic is increasing and you need more capacity, more power. Now, what used to happen with time is, let's say if there is a big scale, or let's say there is a big sale. Let's say the sale is Black Friday. Okay, so it's a Black Friday sale and your organization is hosting it, and there are millions of users that visit your website and application. Okay, now since so many people have visited the application, your application is going to go slow. So you will have to quickly scale the servers over here. Quickly scale servers, meaning you will have to add more server capacity. And suddenly you realize, like, from 5-10 servers, you have gone to 50-100 servers. These are all physical servers and you have bought them for managing the traffic that comes in during Black Friday. Okay. Now the problem is, there are so many people came on Black Friday. After Black Friday was over, everybody just like the traffic came down. So now suddenly you realize, like, you did not need so many servers. You just needed them for Black Friday, but you have already paid for these servers and now these cannot be returned, right? You have to keep it with yourself, right? Until and unless they will come only in use, until and unless there is a next sale, right? So what is the problem over here? The problem is, this entire process was expensive. This is how it used to happen in early days of the internet. The problem was, this was expensive. It was slow because you could not immediately scale and add physical servers. Okay, because if traffic scales, then there was a lag wherein the physical servers need to be bought in, they need to be connected, they need to be set up. There was an entire process that used to happen. So this was expensive, slow, and hard to manage, right? With increasing scale, it was hard to manage this infrastructure on your own. Okay, and this is where the era of cloud computing came in. Okay, to solve these problems. Okay, so what happens is, now this startup A. So we spoke about how this startup A managed things using physical servers. Okay, now also before talking about cloud computing, I'll also tell you something. This was the problem that Amazon itself faced for their e-commerce website, and I'll be coming to that. Okay, because this problem, when Amazon faced this problem for Amazon.com, that is when they launched AWS. Okay, and this was the entire story behind AWS, and I'll come to that in a while. Okay, but let me talk about this physical server. So this startup A has bought physical servers. Okay, they scaled physical servers for a sale, which is Black Friday sale, and they realized that, hey, they do not need suddenly so many servers, and so many servers that they have bought are of no use when there is no big sales going on. And of course, it was an expensive process. It was not easy to manage. Now, what would happen if this startup A launches or builds a product today? What it's going to do is, okay, so instead of going for a physical server, okay, it is going to, so I'll just make this small, and it is, instead of going through physical server, it is going to make use of server from the cloud. Or not a server, it is going to make use of, I should say, some sort of computing power. It is going to get computing power from the cloud itself. Okay, that is what it's going to do. So here you have a cloud provider. Okay, there is a cloud provider who rents the servers. Okay, and this startup A has built an amazing product and a website, and it thinks it is going to work really well. So what it's going to do is, to deploy it is not buying physical servers like it did like 10-20 years ago, right? But what it's going to do is, it is going to go to a cloud provider and it is going to get some computing power. Okay, it's just like renting electricity, water, a house. It is going to rent the computing power, a server, a small computing power, and then it is going to launch the website or the product. Now, there comes a phase 2 wherein this startup realizes that the application is doing well. There are more and more customers joining the application and using it. So what it is going to do is it is going to ask for more power and more computing power. It is going to scale the website from the cloud, okay, on the cloud. Okay, is it renting the servers? Not really. Is the startup managing physical servers right now? No. Is the startup paying for the servers upfront? No. It is buying or renting the computing over the cloud. Okay, who is managing the server over here? The cloud provider over here is managing the servers. Who is buying the servers? The cloud provider is buying the servers, and it is renting a part of the computing power to startup A. Startup A is not just the only startup who is renting this. There is another startup located somewhere in the world, which is startup B, that is also doing the job of renting from the same cloud provider. Then you have startup C. So there are many startups, many more startups who are doing the job of renting the computing power from this cloud provider. Okay, and this cloud provider has bought like some servers. Okay, and it is renting a part of which to this startup A, startup B, as well as startup C, and hundreds and thousands of more startups. So it's a business for this cloud provider wherein it's renting the computing power, storage power to these people who are launching. And it is providing the guarantee. This cloud provider is saying that, hey, tomorrow if your application scales, you can start with a minimum capacity. You can get the server of minimum capacity if you're launching new, okay, and have an option wherein you can scale up as and when your traffic increases. So let's say this startup A grows to 1,000 users or 100,000 users. Startup A is going to say, okay, I need to go to next level and I need to scale my website with a better power, because the website is going slow if many people are accessing it at one time, right? So it is going to say, hey, cloud provider, provide me with a better compute power. So cloud provider is going to provide it to A. Tomorrow it goes to 1 million users. It has 1 million people using the website. So it is going to again upgrade its computing power. And that's how this startup does not have to rent any sort of computing power. It just has to, borrow it from the cloud provider. Now tomorrow, let's bring in the same scenario. Tomorrow, let's say this startup A is running Black Friday sale, right? Now what happens in Black Friday sales? There are 10 and 100 million people who start accessing this website that A has built, the startup A has built. Okay. Now suddenly startup A realizes that, hey, there are so many people coming over to the website, I need more power. So it is going to upgrade and scale its application by taking more computational power from this cloud provider. It is going to upgrade all its servers, and upgrade will be one click. It is just going to tell cloud provider that, hey, this server that I'm using, please upgrade it to this capacity. So this cloud provider is going to confirm, and it is going to upgrade this A's website to so and so capacity. Black Friday sales go really well. Startup A makes a lot of money. Now it is going to go to cloud provider and say that, hey, the traffic has gone now. Okay, it's no longer Black Friday now. So I need to downgrade my servers now. Okay, so cloud provider is going to downgrade the servers of A because the sale is gone, right? And it is only going to bill for the time which A has used, or which during the time which A has upgraded or bought more power. It is not going to charge for entire month. Okay, so it's basically pay per use for the time period when A had upgraded the servers. Let's say A upgraded the servers for 3 days. So cloud provider is only going to bill A for 3 days and not for the entire month. So this is important, and this is something that you understand really, really well. Okay. So yeah, this is about cloud computing, and I hope this gives you a gist of how cloud computing works. Okay. So here the benefit is for these startup A, B, and C, they could just rent the computing power online, okay, over the internet. If they need more power, it was just like clicking a button and instantly they got it. For example, here Black Friday sale happened, so they just upgraded the power. If they didn't need any more, they could, downgrade and stop paying for additional computation that they had bought. Okay. There is no requirement of having cooling rooms or making sure that your servers cool down, electricity bills, or a full-fledged IT team. So these startups now, A, B, and C, can operate leanly. Okay. They can operate leanly with a small team.
They don't need to take the headache of having a big team to manage their servers, right? And this was different from how it was being managed early on, wherein you needed physical servers. You need to have your own power generator. So I missed talking about power generators, but if you have physical servers, you also need power generators, because if power goes on, you need to have some sort of backup over there. So it was very time consuming headache. It was a sort of headache, I would say, right? So with this approach, the cloud approach, okay, you have made your life easy. Okay, technology became cheaper because you are renting the technology. You are not buying the servers upfront. You are renting and paying for per use. It's faster to use. Upgrade, downgrade is easy, and you focus on your business ideas over here. Okay, and you are not focusing on managing and maintaining physical servers, right? So that is what cloud computing is, and that is how it came into picture. Okay, now let me talk about AWS, and let me tell you how AWS came into picture. Now, first of all, what is AWS? Okay, so AWS stands for Amazon Web Services. Okay, so it's basically AWS, Amazon Web Services. Now, what is this Amazon Web Services? Okay, so let me tell you, Amazon Web Services is a vertical within Amazon, and like like Amazon.com is their e-commerce website. Similarly, they have another business running there, which is Amazon Web Services, that is doing the job of providing everything like the cloud infrastructure to the companies, basically. So here we spoke about cloud provider. So that is what AWS is. It's a cloud provider with which you can rent servers, virtual servers. You can rent storage. You can rent a lot of other things using which you can build and launch products today. Okay. Now, Amazon.com. Okay. Amazon.com ran into this problem, wherein this problem that we spoke about of managing physical servers and scaling them up on Black Friday. Okay. So what I will do is I will, okay, if you come over here. So Amazon. Okay. So I want to tell you one thing over here. Initially, there was no AWS. Okay. There was only Amazon. Okay. So let me first talk about Amazon. I'll just move this web services somewhere over here. So Amazon back in 2000s. Okay. This was around like 25 years back. Okay. What used to happen is Amazon was the largest e-commerce website. Right, it's still the largest e-commerce website, but back then also it was the largest e-commerce website, and they had built massive infrastructure for their own needs. Okay, there was no concept of this cloud computing and all in that era. Okay, so they had bought physical servers, they had a massive infrastructure for scaling Amazon. Now, what happened is, whenever there used to be big sales like Black Friday and any other sale, there used to be tons of people who used to visit Amazon.com, buy on Amazon.com, and suddenly they had to scale their server capacity, right? And when the sale was over, what used to happen is this traffic used to go away, and suddenly they realized there was no need of having so many servers when there is no sale, right? So Black Friday will happen. Think of Black Friday. Black Friday will only happen once in a year. What would Amazon do with the rest of the servers for the entire year, right? So the servers were useless. So what Jeff Bezos did is, Jeff Bezos is the CEO and founder of Amazon. Okay. So what he did is he was the CEO and founder of Amazon. Then he was the CEO. Right now, from what I know, is someone else is heading Amazon, but that's fine. Okay. He's the founder of Amazon. So what he said to the team is, can we figure out a way to rent these additional servers for the rest of the years? For the rest of the period in the year when there are no sale running, because those servers are just lying there. Okay, can we figure out a way to make money out of these servers? That is what he told his team. And what team did is they built a website. Okay, they built a website using which they can like someone else can rent their extra computing power. So they had computing powers like physical servers, right? So they built a website thinking that someone will come and they can rent our computing power, okay, for some period of time. So that is how AWS came into picture, and they named the website and the service that they built as AWS, right? So AWS had S3, which is storage, it had servers which they call EC2 Instances. Okay, so they created this website and they started renting it to people and other startups, and that is how this business came into play. Okay, that is how. So the point of telling you this is you should understand the problem as to what was happening in early days. Okay, it's not like we are going back and we need to understand how things were happening early on, but it's basically I'm trying to explain as to why this thing exists, because that is when you will understand the importance of these things, because you have not seen the world before cloud computing, right? If you're watching this, it's likely that you might not have seen the world before cloud computing, or if you were there, you are not aware of what happened in the internet world, right? So I'm just trying to bring this point over here so that you understand the importance of cloud computing. And today what happens is, so earlier Amazon rented all these servers and all, okay, and then they thought of renting it, and that is how AWS was born. And suddenly they realized, like all the startup realized that, hey, they don't need to rent physical servers because that was a pain, and they started making use of Amazon Web Services. And it grew in popularity. So they actually solved a problem for themselves, which happened to be a problem that all the other startups at that time were facing. They didn't want to buy their own servers, and they let Amazon manage the infrastructure while they pay per usage. Okay, so a lot of startups makes use of AWS today. Okay, so yeah, this is what AWS is, and this is how cloud computing emerged. And looking at AWS, there were tons of other services that came into play, like Azure. Microsoft launched Azure. Google launched GCP. And today, cloud computing is a default choice for new business. Okay, today if you're launching business, nobody thinks of renting physical servers, right? If you're working in a company, does your company rent physical servers or buy physical servers? No. They are going to choose a cloud provider, and they're going to host the website or any product that they're building on a cloud provider, and they're going to rent the computing power from them, right? So this is what cloud computing is, and this is how it emerged into what it is today. Okay, I hope this has been useful, and I hope this gave you some good insights about what cloud computing is, and I hope this gives you a good understanding. So now it's time that we begin exploring AWS. So what I would recommend is head over to the browser, come over to your favorite search engine, whichever it is, and search for AWS. Now, the moment you search for AWS, you're going to see few links pop up. And this is the first link that I see, which is of Amazon Web Services. So you can see right here, Amazon Web Services, which is aws.amazon.com. So Amazon.com is the e-commerce website, and AWS is a subdomain over here, as you can see over here. So I'll just right click, I'll open the link in the new tab. Also, when you search, you will see quite a few links over here, like sublinks. You can see management console. So this is the link to the management console. You have a generous free tier. Okay, I'm saying generous over here, right? So if you're a new AWS user, if you're signing up for AWS for the first time, they have an amazing free tier wherein you can get started with AWS at literally no cost. Okay, of course, you will be charged later on if you exceed the free tier limit, but getting started is absolutely free. Okay, there are certifications that are available. Okay, so there is a link for this, AWS Educate, training certifications, all of these are links. Okay, the first three are very important ones. So if you come over here, okay, let's understand what AWS is. Okay, so here you can see it stands for Amazon Web Services, and you can see over here they have now generative AI promoting over here, because generative AI needs generally a lot of compute power, database storage, content delivery. So they are basically positioning themselves as the default choice for generative AI applications. You can see there are a few tutorials that exist over here, and you can read more about AWS and explore their entire website. So there are a lot of use cases that you will see over here in the retail industry, AI industry, financial services. Okay, there are quite a few products. So if you scroll down over here, explore our products. Okay, you can see Amazon SageMaker, EC2, Amazon Elastic Cloud Compute. So this is a virtual server that you get in the cloud. This is that service, right? You have a storage service, which is a simple storage service. So if you want to store images related to your application and all, you can make use of S3. Images, PDFs, receipts, all of that, right? You generally won't store it in the database, so you need a storage place. So EC3, or sorry, S3 is one of the service that helps you do that. Okay. Identity and access management, so you can control access to your AWS account using this service. You have DynamoDB, which is a managed NoSQL database from Amazon. Okay. You have Amazon CloudFront, which is also a CDN network. AWS Transform. So there are tons of services. You can see show 15 more and you will see more services load over here. You can see Amazon RDS. So this is the relational database. So you would host your application on the server, virtual server, which is EC2. You will store images on S3. Okay. If you have NoSQL database requirements, you will make use of Amazon DynamoDB. If you scroll down, if you need relational database, you will make use of Amazon RDS, right? Then you have Amplify, Elastic File System. There are tons of things. Okay. You can just explore them, and yet there is a link to show all over here. Okay. There are tons of services. Okay. And there are various regions that you can see over here where Amazon exists. Now this graph over here tells or talks about Amazon or AWS global infrastructure. Okay. So it's talking about the availability zones over here that exist with AWS. So you can see over here, it is globally available. You can see there are so many places at which AWS is available, and they have all their data centers there. Okay. So this is about AWS. If you scroll up, now one thing I'll tell you over here, this homepage changes quite a bit. Okay, so depending on when you're watching this video, you might see something else over here. Okay, because whenever I visit this website, I see something new over here. So they keep on constantly updating, changing the design of this website. So don't worry if you're not seeing something similar on your end over here. Okay, get started for free. So this is going to likely take us to our free tier page over here. Okay, and you can see Amazon free tier over here. Okay. And you also have the link to pricing over here at the top. So I'll just open pricing here. Okay. So let me open pricing. Okay. Pricing opens like this. And under pricing also you have free tier to access over here. You have pricing calculator, offers, saving plans. Okay. That's fine. So let's take a look at free tier. Now, basically, whenever you sign up for a new AWS account, you get you can get started using this free tier. Okay. And you can see over here that this is a free plan wherein you get around $200 in credit. Okay. Now I would also want to mention over here that they have updated their free tier recently is what I can see. Okay. So you are getting $200 in credits. Okay. Up to $200. Okay. So when you sign in, so you can see over here, gain $100 at sign up. So the moment you sign up, you get $100 and up to $100 later on. So as you start exploring services and do certain actions within the Amazon ecosystem, okay. So as you can see over here, you get more $100 as you explore key AWS services. Okay, and there are no charges incurred unless you switch to a paid plan. And then you have a paid plan wherein you basically start making use of production ready workloads basically. And you get free usage on selected services, and there are all these features that you get access to. And then here you have all these services that are there to explore. Okay, so you can click on EC2 over here and you can read more about EC2 here. Okay, so every service has their own dedicated page that you can go and explore over here, and how others are making use of this service. Okay, and for EC2 they have a pricing tab as well. So every service has a pricing tab. Okay, now what is EC2? EC2 is nothing but the virtual server that AWS has. So using EC2, so let me go to overview. Using EC2, you can borrow a computing power in the cloud, and you can make use of it, and you can install your own softwares that would be important for you for running your application. So you can explore all the features over here. Okay. And if you go to pricing over here, now instant type, if you see, okay, I'm not going into details over here, but you can get different instance types over here, like Windows instance, Linux instance, Ubuntu instance, and so on. Okay, so here, if you go, so there are 3 purchase options. If you go to on demand, okay, on demand, you are going to see the pricing over here. Okay, so for different regions, they have different pricing, and you can see over here. Okay, so this is the pricing. Okay, all the data transfer, first TB per month, it's 0.09 per GB, and so on. And these are different regions wherein you have instances available. Okay, so you can borrow from any of the regions. Okay, so this is something I'll leave for you to explore. Okay, and yeah, we came over here from this pricing page over here. Now there was a legacy free tier as well that existed. Okay, this was before July 15th. So if you right click and open over here, this is the old free tier that they had over there. Now here you can see over here, they had few services that were available for 12 months. Okay, so you could use few services for 12 months over here, and some services were already free or like always free. Okay, so they have updated the free tier is what I can see. So you need to explore this new free tier. Okay, but regardless, for learning, this is going to be free because they have a generous free tier still. Okay, they're giving $200 US, which should be enough for learning and understanding AWS. Now, few quick things that I would want to highlight over here to keep costs in control. Number one is whenever you're creating any sort of resources within AWS, make sure you remember that resource and make sure you remember to delete that resource once you are done practicing. Okay, because AWS charges you per usage, right? As and when you use the service. So it's important that you delete those instances or whatever resources you have created in your account so that you are not billed for that. This is one important thing that you need to remember. All right. So with this, I believe you have a fair understanding of AWS now. Now, as the next step, what we would do is we would create an account with AWS. So what I'm going to do is I'm going to click on create an account. If you already have an account, you can click on sign in to the console. So I'll say create an account over here, and you will be taken to this AWS console sign up page, right? And you will have to give AWS some information about or details about your account. So here we'll first enter the root email address. Now, what is the root email address? Root email address is the email address of the person who owns the AWS account. So it's going to be your email address, and I'm going to say abc@embarkx.com. Okay, this is just a dummy email that I'm entering, or you can enter abc@abc.com. Okay, I'm just entering dummy thing. Okay, and it's telling me account name, so I'll say test. Okay, it's asking me to verify the email address. So unfortunately, I won't be able to go ahead with this step because I already have an AWS account on my email. Okay, so I don't want to create a new one, but I'll just give you a gist of the process. You have to just enter your details. You will be asked for email address. You will be asked to verify the email address. The phone number will be verified down the line. You will be asked for entering the contact information, and you will be also asked to add a payment method. So you will have to add a card over here, and AWS will of course do a $1 verification on the card, and whatever amount is debited, it will be refunded. So $1 will get debited and it will get refunded. This is just to verify your card, and then your phone number will also be verified, and you will be asked which plan you wish to choose. So go ahead with the basic and free plan, not the paid plan. Okay, if you choose paid plan, it is going to be a problem. You will be charged for that. So don't select the paid plan. Just start with free AWS credits. All right. So I'm unfortunately not able to go through the sign up process, but it is a very simple sign up process, very user friendly, just like any other, just like signing up on any other website. Okay. And then once you sign up, you will be taken to the AWS console. Now, just to give you a gist of what AWS console looks like, this is the kind of console that you're going to see. Okay, they give you a nice overview of your AWS account over here, like what are the services that you have recently visited. So I use this account quite a bit, so you'll see some movement over here or something over here and recently visited. But if it's a new account for you, you won't see recently visited over here. Okay, and there are some cost charges and all of this. Okay, so the billing information, all of this you would see over here. So this is where the goal is. After sign up, you should land over here. All right, I hope this helps. So now it's time that we understand a bit about AWS ecosystem. So what I'm going to do is I'm going to ask you to search over here as the search query can be AWS infrastructure. And you are going to see this first link for AWS infrastructure, which I've already opened over here, right? Now, what is AWS infrastructure? So if you scroll down over here, you will see some terminologies over here, which I'm going to explain to you shortly. Okay, don't worry about that. But first of all, you'll see this terminology that AWS Cloud spans 120 availability zones in 38 geographic regions. Okay, and it has announced plans for 10 more availability zones. So they're scaling the availability zones, and 3 more AWS regions in the Kingdom of Saudi Arabia, Chile, and AWS European Sovereign Cloud. Okay, now this is as I'm recording this video. If you're watching this video at some different point in time, okay, it's likely that this information would have been updated, but this is where you will find the latest information. So right now it's there as I'm recording this video. It's there. AWS is there, is having 120 availability zones, and you can see all the availability zones over here. Okay, you can select South America, Europe, Middle East, Africa, Asia Pacific, Australia. Okay, and if you scroll down, you will see a lot more information. Now there are some terminologies like availability zone and all of this. Okay, so what does it mean over here? Okay, so for that, let me come over here to our favorite whiteboard. Okay, so what is AWS? First of all, think of AWS as a global network of data centers. Okay, so we are going to talk about few terminologies over here. Okay, first I'll just highlight the terminologies. Okay, or let me add a text box. So we are going to talk about data centers. Okay, I'm going to talk about AZS. Okay, this is nothing but availability zones. I'm going to talk about regions. Okay, so these 3 are the important things that we will understand. Okay, now what I was talking about AWS ecosystem. So what is AWS? You can think of AWS as a global network of data centers. Now, what is data center? A data center is nothing but a big warehouse which is full of servers. Now, what business AWS is in? It is basically in the business of renting a space or a little bit of computation on their server, right? So what they need warehouses of servers because it's a big business, right? So first thing that you should understand over here is data center. Now, what is a data center? Okay, a data center can be something like this. Okay, and it is going to have a lot of servers. Okay, it is like a warehouse that will have a lot of servers. So that is what a data center is. So there will be a data center when it comes to AWS. So you can think of data servers as a building full of servers. Okay, I hope that analogy would make sense. Okay, what is data center? It's a building full of servers, and servers are nothing but computers. Okay, powerful computers. Okay, that is what data center is. Okay, now these servers, what they are going to do, they are going to store data, run applications, handle requests of the AWS customers. Okay, and AWS has thousands of data centers worldwide, right? Thousands of data centers worldwide. It's a big business for them, right? And they have tons of customers. As customers are growing, they're opening more and more data centers. Okay, I believe they also mentioned this somewhere over here. Like, so if you go over here, so they mentioned here, you can see they are launching 3 more AWS regions. Regions meaning the servers, nothing but it's servers. Okay, we'll come to regions as well. Okay, so here first thing you need to understand is data center. I hope this is clear. Then you have something called as availability zones. Now, what are availability zones? So what AWS does is it is going to group multiple data centers. So this is one data center, second data center. They're going to group these data centers into something called as availability zones. Okay, so these 2 data centers become availability zones, something like this. And this is going to be also called as AZ, right? Availability zones, AZS. Okay, so AWS groups data centers into availability zones, and each availability zone is going to have 1 or more data centers in the same city. And these data centers will be connected with high speed networks. Okay, now what is, you will ask me, what is the need of having this availability zone over here and multiple data centers? Okay, so what will happen is they will replicate the data. So across multiple data centers in the same city, the data will be replicated. Why is it replicated? So for example, if one data center goes down, for example, if something happens to this data center, let's say it goes down. So this data center will have all the data that was there over here. Okay. And this will serve as a backup. Okay. So if one data center goes down, or if some sort of problem happens like power failure or some sort of natural calamity or something like that, then others are going to do the job of keeping them running. Now I hope this is clear, the concept of data centers and availability zones. Now what happens is multiple data centers are grouped to form an availability zone, and multiple availability zones are grouped to form a region. Okay, so basically I'll duplicate this entire thing. So I'll just duplicate this like this over here. Okay, and I'll just reduce the size of this. Okay, so that it fits in the screen. Okay, so I'll also select these. Okay, so there are multiple availability zones that will group things. Okay, so here if you see, this is one availability zone, this is the second availability zone. Okay, and they together, what they will form? They'll form a region. So this is nothing but a region over here. Okay. So here there will be something called as region. Okay. Now what is a region? A region is nothing but a group of availability zone in a specific geographic area. Okay. So for example, a region can be, so let me add over here. It can be North Virginia. Oops. Okay, it can be Mumbai, which is located in India. It can be Ireland, which can be located in Europe. Okay, so these are multiple regions. These are different regions that exist within AWS ecosystem. Okay, I'm just giving you an example of what all regions exist, why they exist. Okay, so here we started with data center. What is data center? That data center is the smallest thing that exists. It is basically, you can think of it like a building that is full of servers, computers, and multiple data centers come together and form availability zone. And availability zone is nothing but the group of data centers in a same zone, right? And data is replicated across these data centers. Then comes region. So multiple availability zones also form a group together to form a region, right? And there are multiple regions that exist like Virginia, Mumbai, Ireland. Okay. And yeah, this is what forms the global infrastructure of AWS. And when it comes to AWS, there are multiple regions that exist. Okay. There are tons of data centers that exist, and there are lots of availability zones that exist. Okay. So if you come over here now, all these terminologies will start to make sense, right? So AWS cloud spans 120 availability zones. What is availability zones? I hope you know this, right? The availability zones, AZS, right? So this is what availability zone is. Then they have 38 geographic regions as of now, and they are planning to come up with 10 more availability zones, right? And 3 more AWS regions in Saudi Arabia, Kingdom of Saudi Arabia, Chile, and European Sovereign Cloud. Okay. And you can take a look over here at different regions. Okay, so for example, Australia, you can see this is one region, and it has 3 availability zones, and it is launched in 2023, right? So one region has multiple availability zones as per the diagram over here, right? Can you see this? I hope this is making sense, right? And talking about data over here, okay, I also want to shed some light about data. Within availability zones, data is replicated across multiple data centers. Right. So if there is data within, of course, there will be data within availability zones. So within availability zones, data is replicated across multiple data centers, and across availability zones over here, many services are replicating data across multiple availability zones for high availability. So for example, if one availability zone goes down, there is another availability zone for the backup, right? AWS is known for its high availability. Right, it never goes down. Okay, there is a very good uptime that you get, and you don't have to worry about servers. So how are they managing this? They are managing with the help of replication. So here within a single availability zone, they'll have replication, and across multiple availability zone also they'll replicate the data. And if one availability zone goes down or some issue happens over there, you have another availability zone coming in for the backup. right? And this is within a single region, right? So this is what it is, and you can now go and explore this map over here, Asia Pacific. So there are 3 zones over here, and they have just launched in 2025. So they are launching more and more. You can see geographic regions, availability zones. They are coming in with more things over here. Okay, so they also have plans to launch even more. So you can just go and explore this entire world map over here. So if you click over here, this is South America. If you come over here, this is Mumbai. Okay, Asia Pacific, Mumbai. This is Hyderabad. Okay. There are tons of regions, availability zones, and data centers available, okay, across the globe. Now, there are so many regions. When you are launching your own product, your own website, how should you choose a region? Okay, of course, looking at this, it seems like you'll have to pick a region as to where you want to host your things, okay? So, the number one thumb rule is whenever you're picking the region, you have to make sure that you have to take into consideration the proximity to your users. For example, if you're launching a service in India, okay, you should choose a region in India because that will be nearest to your users. And this is to make sure that latency issues are not there. So, for example, if you choose a data center in Mumbai or Hyderabad, that is going to be closer to your customers, right? And this is launched in 2022, you can see. And Mumbai was launched in 2016. Right? So proximity to users is one of the important factors when picking a region. Okay. You also have to make sure and take into consideration the AWS services that are available in that region. Okay. So one thing I would like to highlight that not all AWS services are available in every region. Okay. For example, we are living in an AI world now, right? So AWS launches AI services. So some AI services might not be available in a region in Australia or region in South Africa or India. They might first launch in US based regions, right? So you have to check the services that are available in the region that you're choosing as well. Okay. And also you have to take cost into consideration. For example, if you go over here, if you go to products and let us say you open EC2 over here. Okay. So you are launching a virtual server, you are launching a app and you need a virtual server. Okay. Now here there is EC2 pricing. So if you click on EC2 pricing over here, so every service has a different pricing. So you can go to that service page. This is the service page of EC2 as you can see, and you can take a look at the pricing for EC2. So you can see on-demand instances, savings plan and spot instances. Okay. Now if you scroll down, okay, there is no region specific pricing over here, but if you go on-demand instances, okay, and if you scroll down over here, you will see the regions. Like this service is available in which all regions and what are the costs associated with it. So you can see over here. So first of all, these are the instance types that are available for EC2. For example, this is the smallest instance, which is nano. You have micro, small, medium, large, and so on. Okay. If you scroll down a bit, okay, you can see here pricing based on regions. So you can see over here. So for US East region, this is the pricing. For some other region, this will be the pricing. Okay. And you can scroll down over here, data transfer out and from Amazon EC2 to this regions over here. So if you are transferring data from this region over here in US East to any of these regions, then this is what the cost you will have to bear. Okay. So it varies depending on where you are and where you're coming in from. So for example, if I, not over here. If I go to, let's say, not US East, but let's say I go to Mumbai, you will see this is the pricing in Mumbai. Okay. And of course, if my customers are located in Mumbai, I would, or in India, I would want my data to be hosted here. So be sure to check because the pricing is region specific and pricing would differ by region. US East is usually the cheapest. Okay. So be sure to check on your end. And also, how to choose a AWS region. Well, so there is another point that I would want to highlight. First is I spoke about proximity to users. That is important consideration, or that is important point that people consider when choosing AWS region. Okay, proximity to users, a list of available services. Okay, you have to make sure whether all the services are available in the region you are choosing. Cost, because prices differ by region. And the last and fourth point that I would have is compliance and legal requirements. Okay, so some countries require data to stay within the country. For example, European GDPR, and there are some laws in India as well India's data laws. So you will have to choose servers in India if you are basically storing some data that law is not permitting to move outside the region. Okay, so compliance and legal requirement is also a thing wherein you would have to choose the region within the specific country. Okay, so yeah, these are some points that determine as to how you can choose an AWS region. Okay, number one is proximity to the users. Okay, number two is the list of available services. Number three is the cost associated, and number four is the compliance and the legal requirements. Okay, I hope these things are making sense. So this is about the AWS ecosystem, where we spoke about availability zone, data centers, regions, and how choosing the right thing matters. Okay, I also want to talk about service categories over here. So whatever services AWS offers, of course, it is categorized. Okay, so there are tons of services. First is here, if you go to products, you will see all the categories here on the left hand side. Okay, so analytics related services, you will see under analytics tab. You have application integration related services. You have compute. So if you're buying some compute power in the cloud, you have different services like EC2, Elastic Beanstalk, ECS, EKS. There are tons of things. Serverless, if you want to go, you have Lambda. Databases. So for example, if you want to store data in the cloud, you have Amazon Aurora. You have DocumentDB, DynamoDB, Neptune, Relational Database Service, which is RDS. So this is a relational database services that you want to store. Okay, so for example, MySQL, Postgres related data you can store over here in RDS. Okay, you have developer tools over here. You have end user computing, a lot of stuff over here. So AWS divides all these services into service categories, and you should know like this is how the categorization works, because there are tons of services. So they have done a good job of categorizing everything. Okay, so yeah, I hope this has been useful. So I want to give you an overview of the AWS dashboard, and we'll also talk about one of the important things within this dashboard, which is AWS Billing and Cost Explorer. Okay, so we'll come to that. But first here, this is what you see when you log into AWS for the first time. Here on this icon over here, if you click, okay, you're going to see all the services. Okay, so you can see recently visited services. So these are the services that I have recently visited. Of course, you will see this as empty if you have a new account, but I use this account, so I have some services that I've visited. Some of your favorites, okay, and you can add services to your favorites. You have all the applications, all services over here, alphabetically sorted. So you can see the amount of services that AWS has. You can see, you can just scroll through. It's so much, right? They have a lot to offer. So there are tons, and you can basically navigate to any service of your choice. And then over here, you will see service categories. For example, analytics, application integration, blockchain related services. You will see compute, containers, okay, database related services. So all of this you will see here in the dashboard itself. Okay. Now coming over here, okay, here you will see some overview of your AWS account, like your billing information, the cost and usage, the health of AWS. You will see all your applications, the console home. Now what I want to talk about is the billing service, right? So what you can do is you can search for billing, or I already have billing and cost management over here. So I'm going to just open this, or you can even search for billing and cost management from here. You can see billing and cost management over here. Okay. Now if you go to billing and cost management on the home page, you're going to see the cost summary and the billing information, the total forecast, last month forecast, and last month total. Okay. Now this particular tool is really important if you are a developer, and even if you are an AWS engineer. So if you are a software developer or a DevOps engineer, this tool becomes really, really important, because you will be focusing on making sure you are not build unnecessarily. How can you improve costs, optimization, and all of that. Okay, so there are tons of tools that I'll give you an overview of within this particular thing, within this particular view. So here you can see billing and cost management home. It says, okay, I have some payment due and I need to make the payment. Also here, there are some recommendations. So here, if you see, we'll come to the recommendation. It's asking me to enable cost optimization hub and add an alternate billing contact and even create a budget. So I don't have budget created. Okay, so we'll talk about budgets as well. You can see trends over here. So if there is any sort of costs that are being applied to my AWS service, I'll see the cost trends, and you can group by service, linked account. You can group by regions as well. So if you want to see what sort of cost is coming region wise, so if you have your services running in multiple regions, you will see all of that appear. Okay. Now talking about region, if you scroll up over here, I've selected global. Okay, I'm on global region, but here you can see there are tons of regions that exist. Okay. Now for some reason, all regions are not available for my account, and here you are seeing there are 17 regions that were not enabled for this account. So if you click over here, it's saying to enable regions, go to manage regions here and click on the link at the bottom of the drop down and then click enable. So that will enable all the regions for my account. Okay, so this is something I can do. I'm not sure if this is something that you will see in your account. If the regions are locked, then you can go to manage regions and enable it as per the instructions that are shown. Okay. But here, the point is here you can see cost by regions, cost by services, and cost by linked accounts. Okay. Here you will also get tips and recommendations from AWS on cost savings. So for that, you need to enable cost optimization over here. Okay. So you need to enable that. And here you will also see cost allocation coverage. So here you are seeing different information. If you want to know something about any of the things over here, you can click on info over here and you'll see some documentation open here at the right. Okay. So I will collapse this, and here this is about home. Then you have dashboards over here. So if you click on dashboards, okay, this took some time to load. So here you can create your own dashboard. Okay. So if you need a billing dashboard to be created wherein you show some sort of metrics, you can click on create dashboard, and you can add select a date range. Okay. Last 7 days dashboard. And you can add the widget over here, custom widget, predefined widget. So for example, cost widget is what I can add. Okay. So I can simply drag drop. I can click on this icon, these dots, and I can drop this cost widget over here. Okay. I can basically resize it. I can increase the size, minimize it. So it's completely you can configure. It's completely configurable. You can see over here, you can select all the properties over here. So this is how you can create a dashboard. So one dashboard can be for management level. One dashboard is for some sort of presentations. If you're having weekly stand-ups, you can basically create dashboard for that stand-up as well. Okay. So this is about dashboard, and here auto save is enabled. Okay. I'll save this. Okay. You can go to bills over here. So billings and payments. Now over here on the left hand side, you can see there are categories: billings and payments, cost and usage analytics, cost organization. Then you have budgets and planning. Okay. So we'll talk about bills first. So I'll just leave this page. Now here in bills, you're going to see basically all the bills that have occurred. So previous bills, current month's bills, you can manage payment methods. All of that you can do over here. Okay. Then you have something called as Cost Explorer. Now there can be it's possible that Cost Explorer might not be enabled for your account. So if it's not enabled, you need to visit Cost Explorer for the first time, and then you will have to click on enable. So you will see the enable button, but for my account, it's already enabled. Okay. So what is Cost Explorer? Cost Explorer is an interactive visualization tool that lets you explore past and forecasted spends. Okay. And so basically it's basically enables get a better understanding of the cost. It shows breakdowns by service, linked regions, usage types, and any sort of tags that you have done when creating the resources. Okay, so you have different options over here. You can select a date range. You can see granularity. So if you want to see daily, hourly, monthly, and you can see the division by service over here. So you can see cost in July over here broken down by service. So if for example, in July, the cost that occurred on your AWS account is $100. You can see that broken down into service wise. Okay, that is something you can see over here. So this is the cost and usage breakdown. So Cost Explorer is one service that I use a lot personally. Okay, because as a developer or a DevOps engineer, this is how you learn what is costing money in your AWS account. Where is my spend going? For example, if there are EBS snapshots that are spiking in US East Region 1, then basically you would know that using Cost Explorer. And what you can do is you can go to that region, and if you don't need that service, you can delete it. Okay. So yeah, this is something there. Cost Explorer is free to use. Okay. They give very detailed and interactive data. Okay. And to make better use of Cost Explorer, here you can see this breakdown by tag. So whenever you're creating resources, I don't have any tags right now in my account, but whenever you are creating any sort of resources, for example, EC2 instances or anything, make sure you tag them. So tag is basically a user defined grouping. For example, if I created 5 instances for a particular project, so you can add the name of the project as a tag. Then if you created 5 more instances for some other project, you can add tag over there again. So basically here, if you group things by tag, you will know, okay, which project is costing me more. So all of that you can see over here. Okay. So yeah, this is what it is. You have saved reports, anomaly detection, you have free tier. Okay. So if you are into free tier, right now I don't have a free tier, my free tier has expired. But if you are into free tier, you will see free tier usage over here. So if you want to keep a track of how much you've used from your free tier, you can come and see over here. You can export the data over here. Okay. So all of that is enabled over here. Okay. So this is about Cost Explorer and usage analysis. Then come over here in budgets and planning. So here AWS budgets. So this is interesting. Okay. Now AWS allows you to set budgets on your account. Okay. So budgets are custom cost and usage thresholds that you are defining within your account. They can be monthly, quarterly, yearly. Okay. And what you can do is you can see over here. You create a budget. Okay. I'll just zoom in. You create a budget and you will receive alert when you exceed that budget. Okay. And then once you receive an alert, you can respond with the action. So it's basically allowing you to keep a track of how much you're spending and basically making sure that you don't cross your threshold. Okay, so for example, you can create a budget. I'll say create a budget. Okay, and you have a you can see over here there are 2 options over here. One is using a template. So here you can use the recommended configurations and you can change some configuration options after the budget is created. But over here, this is customized. Okay, so here you can basically set everything yourself. Okay, for your use case. But using a template allows you to quickly set budgets instantly. Okay, so for example, let me select use a template over here. Okay, you will see over here there is 0 spent budget. Okay, so what is 0 spent budget? If you have an AWS account, you can create a 0 spent budget, and if there is a first charge, like if the cost exceeds 0.01, you will get a alert. Okay, how would you be alerted? So you can select this. If you scroll down, you have to name the budget. And then you can enter the name of or your email addresses. So whatever your email address is, abc@ whatever your email address is, you can add that all the email addresses that you wish to get notified using comma separated values. Okay, and you can say create a budget. So whenever there is first charge that occurs on your AWS account, okay, you will get this over here. Then you have monthly cost budget. Okay, so here you can see create a monthly cost budget that notifies you if you exceed a threshold, right? So here you can see this is the name of the budget and here the amount. So if the monthly cost exceeds $100, you will get an email. Okay, then you have daily savings plan coverage budget. Okay, so what this is going to do is it's basically related to savings plan over here, like the name says. And what is saving plan? It's a flexible pricing options that lets you save as compared to on-demand resources. Okay, so let me show you what this is. So if I say daily savings plan AWS, so here if you come, you will see this page. Okay, so here what you're doing is you are committing to AWS that I will be using your EC2 instances for 3 years. Okay, and if you're committing to AWS, you get a discount. Okay, so rather than paying pay-per usage, or rather than going by pay-per usage model, you're going by a commitment with AWS. Okay, for example, if you're running a startup and you are aware, okay, you will need the services of AWS for 3 years. So you can commit to AWS using this savings plan and you get a good discount. And here, what this is doing is this particular budget that we are creating over here. Okay, it is basically allowing you to set the threshold in the savings plan. Okay, so if basically you reach 100% coverage of your savings plan, you will get an alert. Or if you reach 70%, you can change this value. So whatever percentage threshold you meet, you will be alerted. That is what it means basically. And then you have daily reservation utilization over here. Okay, so this will keep a track of how much of your reserved instances are actually being used each day, helping you to see if your prepaid capacity is fully utilized or if you're wasting money on unused reservations. So you can make use of this over here. Okay, generally zero spend budget and monthly cost budget, these two are the options that are used a lot. Okay, in the template view over here. Okay, so I'll create a zero spend budget. I'll just enter the email address. So I won't create it right now. Okay, but you can create it for yourself. You can create these two budgets. Okay, these two are very important whenever you create an AWS account. I always recommend everyone to create these two kinds of budget. So this will tell you, okay, you have you will be notified when the first charge occurs in your when your spends exceed 0.01. So you know, okay, there is some service that is costing you money now in AWS. Okay, that is what this will tell you. And monthly cost budget will alert you. For example, if you have a monthly cost budget of $5 or $2, you can set this. And if it crosses this threshold, you immediately need to log into AWS account and see what's happening. Right? So these two other things. Then there is customized way which you can make use of. Now, using this customized way, you get additional controls over here. Okay, you can do customizations as to how you want to set budgets. So here also you're seeing like cost budget, usage budget, savings plan budget, and reservation budget. So you can select cost budget. Okay, you can go next, and then you will have the ability to set the budget over here. So here it's also showing you the previous spends. Okay, you can see. So you can create a budget over here, monthly, daily. So what do you want to say over here? So daily, if you want to set a daily budget, you can set over here. Okay, recurring budget, expiring budget. So this budget expires on this date. Recurring budget, so it will renew on the first day of every monthly billing cycle. Okay, and then you can have monthly as well over here. You can have quarterly. Okay, if you scroll down, this could be like you can have the budget scope. So whether this budget is for the entire AWS account for all services, or if it is for a specific AWS cost. So you can add that filter as well. Okay, and then you can go next. Okay, I didn't enter the name, so test is what I'll enter. Okay, and this is $10. You can go next. Okay, and you can see. So when I enter $10, you can see this graph also updated. Okay, so if I enter $1, for example, I have not been spending a lot of money on this. Okay, but you can see I've not been spending a lot of money on this account. But you can see over here this graph adjusted. If I say 0.5, okay, you can see this adjusted accordingly. So this adjusts, which is a good thing. Over here, budget amount, you can see, you can also set a threshold over here. I'm not going to do that. You can set a budget action. So what happens after the budget is hit? So you do next, and if you come over here, you can create alerts over here. Okay, so I can say edit, and you can add a alert threshold. Okay, so this is going to add a alert threshold when you hit 20%, and this is going to, when should this be triggered? So whether it if it hits the actual value or the forecasted value. So I'll say actual value, and you can enter the email address. So you can say courses.faisal@gmail.com, something like this. Okay, and you can say next, and you have the alert set over here, right? So I'm not creating this, but I'll just cancel. Okay, now every AWS account should have a zero spend budget, even if it's production account. Then also you should have zero spend, and I also recommend multi cost budget. Okay, so I'll just create a zero spend account. I'll say courses.faisal@gmail.com. I'll just copy this email. This is a dummy email that I have. So this budget is created. You can see over here. I'll create one more budget, monthly cost budget, which will be for $2. Okay, I'll create this monthly cost budget for $2 is what I'll enter. Okay, and 2, I'll have this $sign. Okay, so it will create and it will alert me over here. Okay, this will get created. I'll create one more monthly cost budget, which will be for $5. Okay, so I'll just say 5 and dollars over here, something like this. Okay, and I'll have the email addresses over here. Okay, so there are 3 alerts or 3 budgets I have created over here, right? Can you see this? So this is how helpful it is. So yeah, this is about the cost exploration, billing management. Okay, this is a really important thing about knowing how you can control the cost when working with AWS. So now it's time that we begin talking about IAM. So what is IAM? IAM, as you can see, stands for Identity and Access Management. Okay. Now, let me explain what this is. So this is a service that simply defines who can do what in AWS. Okay. So understand this. AWS is an account wherein a lot of people will be accessing, and they will be using your AWS account for a lot of things. Okay. Or whether they will be using your AWS account or the company's AWS account. Okay. Whatever use case you are exploring this for, a lot of people will be accessing. And how do you control the access of people? So IAM comes to the rescue and helps you define who does what in AWS. Okay. For example, you will have a set of developers who would be working on AWS and they would need access to your AWS account. So how would you grant access to them, and what sort of access level you would want to give them? Of course, developers should not be able to see billing information, your payment information and all of that, right? So how do you control that? Now you will have another group of users, let's say your finance team. So finance team in an organization might want access to AWS account, and they might want to check the billing information and everything. They might want to manage the costs and billing, right? So they won't need the ability to, spin off EC2 instances or write code, push code to AWS. They won't need access to all of that. They just need billing information. So you can control that using IAM. Okay. You would have some people who are managers and they would need some administrative access in IAM or AWS account. So in IAM, you can control all of this. So whether within your teammates or within your team members, you have developers, you have finance team, you have administrators, managers, who does what is defined and controlled using IAM. So IAM makes your life easy, wherein it allows you to manage identities and permissions, and it's a free service, but everything that you do in AWS is gated through IAM. Now there are a few core building blocks of IAM that we should talk about. Okay, and I'll have them pasted here. So we have IAM users, we have IAM groups, we have IAM roles, and then we have IAM policies. So let us understand each one of them. So here you can see, this is what a IAM user is. Okay, so when you say IAM user, you are representing an individual person. Okay, so for example, if you want to give access to your AWS account or your company's AWS account to a developer, you will have to create a user in the IAM console, and that user that you're creating is known as IAM user. You might have testers, finance teams, so for everyone you will have to create a user, and a user will have a username and password. So that is something governed by IAM users. Okay, so a IAM user can have username and password. Okay, and they can even have console access. What I mean by console access is the dashboard access, which is this access over here. Okay, so IAM user can have console access as well, and they can have access keys as well. Now, what are access keys? Okay, now access key are some secret keys using which a developer can access AWS resources using command line. Okay, because developers usually will be working on command line. They might be running commands. They might be making use of Linux-based instances. So they might want to access AWS resources, and they can do so using access keys. Now, finance team might not need access keys because they won't be writing code, right? So access keys can be used by developers, testers, right? So this is about IAM users. Now, what are groups in that case? Okay, so let me talk about groups. First, let me explain you the problem as to why group exists. Okay, now see, if you are making use of AWS for your organization, you will have users that require same set of permissions, right? For example, all the developers will require same set of permissions. All the testers will require same set of permissions. And the entire finance team will require same set of permissions. Like finance teams might not need access to AWS resources, but they will need access to billing dashboard. And developers won't need access to billing dashboard, but they will need access to AWS resources, right? Testers might need some different kind of access, right? So in such cases, you have a collection of users that require similar permissions. Now, instead of assigning individual permissions to every user that gets created, what you do is you have a group created. Okay, let me explain this over here. So let's say here you have this user. Okay, he is a developer. Okay, and then you have a finance team, like a person who belongs to a finance team. Okay, now you assigned this particular user, let's say you assigned this particular user a role. Okay, and what is the role? He can, he can make use of, or you have assigned him some access where he can access EC2 instances. Let's say I'm giving an example over here. Okay, he can access EC2 instances. Now let's say, so this permission is given to this user with the help of policies. Now policies is something that we have not discussed, but policies is a way using which you can define permissions. Okay, so what you did is you added this policy to this user against this user. Okay, now let's say tomorrow one more developer joins. Okay, so this was dev 1. Now we have dev 2 over here. So you assigned policies again. Okay, then you have dev 3. You assign policies again to this particular user, right? Now let's say you want to change something in for all the for the access level of all the developers. Okay, now you have to go to every user and update the policy over there, right? If you want to make any sort of access change, or if you want to give some additional access. Okay, so this becomes cumbersome. Now this is fine if you have 3 developers. Of course, this is still cumbersome if you have 3 developers, but if you have a team of 100, 200, and you're creating 100, 200 users or 100, 200 devs, then this becomes absolutely crazy, a mess, right? So instead, what you can do is you will create a group over here. Okay, and this group will be called as developers. Okay, something like this. Okay, so you have this group called developers, or I will just shorten it. I'll call it devs, like so. So I have this group called devs, and instead of adding the permission to individual users, IAM users that are created, what I will do is I'll create a policy and I'll assign it over here. Okay, I'll say dev policy, something like this. Okay, I've assigned a policy over here. Okay, or I need to give EC2 access, right? So I'll write EC2. So I've given this access to this particular group over here. And what I will do is I'll add all the users then to this particular group, right? Something like this. So individual users won't have the permissions defined in them. Okay, so I'll just get rid of EC2 over here. Okay, and instead of defining it individually, what I would do is I would just drop them inside this group. Okay, so like so. Okay, so now they don't have policies assigned to them individually. What happens is they are, whenever they join this team, okay, they are automatically given the permissions that have been given to this entire group over here. I hope this is making sense. Okay, so there are 3 devs that have been added in this particular group. Okay, now if 4th one joins, I don't have to do anything. I have to just create a IAM user and add that particular person to this particular group. Okay, so rather than going by this approach wherein you are managing every individual user and you are assigning permissions, policies to every individual user, you create a group, you assign the policy to this particular group, and you add all the like-minded people or people with similar roles inside, right? Now tomorrow if I want to update and add one more permission over here, let's say along with EC2, I want to give S3 access as well. S3 is also a service. Okay, so let's say I want to give S3 access as well. So what I'm going to do is I'm going to simply add S3 policy over here to this group. And the moment I add it to this group, it's assigned and it's reflected to all the developers that were part of this group. Okay, so what is group? Group is a collection of users with shared permissions, and you can see the example over here. For developers, for developer group, you can have this policy power access user. For viewers, you can have read only access. Okay, so this group thing makes your life a lot more easier. I have also tried to explain this with the help of a scenario. Okay, I hope this is useful. Now let us talk about roles. Now what are roles? Now there will be scenarios, of course, when services, applications need temporary permissions. Okay, now let's say you have AWS Lambda. Okay, AWS Lambda is one of the service, and you have deployed something on AWS Lambda, and the application that you've deployed on AWS Lambda interacts with S3 or let's say S3 bucket. It interacts with S3 bucket. So Lambda is going to need S3 bucket permission for a while, right? So generally Lambda cannot access S3 because they both are different services. So in such cases, what you can do is you can create a role which is like a temporary identity, and it can be used by the AWS service, okay, when it's running. So basically your Lambda function will get this temporary role, and he will be assigned or elevated to this with the specific permission for a while when it's running, and it will be able to access the S3 bucket, and then once it's done, it would be back to normal. Okay, so that is what a IAM role is. Now IAM role is very similar to IAM users, just that it does not have any sort of credentials. So see, IAM user basically is an individual person that has username, password, access key, but and it also has a permission. IAM users, right? It has policies attached to it. Okay, but IAM roles has permissions, but it does not have permanent credentials. Okay, it does not have permanent credentials, because if you want to give this particular permission to a service, of course, a service won't be able to log in using credentials, right? So that is where roles come into play, and you create a role basically to assign someone or any of the user, service or apps a role that it can be assumed when it's being executed. I hope this is making sense. And now let's talk about IAM policies. So what are IAM policies? So IAM policies are nothing but permissions that you define, and it can be used by roles, groups and users. Okay, so it can be assigned, and policies are usually defined using JSON documents. Okay, so it's a JSON like syntax that represent a policy. So yeah, these are some of the components or things that you should be aware of in IAM. I hope this entire thing has helped. So now it's time that whatever we have learned, we put it to action. So what I'm going to do is I'm going to start creating users, and we are going to make use of IAM and understand how it works. Okay. So here you can see I am in the recently visited tab over here, but I'm going to just simply search over here because you might not see it over there. So IAM, you can see, and here you can see a short description: manage access to AWS resources. And you can see top features like group, users, roles, policies, access analyzer. I'll go to IAM. Okay. And this is the IAM console. And you can see over here, there are like it's a straightforward console over here. Okay. So first thing is, here you are going to see security recommendation. So this particular account has the root user has multi-factor authentication enabled. Okay, if you don't have multi-factor authentication enabled, I would request you to enable multi-factor authentication in your AWS account. To enable multi-factor authentication, you can see over here my security credentials. Okay, manage your access keys, multi-factor authentication and other credentials. So you can click over this, click over here, and here you should see a way. So you can see over here multi-factor authentication, and I've assigned a MFA device over here. Okay, so this is done basically for myself. You can assign a multi-factor authentication device. You can add the device name, and you can basically add the way to authenticate yourself, and you can secure your account even more. Okay, so this is about multi-factor authentication. But coming over here to IAM, okay, let's explore this console. So first of all, what we are going to do is, here you can see under access management, you have something called as users, right? So here in users, I'll go, and here you can see I already have one user that has been created. Okay. So what I will do is, it's likely you won't see a user created over here. Okay. But what I will do is I'll create a user here. So this should be empty for you, like there should not be any user. So I'll say username, and username, I can see S3 user, for example. Okay, so this user is being created to access S3. Okay, so we have someone in the team who needs access to S3, let's say, or let us say the user is John. Okay, usually you will create the user with the name John. Okay, so I'll create John over here. Now here you can see this checkbox: provide user access to AWS management console. Okay. So if you're providing console access to a person, it's best to manage their access in IAM Identity Center. So I'll say provide. Identity Center is something that is new, and AWS is pushing us to make use of Identity Center. But I'll choose IAM, okay, because we are talking about IAM over here. So I'm creating an IAM user over here. Password. So it's saying auto generate the password. Okay, so I'll say auto generate the password, and or let me add custom password. So if you say auto generate the password, it is going to auto generate it for you. And custom password, you'll have to enter the password yourself. So I'll enter the password over here. So I've entered the password over here, and you can click on this to show the password. Okay. Now here you can see users must create a new password at the next sign in. So if you want users to change the password on the next sign in, you should keep this checked. But this is just for demo purpose. Okay. It's not an actual user that I'm creating, right? I'm not going to share this credential with someone. So this is just for demonstration. So what I will do is I'll keep this unchecked. Okay. I don't want to change the password on next sign in, right? And I'll say next. But ideally in production environment or something, if you're creating a IAM user for a real user, this should be checked. It's a good practice. Now, once this is done, you will say next over here. Okay. All right. I'll say never. Don't save this. So you can see over here, permission options, right? So add, do you want to add the user to a particular group? Do you want to copy the permission? Do you want to attach the policies directly? Okay. So I already have a group called S3 access. Okay. And you can copy the permission from some other user. You can attach the policies directly. Okay. So I'm not going to do any of this. All right. Right now, you can do it from here. Right. But I'm not going to do this right now. These are the options I'm showing you. I'll say next over here. Okay. It's asking you to review over here. So you can see John is the user. There is a custom password that we have given. Required password reset. No. Permission. We are not giving any permission. Tags. Okay. Now here you can add tags over here to any AWS resources. Okay. Like major AWS resources, you can add tags. Now what are tags? Tags are basically key value pairs that are added by the person who is managing the AWS account, and they help you to identify, organize, or search for resources. Okay. Now let me give you an example. You as a person, you will be working on multiple projects. Right? And for those multiple projects, you will be creating resources in your AWS account. Let's say there is a customer A that is from, let's say there is a US based project that is going on. Okay. US based. And there is another project that is going on, which is Australia based. Okay. I'm just giving you an example. Or let's say there is an example, company A and company B. So you're working for two companies. Okay. And you have created resources in your AWS account for company A. And also you have created resources for company B, right? So to categorize the resources, you can add tag. So for example, over here, I can say company name. Okay. And you can say company A. So this becomes helpful. Okay. So tomorrow, if you want to filter this, or if you want to filter filter all the resources or see any data with the help of tags, you can of course do and add a filter, right? And if you want to see any sort of billing information, so billing dashboard also allows you to bifurcate on the basis of tags. I'm not going to add it over here, but this is how you can add. I'll say create the user, and the user will be created. You can see. So this is the console sign-in URL. This is the username, and this is a password. Okay. Now what you can do is you can email the sign-in instructions to this particular user if you want to. Right, you can download this as CSV file, or you can return to the user list. All right, what I will do is I'll copy this sign-in URL. I'll head over to another browser tab and I'll open incognito mode, and here I'll paste that sign-in URL. Okay, so this is a sign-in URL, and once I add the sign-in URL, you will see the account ID being added over here. Now, when this sign-in URL loads, you will see the account ID being added over here. Okay. So this account ID was a part of the URL. So what happened is this ID got pre-populated over here. So you don't have to add this. Okay. And now you have to just fill in your IAM username, which is John, and you have to enter the password. So I'll enter the password. So I've entered the password as well. Okay. Now, understand one thing. Here I didn't click on sign in using root user email because this user is not a root user. What is the root user? Root user is the user who owns the AWS account. This user is not the root user. So he is a normal user, IAM user that has been created. So I am just making use of IAM user sign in page over here. Okay. And I'm going to say sign in. Now the moment I say sign in, I will be taken to AWS console over here. Okay. You can see over here, there is no recently visited services. Okay. Nothing over here. Access denied to cost and usage data over here. There's nothing that I can access over here around cost and usage. Okay, there is a short sort of tutorial that has come up. Okay, which is fine over here. I don't want to access it. Okay, but let us come over here and let us try to access EC2. Okay, so can you access EC2? So you can see over here, there is no access. Everywhere you are getting error over here, right? If you try to launch an instance, okay, if you try to launch an instance, you are of course going to get an error. Okay, let me go to S3. So if you go to S3, here also you won't be able to do anything. You can see over here, you cannot, so here if you try to create a bucket, let me create a bucket. So on this particular form, what I did is I entered some dummy bucket name. Okay, you can enter any bucket name, dummy. And I scrolled down and just clicked on create bucket. So the moment I tried to do this, you can see I got this error. Okay, so I'm not having the permission to create bucket over here. Okay, to be able to create a bucket. So you can see over here, failed to create a bucket. S3 create bucket permission is required. So view your permissions in IAM console. And this is a response that we have got. So this user, John, is not authorized to perform create bucket on this S3 resource. Okay, I hope this is making sense. So I don't have access over here. My access is very much restricted. You can see I cannot even see all the buckets over here. I cannot see the buckets listed over here. I can go to the page and I can see the S3 UI over here by Amazon, but I'm not able to create the buckets. Okay, now the, one second. So if I come over here, okay, create bucket button is there. They are not hiding this. I see the UI and everything. I can play around with the UI, but I cannot see the list of buckets and everything over here. Okay, so I hope this is making sense as to how you can just create a user over here. We created a user, okay, but the user is not able to do anything over here. So what I'm going to do is, let me come over here to this users. Okay, so cancel, I'll say return to the user list. Okay, he's saying you haven't viewed or downloaded this user password. Okay, that's okay. So I'll say continue. And now here you can see this John user that exists, right? So what I'm going to do is I'm going to come over here under permissions. Okay, within this user, I'm going to go and under permissions. So I'm within the user. Okay, if you click on this user, I'm under permissions. And here there is no permission that exists, right? So I'll say add permission over here. And now you can see over here, I can add him to the group. So there is already a group called S3 access which exists. Okay. And this group already has Amazon S3 full access policy attached. Okay. So this is a group and the policy that I had created early on. Okay, this might not be there in your account, but this exists in my account. That's fine. Ignore this, but we'll attach the policy directly. So here, if you go to policy, you can see there are tons of policies that exist. Okay. Now here you will see type is AWS managed, AWS managed, AWS managed. What does this mean? So these are predefined policies that exist from AWS. So when you say AWS managed, it means that these policies are being managed and created by AWS itself, right? So that is done, and this is AWS managed. So what I will do is, if you can expand this. So if you expand this, you are going to see this JSON over here, right? And this JSON defines this policy, right? Administrator access. So you can see administrator access. So if you want to create an admin user, you can see over here, this policy will provide full access to AWS services and resources. So you can see over here, version is this, okay? Statement, within statement, you are saying allow, effect is allow, this effect key says allow, action is star and resource is also star. So allow, action defines what the person can do, right? Or what the particular resource can do. So action says star, star means it's a wildcard, it says give access, allow him to do everything. And resource meaning which resource, like S3, EC2, which resource are you giving access to? So resource is also star, which means he can do everything everywhere. So that is what administrator access is, and it is defined by AWS itself. Okay, So be sure if you're assigning this to someone, he will be able to do everything on all the resources. So be sure of that. Okay, this is administrative access. If you see administrative access amplify, you can see effect allow action. So this is all the action. So you can create stack on CloudFormation service. You can do all of this. CloudFormation is a service. Okay, you can do all of this on CloudFormation, and resource is this. Okay, so resource is also mentioned. Okay, so this is the policy. These are policies you can explore. So we want to assign S3 policy. So I'll say S3 over here. And you can see over here, there is a Amazon S3 full access policy. You can see this, right? So what I'm going to do is I'm going to assign this to this particular user. I'll say next. Okay, and I'll add this permission over here. Now, the moment you assign this permission to this particular John user, I'll go over here and I'll refresh. Okay, so earlier I was not able to see, I was getting the access denied, but now you can see there are no buckets, right? Earlier I was getting an error. Now it says there are no buckets, and this sidebar has also come in. Earlier the sidebar was also not being displayed, right? So permission changed things, and now you can click on create bucket. Okay, or if you go to S3, Amazon S3, you'll see create bucket over here. So you create bucket, I'll enter any name. I'll say my dummy bucket, and I can say any sort of name over here. Okay, now whenever you are creating a S3 bucket, remember that the bucket name has to be unique across Amazon globally. Okay, so that is something I've done. And here, if you say you're seeing block public access, that's fine. I'll say create a bucket. I won't make any changes to the bucket settings, but I'll just create a bucket. So you can see the bucket is created now, right? So this is how the permission things works. You just added this permission over here. Now let us come to user groups. Okay, now there is already a group created called S3 access. Okay, what I will do is I'll just delete this group because this might create some confusion. So I'll just delete this. I'll say S. So you can see how deleting is a sensitive action. So it's asking me to type something so that I don't delete something accidentally. So this is deleted. Now what is group? A group is a collection of IAM users, and you can assign permissions to that group. So you will create a group. I'll create a group called developers, okay, or image uploaders. Let's say image uploaders, and they need access to S3. Okay, so this is my group name, image uploaders, and I'll add John to that particular group. Okay, and I will select search for S3 full access over here, and I'll say create the user group. So whoever is added now in this image uploaders will have complete access to S3. Now if you go to users and if you click on John, you will see he's part of this group, right? And he'll still have access to AWS S3. So if I refresh, he'll still have access to AWS S3. Nothing changes over here. Okay, but I can change the access. Let's say tomorrow requirement changes. Okay, I want to update the permission for all the image uploaders from S3 full access to that of let's say I just want to give them S3 read only access. So I can come over here and I can go to user group, image uploaders, and here instead of permissions, I'm going to add a permission, attach policy, and I'm going to say S3 read only. So I'll say S3 read only access. I'll attach the policy over here. Okay, and S3 full access I'll get removed. Okay, so they don't have full access to S3, but now they have only S3 read only access, which means they cannot create the buckets. Okay, it's taking a bit of time. I don't know why. Okay, but it should ideally. Okay, you can see S3 read only access. Okay, so now what this means is the user John also has S3 read only right now. Let me refresh. Okay, so okay, he has full access also because that was attached directly. So you remember when creating the group, before creating the group, we had attached the policy directly to this particular user. So you can see over here attached wire directly, and this is coming in through group, right? So what I will do is I'll get rid of this. Okay, we'll have to get rid of this. But now if you come over here, okay, and if you refresh, read only meaning he can only read the buckets, but he cannot create the bucket. So let me create the bucket. Let me try creating. So I'll create this dummy bucket and I'll say create. So now you can see create bucket permission is required. Can you see? But he can see the buckets. He can see the buckets. Okay, but he cannot create buckets. So you can see how a permission change at group level just impacted everyone. Now if you go to user groups again, image uploaders, and here in permissions, I'll add the permission, I'll attach policy, I'll say EC2 over here. Sorry, not EC2, S3 full access, and I'll attach this policy here, and I'll get rid of that read only, or we don't need to get rid of read only, you can get rid of read only as well. Okay, so I'll get rid of read only. Now if you go to users and if you go to John, you will see S3 full access is being added by a group, right? So this is fine. Now if you come over here and if he tries to create the bucket, it will get created. So I'll create the bucket, I'll say create. You can see the bucket will be created, right? So this is how groups make your life easier. If you have hundreds, thousands of developers, you can create a developer group, and developers usually need same set of permissions. So you give them that specific access, like access to CLI and whatever. Okay. And if you have finance team, you can create a group finance team. So it makes management a lot more easier. Okay. You also have roles. Okay. So if you come over here, you have roles from where you can create roles over here. So I already have few roles created. Okay. Which is fine. But you can create roles over here, and you can see over here, role is an identity you can create that has specific permissions with credentials that are valid for short durations. Now these credentials you are not creating, but it is assigned by AWS itself. Okay. So role over here, you can create the role for the trusted entity type. So here, if you click on this info, you will also get the documentation. Okay. So here you can say AWS service. So what are you creating this role for? Okay. So are you creating, so let's say we want a role to be created for EC2 instance. So you can say over here, allow EC2 instances to call AWS services on your behalf. Okay. Allow EC2 instances to call AWS system managers on your behalf. So you're creating this role, okay, allows an AWS service like EC2 Lambda to perform actions on this account. So you're creating a role for EC2. Okay. If I want to create a role for Lambda, I'm going to select Lambda. Okay. You can see over here, right? You can even select AWS account over here. That is something you can do as well. Now this option is for users, or for allowing a user or a service in a different AWS account to access resources in your account. For example, you would have a central IT account, okay, which is being managed by IT team, and a separate production account, right? So there are two AWS accounts. Now a developer in IT account needs to be able to deploy updates to the production account, right? So what you would create a role in the production account and set the trusted entity to the IT's account ID, and this allows the developer to switch roles from their IT account to the prod deployment role in the production account. Okay, so this is like giving your keys basically to a trusted a person who is from other account. That is what this option is for. So you have to like add another account over here and do all the configurations. Web identity. Okay, now this is for allowing users who are authenticated by a public identity provider to assume a role, right? So example, you have a mobile app that uses Google or Facebook for user logins. So when the user logs in, you get a temporary token from the identity provider, and they can use this token to assume a role and gain access to your AWS resources, right? Like uploading photo to your S3 bucket. Okay, so you can select the provider over here and you can go ahead with that. SAML federation. Okay, so this is similar to web identity, but it is used for corporate identity providers and is the most common way to integrate with companies' internal login system like Microsoft Active Directory. Custom trust policy. This is the most advanced option, and this allows you to define a custom JSON policy to define trusted entity with more granular control and specific conditions. Okay, and we spoke about this AWS service. Okay, this is for granting permissions to AWS service to perform actions on your behalf. So I've selected Lambda over here. We'll go next. You can add permissions over here. What sort of permissions? So if I want to give S3 bucket access to Lambda, okay, then this is something I'll create, and then you can name the role. Okay, so you can say Lambda S3. Lambda S3. Okay, so you can see description, it's auto-generated. It says allow Lambda functions to call AWS services on your behalf, and this summarizes everything. Okay, Lambda S3. So you can say Lambda underscore S3, and you can see the trusted policy over here. Okay, and here you have the permission policy. You can add tags if you wish to, and you can create the role. something like this. Okay, so a role is created. You can see Lambda S3 over here is being created, right? So these are roles. And if you go to policies, you will see all the policies over here. You can see all the policies. These are all AWS managed policy. Okay. Now there are AWS managed, and you can even create your own policy. So you can see over here, policy editor. So you have policy editor. So you can do visual editing. You have actions. You can do JSON editing as well. Okay. So let's say I want S3. Okay. So S3. I'll select S3 and what I want to do. So what all actions I'm creating policy for. So list grants, list access points, list buckets, and list jobs. Now you can even read more about these rules over here. List jobs. So if you click on list jobs, it says grants permission to list the current jobs and the jobs that have ended recently. Okay. So I'm creating a permission which allows list access grants, list points, list buckets, and list jobs. These 4 roles are only being assigned over here. Okay. You can even, so this is for access level list. This is for access level read. This is for, if you scroll down even further, this is for access level read or write. Okay. So I can allow someone to create access point as well. So you can go more granular. You can, select so many information. You can also add the permission for tagging over here, delete object tagging, delete job tagging, all of that. Okay, so you can just explore this. There are tons of roles over here. Okay, and I've selected S3 over here. So you select the service, you select the permissions or actions over here. Okay, actions. So I'm selecting actions. Then you add the resource over here. Okay, so what are resource types? So you can say bucket over here. Okay, and you will add the resource. Oops. So bucket name. So which bucket name is this for? So whatever bucket name you have created, that is something you will have to add. So let's say I add for this bucket. Okay. So it is for this resource. So I'll add like so. Okay. And I'll say add the resource. So you can see these actions on this resource is what this permission is being created for. Right. And you can add a condition as well, which is optional. Okay. Now there's a visual editing over here. So if you can see visual editing here for this entire thing. Okay, but generally JSON is preferred if you are a developer. Developers love working with JSON, so they prefer JSON, and you can even add more statement. So this can go even more complex. You can add more statement and you can create your own set over here. And then once you create, so let me create over here. I'm creating a temporary, I'll say temp over here. Okay, this is temp. And I'll say create a policy. So this will be created. And now if you see over here, okay, let me search for temp. So you can see this is customer manage. So everything was AWS managed. This was customer managed because customer has created this. You can see this. Customer has created this. Right. And you can assign this to any user just like any other policy. So you can come over here. You can add the permissions. And here you can see attached policy. You can say temp. You can see customer manage. You can assign this. Okay. So yeah, this is about policies and how things can be done with policies. Now I also want to talk about some best practices that you should keep in mind when managing users and everything for your AWS account. So first thumb rule is never use root account. Okay. We are using root account till now, but you should never use root account. And the best practice is you create a admin user and use that one. Okay. So what we are going to do is I'm going to come over here. I'm going to go to user, and here I'll create a admin courses over here, something like this. Select this. Okay. I want to create an IAM user, and I'll have a custom password. Okay. I'll enter my password here. So this is the password, say next. Okay. And I'll attach policies directly, and I'll give this user administrative access. Okay. I'll say next, and I'll say create the user. Okay. Now I have these console sign-in details. I'll copy this and save it somewhere safely. Now once I've saved all the details, okay, what I am going to do is I'm going to log out of this user. Okay, and I'm going to make use of that account. Okay, so let me log out over here. Let me sign out. Okay, and I'll sign in with the other user. I'll paste in the URL that I got, the sign in URL. Okay. And okay, this is reloading. It's taking a bit of time. So yeah, the page loaded and I entered my credentials and I'll say sign in. Now I'm not signing in as a root user, but I'm signing in as a admin user. And you can see I'm logged in now. So I'll use this account going forward. And this is very, very important that you use this account because it's generally not a good practice to use your root account. Okay, root account is only for billing, security, because anything can be done from your root account, and AWS is such a thing wherein if it lands in wrong hands, like if your account get hacked or something, okay, your account can even be deleted. So that's the thing. Okay, so never use root account is the best practice. Okay, set up IAM users or group always and assign them the right permissions. Okay, for example, if you have developers, you can create user or a group for developers. For testers, you can create a group and you can assign them the right permissions. Also make use of multi-factor authentication everywhere. Now what that means is whenever you are creating account, enforce multi-factor authentication on all the IAM users with console-based access. This is really, really important. Security not only begins with you, but also people who are using your organization account should make sure that their accounts are secure and they are making use of multi-factor authentication. Also follow the principle of least privilege, which means that don't give administrative access to everyone just because it's convenient. Okay. Instead, create narrow policies. Like, for example, if someone needs access to EC2, like just give them access to EC2 and deny IAM changes. Okay. So narrow down the policies. This is how you will keep your AWS account really, really secure. Okay. So I hope I have been able to explain all of this and you have got a good gist of IAM as a whole. I hope this has been insightful. So when it comes to cloud world, you will often hear this term called root account hardening or account hardening. Okay. So what does hardening mean? So hardening basically means making an account or system or an application more secure by reducing its weakness. So when it comes to AWS, how would you harden the AWS account or your AWS account basically? Yeah. So understand this thing. When it comes to AWS account, the most important thing is the root account that you have access to, right? And root account is the most important account because it has access to, everything. It has access to billing information. It has access to all the other users basically. So you can manage and control all the other users. It's basically the master of that particular account. Okay. Now, when you say you want to harden this particular AWS account, you mean you want to make it much more secure. Okay. So I'll just share some more steps over here. So here in the root account, so let's say if you're logged in through root account here, right now I'm logged in through my IAM user. So if you're logged in through root account, come over here, go to security credentials. Now inside security credentials, you are going to see everything over here. Okay. Okay, it's asking me for rating. Here you are going to see everything, and here you can see this warning over here that I have not enabled multi-factor authentication. So if you have not enabled multi-factor authentication for your root account, you should definitely do that, and you can assign a multi-factor authentication over here. Okay, it will take you over here, and you can select Authenticator app or whichever way you want to do. So if you're using Google Authenticator, you can make use of this. Okay, but there are other things over here. So access keys, if you have any access keys created against root account or in root account, you should immediately delete it or revoke it. Okay, that is very, very important because using access key, what can happen is anyone can gain access to the root account and it can be extremely dangerous if it's leaked somewhere. So it's best to delete or revoke any sort of access keys that are there associated with the root account. Okay. Also, I spoke about a multi-factor authentication. You have to assign a multi-factor authentication device over here. Okay, I would also recommend, like, if you have a IAM account, you should also assign a multi-factor authentication device here as well. It's totally up to you. Okay. Also, in the root account, I'll tell you, you have to go over here in account, and here I think you have to click on account, and let me go to account. So it's loading. Now, since I'm logged in using IAM account, I'm seeing over here, I don't have this permissions over here, right? So it is okay. But in the root account, if you're logged in through root account, you're going to see the contact information and alternate contacts. So I would recommend you add billing, security, operations related contacts over here inside alternate contact. Okay, let me show it to you. So I've logged in through my root account, and you can see over here there within alternate accounts, you can see billing contact, operations contact, security contact. So I would recommend adding all of this if you are setting up a company account. Okay, you should enter name, title, phone number for each contact and save it. Okay, because this would be helpful, right? And also add your contact details as well. Now your contact details are supposed to be added in this contact information. Okay, so I'm not showcasing my contact information over here because in root account my contact information is already added. Okay, so I've switched over to the IAM server here. Okay, so this is what the concept of root account hardening. It's very important to keep your root account secure.
So now it's time that we begin talking about EC2 and understand what it is. So what is EC2? So EC2 stands for Elastic Compute Cloud. Okay, so this is how it expands, ECN2, Elastic Compute Cloud. Now it is nothing but a AWS based service for renting virtual servers in the cloud. Okay, so compute in the cloud is what you can say. So if you see Elastic over here, okay, what does Elastic mean? Elastic means it is fully flexible. So you can launch either one server, 1,000 servers, you can increase or decrease the capacity. It is fully elastic. Okay, and it's not like you have to buy this much of capacity only. You can upgrade, downgrade anytime. So it's completely elastic, and that is why it's called elastic. Okay, it gives you full control. So if you want to choose operating system, software, networking, the kind of operating system it runs, so all of that you can configure. There is no issue in doing that. You can install whatever you need. So it's basically like having your own compute or having your own system in the cloud, right? So elastic compute meaning it's basically like your own system, and cloud means it is there in the cloud. Now EC2 these days is being preferred a lot by the organizations, okay, instead of having virtual machines. So what used to happen is if EC2 is not there, the organizations will have to buy on-premises virtual machines, okay, having their own data centers and physical servers at your office, which is not good. So here what AWS has done is they have taken away that headache from organizations wherein they have to have their own servers and everything, right? So organizations can come, they can choose their own, size, CPU, memory, and they can rent servers on demand. On demand meaning they have to pay only for what they use. Like for example, per second, per hour basis, that is what they are being charged. Now, when we talk about EC2, there are few concepts that I want to talk about, okay? And these are the concepts that you will hear a lot. So first concept is instance, okay? Now, what is an instance? An instance is a running virtual server. So when you create your own server using EC2, it is known as instance. Instance is a terminology that is being used. And generally, you will hear people saying that, hey, can you create or launch an instance for this particular project? And when you say launch an instance, it means generally EC2 instance. There is another concept of AMI, which is something you will hear a lot. AMI is nothing but Amazon Machine Image, which is nothing but a pre-built OS along with software template that you can pick when launching an instance. Okay. Also, I would like to highlight that instances that you create are of different types. Okay. You can select the kind of CPU you want to have, RAM you want to have, the network, everything. Okay, so the CPU power and everything you have the option to choose. There is another concept of EBS. What is EBS? EBS stands for Elastic. So one second, Elastic Block Store. Now what is this? So whenever you create a EC2 instance, okay, you would need a storage because you're going to run or host your website on it, right? So EBS is nothing but a persistent block storage that you can attach to an instance, and you can think of it like it behaves like a hard drive. And it basically it helps you save your data. Okay, so these things is something that you will hear very often. So I thought I should give you an overview. Now let me talk about where EC2 instances can be used. Okay, so what I will do is I will simply paste something over here. Okay, so yeah, this is something that you should be aware of. So okay, so where all EC2 instances can be used? So EC2 instances can be used for hosting apps
or APIs. Okay, so if you have a application that you want to host somewhere, you can make use of EC2 instances. And also if you have some backend application ready, which is exposing the APIs, you can make use of EC2 instances. They can be used for running batch jobs, scheduled tasks, or even background workers. So for example, there might be some periodic tasks that you might want to run. You might want to do data processing. You might want to have ETL jobs, scheduled cron jobs, video transcoding, all of this. Okay, so for all of this, you can make use of EC2 instances. Machine learning. Okay, EC2 instances are really helpful in machine learning field as well. When you're doing machine learning, if you want to train an AI model, right? So you can make use of EC2 instances. Also, they can be used to set up dev and test environment. So now what we can do is, since we have understood EC2, what EC2 is, let us head over to our browser and let us try creating an EC2 instance. So here, if you come to the home page, or just type in the search bar EC2, okay, and you will see this service, virtual servers in the cloud. So select this EC2 over here, and you will be taken to this particular page wherein you will be seeing all the EC2 instances. So you can see EC2 instances running. So like I told you, instance is the term associated with a EC2. Okay, so whenever you create an EC2, you can see instances everywhere. Launch EC2 instance, or launch an instance. Okay, so instance is nothing but a virtual server. Okay, so there are 0 instances running. If there are any instances running, you will see them running over here. Okay, but I'll come to the dashboard and I'll click on launch instance. Okay, now you can see over here launch instance. So you can we'll call this instance. We can give it a name. So I'm going to say first instance. Okay, first hyphen instance, like so. Okay, now if you scroll down here, you will see application and OS images. Now what this means is, you can see AMI. So you have to select the AMI basically, which is Amazon Machine Image, which will contain the operating system, application server, applications for your instance. Okay, let me zoom in a bit so that you can see this much more clearly. Okay, and if you don't see a suitable AMI below, you can search for the OS images, and you can see there are thousands of application and OS images over here. Okay, and for quick start, it is showing you a few options over here. Like you can select Amazon Linux, Mac OS, Ubuntu, Windows. You can choose Red Hat or Debian. A lot of information, a lot of options you have. In fact, you can even browse more AMIs. You can see there are tons of options over here. You can see community AMIs. So there are quick start AMIs, okay, which are commonly used. Then there are community AMIs, which are public, okay, and anyone can publish an AMI. So this is that catalog. Okay, there are Amazon Marketplace AMIs as well. You can see. So there are tons of options. Okay, and of course there are few that Amazon also recommends. So you can choose from here the filters and everything, and I hope you're getting a gist of how vast this can be. So what we can do is we can select Ubuntu over here. Okay, I'll choose Ubuntu, and once you select Ubuntu, you are going to see here AMI, and if you click on this, okay, you will see different variations over here. So we'll make sure that we select free tier eligible option over here. Okay, because we don't want to get charged over here. And if you scroll down, you will see the architecture and everything that you can choose over here. Publish date, it's a verified provider. And if you scroll down here now, you have an option to choose your instance type. Okay, instance type meaning what sort of capacity and everything you wish to have. You can click on info and read more. Okay, instance type allows you to select your computing, memory, networking and storage needs. Okay, so based on what sort of computing you wish to have. And if you click on this, you're going to see T2 micro. This is having 1 CPU, 1 gig of memory. Current generation is true, and you can see there. This is everything related to pricing. If you scroll down, there are more powerful ones as well. So you can see this large one wherein you get 8 cores, 8 CPUs, 32 gigs of memory, and some pricing over here. If you scroll down, you have larger ones as well. Okay, so if you want to do some heavy tasks, you can go ahead with this X large, but this will be costly. Okay, this will be costly. So just scroll down. You can explore a bit. Okay, like you can explore. There are a lot of options here. You can see. Okay, so I'll just select the one that is free tier eligible. Okay, because if I select something else here, if you scroll down, you're going to see the cost details. Okay, somewhere over here. Okay, it's not showing me cost details over here. I don't know why. So earlier what used to happen is whatever I used to select, it used to show me cost details. So if I select this, Let me see if it shows course details. No, it's not showing me. So maybe they have updated this, but I'll select free tier eligible over here. Okay, so make sure you do that. Key pair login. Okay, so here you will see proceed without key pair is not recommended. Okay, so it is recommended you can create a key pair over here. That is what is recommended. Now, what is a key pair? Key pair is basically a way that allows you to connect securely to your instance. Now, if you want to learn more about key pair, I have this article from Amazon open over here. This is from the documentation itself, and it says a key pair consists of public key and private key. Okay, and this public key and private key acts as a security credential that you can use to prove your identity when connecting to Amazon EC2 instance. Okay, so understand this. You have this computer. This is your computer. You have this EC2 instance hosted somewhere, right? You want to connect to the EC2 instance from your terminal. How are you going to connect? Of course, entering username password is not a right way. So you get this key pair that you can save on your machine, and using this key pair, you're proving your identity. Okay, and that is how you are authenticated. So that is something you can do. And what I will do is I'll create a key pair. So I'll say create a key pair. You can enter the key pair name over here. Now here, what you need to do is you need to enter the key pair name. So you can say my EC2 key over here. Okay. And you can select RSA over here, and private key format over here. You can see .pem is the extension for OpenSSH, and .ppk is being used for PuTTY. So if you have PuTTY, or if you're making use of PuTTY, you can select ppk. If you're on Windows or Mac and plan to use either PowerShell or inbuilt Mac terminal, then I'll select PEM, and I'll say create a pair. Now, once we click create a key pair, we will be prompted for downloading the key pair. And what will happen is we'll have to save it at a secure place on our system. So I'll just click this. So I've saved the file on my local machine. Now what I need to do is, if you scroll down here, you will have network related settings. So I'm not making any sort of changes over here. Okay, I'll just keep it like this. And you can see this option over here, allow SSH traffic from anywhere. Okay, so this helps connect to your instance. If you want to be more secure, you can basically select my IP over here. So SSH traffic, SSH meaning from the command line, that traffic will be only allowed from your IP, or you can give some custom rule over here, or you can say anywhere. So depending on your requirement, you can select these checkboxes as well. Now, if you scroll down, there is an option to configure your storage. I'm not doing this, okay, because I think 8 gigs is more than enough for me to learn over here. And you can see here on the right hand side, you have all the summary, and here you have some free tier related information here, right? Now with this, what I'm going to do is I'm going to say launch the instance. Okay, there is an option to preview the code as well. Okay, so you can preview the code over here. Okay, so you can see. So this is the CLI command basically that it is showing us. Okay, everything to create the security group, to do everything, to run the instances. I'll close this preview. And I'll just close this, and I'll say launch instance. Okay, so it'll take some time for instance to be created. Okay, we'll hang in there. Okay, it says success initiating the launch. So if you go to instances over here, okay, if you go to instances, you will see that the instance state is pending. Okay, and this is our first instance. This is the instance ID, and you have all this information. So this is public IP v4, and here you are going to see all the information over here. Okay, so we'll wait until this instance state changes. Okay, so after a while, I just hit refresh over here. This is a refresh button, or you can refresh the entire page, and I could see over here that I have my instance up and running. Okay, you can see over here running is the state, and if you scroll towards the right, you will also see tons of information, and I also have the instance public IP over here. Okay, now what we need to do is you must have saved the key basically which you got from Amazon when creating the EC2 instance. You must have saved it securely to a place on your system. Now to connect to an EC2 instance on Windows, what I would recommend is you make use of a tool called bash over here, git bash. Okay, so this is git bash that I have installed, and it allows us to execute commands over here. With git bash, you can easily run commands like SSH. Okay, and it's very easy. See, you have PowerShell and Windows inbuilt terminal, but if you're on Windows, I would recommend making use of git bash, because for PowerShell there is some additional configuration if SSH command does not work, and it could be a little bit overwhelming for the beginners. So what I recommend is you head over to Google, you search for Git Bash installation, and here you can see it comes, you can navigate for Git for Windows. You can navigate to this website, Git for Windows, and you can run this installer. Okay. And then on Windows startup menu, you can simply search for Git Bash, and this sort of terminal will open like you see behind. Okay. So go over here and just install it. Okay. That is what I mean. So Git for Windows is this one. Okay. So you just install it and you will get this Git Bash over here. You can see Git Bash. Okay. So it's a bash emulation used to run Git from command line. Okay. So you can run it like you are making use of Linux or Unix based environment. So I would recommend installing this because it's simpler to set up and it gets you quickly up to speed. All right. Now here, what you would do is, so if you are on Windows, I recommend Git Bash. If you are on Mac or Linux, I recommend using the inbuilt terminal over here. Okay. And also from your terminal, make use of cd command and navigate to the directory where you have your PEM file saved. Okay. So for example, if you have it in AWS folder, just navigate to that folder. And if you say pwd, you will notice that I'm in this directory over here. Okay. I'm in E drive, and within E drive, I'm in AWS folder. So navigate to this directory. Okay. Now, if you say ls, you will see that I have this my EC2 key.pem over here. All right. So we have this key over here. Now, what we need to do is we need to make use of this key to connect to the remote EC2 instance. So what I'm going to do is I'm going to say SSH over here. I'm going to say -I. Okay. And I'm going to add my key name. So my EC2 key.pem. So I wrote my and then I pressed tab. So it auto populated the entire file name because the file is in the same folder. Okay. And then I'll have to make use of the syntax. I'll have to say user over here, user @IP. Now this IP is the public IP of our instance. Okay. Now have we created a user for our instance? Not really, but we get a default user. So you remember when creating the instance, I had selected Ubuntu, right? So when you install Ubuntu, you get one default user, which is Ubuntu over here. Okay. So I'm selecting that over here. If you have selected some other operating system, basically you will have to go ahead with the users, default users for those. Like for example, on Amazon Linux, you will have EC2-user as the default user. On CentOS, you will have CentOS as the default user. Okay, so you have to choose appropriately. I've used Ubuntu over here, and now what I will do is I'll come over here, and here, when my instance was created, you will see something called as public IP4 address. So just copy this public IP4 address, and we'll need to add the IP over here. Okay, so just add that, paste. Oops, so it did not get copied properly. Okay, so I have my command ready over here along with the public IP. I've added all the details and I'll just press enter. Now it's likely that, okay, we did not get any sort of error over here. Okay, the authenticity of host cannot be established. This is, this key is, are you sure you want to continue connecting? I'll say yes over here. Okay, permanently adding this to our host, and you can see I have connected now. You can see Ubuntu @IP. Okay, so I'm logged into my instance. Now I'll tell you something on Mac and Linux. There is a possibility that learners might face an issue wherein they are not able to, run, or they're not able to make use of this key, and they might face permission issues. So in that case, what you need to do is I'll tell you a command that you can make use of. So here, let me say, so you will have to make use of the command chmod 400, and you'll have to add the key name over here. Okay, so whatever is the key name, so key name .pem file. So use this command if you are on Mac or Linux. Okay, this command will be important to fix the permission and allow it to allow your terminal to make use of the PM file. So that is something you can make use of, and once you are done, you will be able to connect it in the same way. Since I'm on Windows, I did not face that issue. Okay, now we can say pwd meaning present working directory. So in which directory on instance we are on? So we are in home Ubuntu. I can say ls to see what all is there in this directory, and you can see there is nothing in the directory. Now what you can also do is you can come over here to your AWS instance. Okay, and scroll right, go inside the instance. Okay, here you will see this option to connect. Can you see this option to connect? So click on this option, and you can see over here there are multiple ways to connect. So EC2 Instance connect, this is one way. Okay, connect using the public IP, and here you can see the default username is already populated. Okay, so that is done. You can connect using Session Manager. Okay, so Session Manager is a feature of AWS System Manager, which provides a way for us to connect to our instances. Okay, so that is something we can use SSH client. So we connected right now and we made use of SSH client over here. Okay, and you can see all the instructions over here as well. You can see all the instructions, right? So you can run this command. So this was the command to fix the permission if your key is not publicly viewable. Okay, so this was the command that I had shown you. So you can copy the command from here as well. You can connect to your instance using the public DNS. So this is the entire DNS. Okay, you can make use of this or the public IP. That is something that you can make use of. And here you can see this command. Okay, rather than typing in everything, you can just copy it from here and you can connect it. Okay, so this is using SSH EC2 Serial Console. Okay, so this account is not authorized to make use of the EC2 Serial Console. So what I would do is I would say manage access, and here I would say allow. Okay, and I would say update. Okay, we encountered an unexpected error over here. Okay, what is happening? So this is not allowed. Maybe some issue with the permission over here. So after enabling, now it's showing that this instance type is not supported. Okay, for EC2 Serial Console. That's completely okay. Okay, all right. But I've shown you how you can connect. Okay, these are the multiple ways in which you can connect over here. And EC2 Instance Connect is also something you can use. So I'll say a public IP, a username is selected over here, and I'll say connect. Okay, the moment you say connect, let us see how this works. So you can see here the connection is being established. Okay, and in a while you will see terminal-like interface over here, right? So you can see, right? So ls is what you can do, and you can also say present working directory. So you are in Ubuntu. So if you want to do some quick troubleshooting or something like that, all right, you can make use of this approach. This is very fast, and you don't need to do any sort of local setup and all. All right. So I've shown you major ways in which you can connect to the to the EC2 instance. Okay. One is EC2 Instance Connect. It connects and shows you a terminal-like interface in the browser itself, as you can see. Sessions Manager is one way. SSH client is what we have seen. Okay. You have some access to ready-made command over here, so you can make use of these commands, and you can run this, right? So I hope this has been useful, and I hope you all have been able to follow along. So it's time that we begin talking about storage on AWS. Now, when we talk about storage, there are different ways to save data in the cloud, and depending on what data you have, for example, whether you want to store files, database, any sort of backups, any sort of app-related data, AWS gives you different storage services. Okay. And storage on AWS is mainly divided into 3 categories. So let me talk about those 3 categories. So number 1 category is which is object storage. Okay, so here I'll say object storage. This is object storage. Then we have the next category, okay, which is the block storage. Okay, and then we have something called as file storage. Okay, so file storage. So all of these are the categories of storage with respect to AWS. Okay, so these are all categories over here. Okay, and when you talk about storage or any sort of storage services, they are likely part of any one of these types. Okay, so let us understand what is object storage. Now, object storage, you can think of object storage where files are being stored, and files are called as objects, and this kind of storage is typically used for things like images, videos, backups, any sort of things. That is where object storage comes into play. Okay, and for object storage, AWS has a service which is called as S3. So it's called S3 over here, like so. Okay, then you have block storage. Now, what is block storage? In block storage, the data is stored in the form of blocks. That is why it's called block storage. Okay, and the kind of service that AWS offers over here is EBS or even Instant Store, right? So here with EBS, what you do is you will attach disk or volumes to your already existing servers, like you have a hard drive. So normally in a computer, you would attach a hard drive to store data, right? Similarly, in EC2 instances, you will attach EBS storage to store the data. So that is what that is a kind of block storage. Then you have file storage. Now for file storage, you have something called as EFS. okay, which is a sort of a shared file system like a network drive or something. Okay, so these are the storage classes that exist. Now let us begin talking about S3. Now what is S3? So S3 stands for Simple Storage Service. Okay, so it's basically a service provided by Amazon wherein you can host objects. Now you can, when I say objects, basically you can store any kind of file like text, images, videos, backups, logs, and so on. Okay, and you can think of it like something called as Google Drive, Dropbox, but in the cloud, and it is built for developers and companies. So you can store any sort of object, any sort of file, any sort of folder. You can create and upload it over there. Okay, and with S3, okay, I'll just add over here. With S3, things are scalable. Okay, so it's very scalable. So whether you need to store one file, 1 billion files, any number of files, it will just work. Okay, it is durable. Now, when I say durable, AWS says that your data has 99.999 times durability, and the nines they use is 11 times. So basically using 9 11 times. So 2 times I've used 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is what AWS says. Okay, 11 nines, and that is what you will hear. So it has it is durable by 11 nines. That is the terminology that you will see being used very, very often. Okay, so that's S3 for you. Okay, and also it's accessible via the internet, so you can access it from anywhere you want. And since it's accessible, you can upload, download, share files using APIs, AWS console. You can make use of CLIs. Okay, now talking about a few S3 related concepts, I want to highlight a few S3 related concepts. So first one is the concept of bucket. So when you're working with S3, you will often hear this term called bucket, S3 buckets. Can I get the S3 bucket name? Can you create a S3 bucket? So these kind of terms is what you will hear very often if you are making use of S3 in your organization. Now, what is a bucket first of all? Bucket is like a container. It's like a folder at the root level in S3, and that is what is called as bucket. Okay, and every file you store in S3 must go into a bucket. Each bucket must have unique name across all AWS services, like across all of AWS, not across all AWS services, but across all of AWS globally, right? Now let me give you an example for this. Let's say I create a bucket saying my bucket. This is my bucket name. Let's say I create. Now, if some other user has already created a bucket with this name, AWS won't allow me to create this bucket, or AWS won't allow me to create a bucket with this name. Even though a bucket with this name is created by another user, AWS still won't allow me to create a bucket with this name, because this name for a bucket is already being used by some other user. Okay. So it's not like bucket names should be unique in your account itself. Bucket names should be unique across all AWS buckets globally, across all users or within all users account. Okay, so that is something that you need to keep in mind. Okay, and yeah, buckets are also region based. So this S3 service is region based. So whenever you are creating a bucket, you have to make sure you select the region as to where this bucket is being created. Okay, so yeah, this is about the terminology bucket that you will hear often. And inside bucket, now bucket will have objects. So inside bucket, you will store something called as objects. So let me reduce the size of this, something like this. And inside buckets, you will have objects. Okay. Now, what are objects? Objects are nothing but your file, your metadata. Okay. So object will consist of your file and metadata. So let me say object is equal to file plus metadata. Now, what is metadata? Okay. Metadata is some information, extra information about your object, like file type, permission, last modified date. So any sort of information like file name, all of this forms the metadata. So object is nothing but your file plus the metadata around it, right? So I hope this is giving you some sense of what S3 is and how it functions. So S3 basically is a short form of simple storage service that is provided by Amazon. It is highly scalable, durable, and it has this concept of buckets wherein you create containers to store objects. Now objects can be of any type, like it can be a photo, a file, image, video. You can just upload it to an AWS bucket that you create. An object has two things. One is your file and the metadata. Okay. So I hope this is making sense. And when it comes to S3, you can think of bucket as nothing like a folder. Okay. Bucket is nothing but a folder, and object is nothing but a file. Okay. So yeah, this is about S3. I hope this is giving you a sense. Now I would recommend to get hands-on with S3. I would recommend you come over to the console and search for S3 over here. Okay, not S4, but S3. So here you will see scalable storage in cloud is how AWS describes it. Okay, and you can see top features like buckets, storage lengths, batch operations, express one zone. Okay, I'll just select S3 right now, and we'll try creating a first bucket. Okay, all right. So I do have a couple of buckets already created over here. Okay, one bucket I believe I had created some time back only. All right. But if you are like if you have not created any buckets, you won't see any buckets created. And here you can see all the regions. Okay, so depending on where you are based, I'll just select North Virginia region over here. Okay, and what I will do is I will try creating a bucket over here. Okay, so you can see these buckets are located in Europe region. What I can do is I can get rid of these buckets if I want to. I can say delete. Okay, and this is going to delete the bucket. You can see confirm deletion. So it's asking me to confirm deletion, enter the bucket name. Okay, the bucket name is dangerous. So I'll just enter the bucket name after copying it. I'll also delete this one. Okay, so this is also a dummy bucket that I'll try to delete. So this is deleted. Okay, now what I will, so if you don't have any buckets, it's likely you will see this kind of a page. So you can see create a bucket for every object in S3. Every object in S3 is stored in a bucket. To upload files and folders in S3, you will need to create a bucket where the object will be stored. So it clearly says that objects cannot exist without a bucket. So bucket is a container that will hold it. And here you can see the pricing as well. There is no minimum fees. You only pay for what you use. Okay. And the prices are based on the location of your bucket. So you can click on view pricing details over here, and you can see the kind of pricing over here. So you can see the storage pricing in North Virginia region, and you can compare basically where all you get the cheapest price for your bucket. Okay, so it won't change much. Okay, but you can select the cheapest region based on your requirement. I'll just select Northeast Virginia. Okay, and I'll say create a bucket. Okay, so I'm in Stockholm. I don't know why I'm getting switched. So I'll just say North Virginia, and I'll try to create a bucket there. So you can see AWS region is North Virginia, general purpose bucket. Okay, and I'll give this bucket a name. So I'll say my bucket. Now it's likely this is not a unique name. So it's likely some other user must have created a bucket with this name. And you can see over here a message, bucket must be 3 to 63 characters and add a unique name. It must be unique within global namespace, which means the bucket name that you are entering should be unique across all AWS users, right? And it must also begin with a letter or a number and valid characters. These are some rules basically. Okay. And here you can copy the settings. If you have an existing bucket, you can copy the setting from those bucket. All right. Here you have some ownership related information. So here we have said ACL is visible, which is the default one. So I'll keep it like this. Block public access setting for this bucket. So one thing you need to understand is, do you wish to grant or enable public access to this particular bucket? Okay, so I'm saying block all public access. Bucket versioning. So here, so you can uncheck this if you want to enable public access. Okay, but I'm just keeping it checked. Bucket versioning. Versioning means keeping multiple variants of an object in the same bucket. So if you're using services like Git or Dropbox, you will know they keep versions of your files. Right, so you can enable bucket versioning over here. You can add tags if you wish to. You can enable encryption and a bucket key as well. Okay, so something like that is what you can do. I'll also I'll keep this public access disabled. I'll say create the bucket. It's likely it won't allow me to create because the bucket with same name already exists. So I'll say 7007, something like this. My bucket 007. Does it exist? Okay, it exists. So 7123. Let me see if it exists. Okay, failed to create. The specified bucket name is already taken. All right. So I'll say 9929963. I'll enter some random name and let me see if it allows me to create a bucket with this name. Okay. So it allowed me to create a bucket with this complex name. Okay. Which is good. Okay. And now what I will do is you can add a file over here. Okay. So you can add a file. So here what I can do is here on my local machine. Okay. Let me do like this. Here on my local machine, I have this hello text, right? Hello text. So this is a normal text file. What I will do is I will say upload and let me see if drag drop interface works over here. So I'm not sure. Okay, it works. So I've not done drag drop ever. So I was not sure. I've literally like clicked on upload whenever I wish to upload the files. Okay, so you can see over here, it's uploaded and you can see over here, add files and folders you want to upload to S3. To upload a file larger than 160, use AWS CLI or SDK or REST API. Okay. So I've added one file, hello text. And here you can see the destination is this. Okay. And you can set the permission over here. You can set the properties. So you can see the property here. This is a standard. Okay. So this is a storage class that you have to select basically. So I'll keep this storage class selected to standard. Now, depending on kind of data that you're storing, there are different storage classes that are designed. So standard is the one that we have, which is designed for frequently accessed data. Okay, so if you want to access your data within milliseconds and it's frequently accessed, you can make use of standard. Intelligent tiering. So you can see data with changing or unknown access patterns. So that is where you make use of intelligent tiering. Infrequent access data once a month. So this is basically some sort of reports that you have created. Okay, and you want to store it somewhere and the access is very infrequent. So what you do is you make use of this standard over here. Okay, standard storage. One zone. So this is recreatable infrequently accessed data once a month with millisecond access. Okay, so this is another one. Glacier instant retrieval. So this is long-lived archive data accessed once in a quarter. Okay, so if there is some data which you don't want to access or access at least once in a quarter or once in a year, there is another storage class. So depending on the kind of data that you wish to store over here, okay, you can select the storage classes and you can see Amazon S3 pricing over here. So if you go over here to Amazon S3, you can see storage and request, okay, security buckets and here. So you can see here you have pricing tiers for different kind of storage classes. So if you are not accessing your data and it is very infrequent, so the cost is very low. You can see the cost is very low. Okay. Archive instant access tier. So this is the cost is very low. Okay. So depending on your storage class, basically the kind of data you are willing to store and how frequent you want to access it, you can choose the appropriate storage tier so that the right kind of pricing is applied to the data. Okay. And you can save a bit depending on the kind of storage class you selected. Okay. So this is very important. If you want more information, you can click on this info over here and you will see the wonderful documentation appear over here. You can see, right? Now, AWS, what they do is they replicate the data across multiple availability zones. So you can see the availability zones, it is replicating the data across, right? And this is to make your data highly available. If one zone goes down or something happens over there, then you have data replicated or duplicated on some other zone. Okay. So that is what this is for. All right. Permissions, I'll just leave it like this. We'll come to that. Don't specify an encryption key and checksums. This is something that I have, I'm not modifying, and I'll just say upload over here. Okay. Now the moment you say upload, okay, it is simply going to upload it to the AWS bucket and you can see your file over here within the bucket. And if you close this, okay, you can see your file appear over here. Now after the upload is done, okay, you can come to the screen, okay, wherein this is where your bucket is. Okay, let me collapse this. So you're going to see hello.txt and you can see the file type and everything over here. All right. Now, if you click on this, of course, you can see the details about this particular file over here, right? You can see the object URL. You can see the entity tag. You can see the Amazon resource name over here, S3 URI. All of these things you can see and they are available at the button click. You can simply copy it. Now what I will do is I'll copy this object URI and I'll try accessing it right from my browser. Now, of course, if I try to access it from the browser, I'm going to see access denied over here. Now the reason it is not accessible is because whatever you upload on S3 is private by default, and you have to make it explicitly available to the entire world. So what I will do is I will come over here, okay, and if you go to the object permissions over here, so this is hello text. If you go to object permission, you will see over here like this bucket has a bucket owner, and it has like all the permissions over here is governed by the bucket owner. That is what it says. So come over here. And what I will do is I will come to the bucket and I'll click on permissions. And here, if you see, when creating the bucket, we had blocked the public access. So this is a setting that we need to access over here. And I'll just say uncheck over here. Okay, so this will basically make sure that everything in the bucket is publicly accessible. I'll save this. It is asking me to confirm. So I'll say confirm like so. Save this. It's saved. And now this won't be enough. Okay, is what I meant to say. So this itself won't be enough. So if you try to access this, it will still won't work. So what I will have to do is I will have to come to the bucket. I'll have to go to permissions, and here I'll have to add a bucket policy. Now to create the policy, I'll say edit over here, and you can see this nice editor opened over here. So AWS makes really easy for us to create a bucket policy. Now what is a bucket policy? Bucket policy governs the permissions as to what anyone can do on this particular bucket and all the objects within it. Okay, and it's typically written in JSON over here. Okay, and it provides access to objects stored in buckets. So you can see over here. So here you can click and you can see policy examples. There will be some policy examples for you to work on. Okay, you can see manage user access, granting read-only permission to public anonymous users, managing bucket using canned ACLs. So you can see this is the dummy policy. So for popular use cases, what AWS has done is they've created some policies over here already. Okay, but what I'm going to do is I'm going to come over here and instead of policy example, you have something called as policy generator as well. Okay, so here we'll generate the policy using this generator. It's a tool from Amazon. So I'll say I'll select over here S3 bucket policy is what we are creating. Okay, now within S3 bucket policy, whenever you are creating a policy, there are different kinds of statements that you will have to add. Okay, now one statement is effect. Now what is effect? Effect mentions whether you want to allow or deny. So here you can see two options. So I'm saying allow because I'm creating a policy that will allow any anonymous user to access the file via the internet, via the browser using the URL of my resource. Okay, so I want to make it publicly available. Why would you want to do this first of all? So imagine if you're building an e-commerce website, you have all the images stored on S3. Okay. Now, if someone accesses the front end or of course the front end will render the images. So those images have to be publicly available, right? There has to be read access that is enabled. Of course, they cannot modify or delete, but the read access should be enabled. So that is what we are doing, right? So I'm going to say effect is allow. Okay. Principal. So you have to mention principal. Now principal is principal dictates who this applies to. Okay, this policy applies to whom? So I'll say this policy applies to everyone. So I'll mention a star over here. Now it is asking me for actions. Now actions is basically the specific permission that you want to add. For example, whether you want to allow download, whether you want to allow the write objects, whether you want to allow get objects, what do you want to do? So I'll select over here and I'll say get object. Okay, so this is the get object. I'll select this. So you will see you have get object. You can select multiple as well. Okay, depending on your requirement, but I'm just selecting one get object. Now it is asking me for ARN, which is Amazon resource name. Okay, so here you can tick all resources if you wish to, or you can mention an ARN in this particular format over here. What I will do is I'll just copy this. Okay, and I'll add the bucket name. So here I'll come to the bucket policy and here I have the bucket name. So I'll just copy this so that there are no mistakes because our bucket name is dangerous, So here I've added the bucket name. Okay. Now after slash, it is asking me for key. So I need to say, apply this like for all the objects within this bucket. So that is why I've added a star over here. Okay. So this is done. And now what I will do is, so the statement is created. Now I'll say add a statement. So when I say add a statement, the statement is added like this. So you can see the principal is star, effect is allow, action is get object, resource is this. There are no conditions and you can remove this as well. And you can add multiple statements over here. So what this tells you is multiple, like one policy can have multiple statements in it. Okay. But I just need one statement since I'm just enabling access anonymous access basically to all the files that are stored in this bucket. Read-only access, right? Get object means read-only access. And now over here below, so you can see over here, the type of policy is selected. Step 2 is added statements. Step 3 is you will say generate policy. The moment you say generate policy, you will get this kind of a JSON which is generated by this tool. So you have to simply copy this, copy policy, come over here, and you can simply paste this. You can see this policy come up over here. Now, this is one way to create a policy. Also, you can make use of the editor over here on the right hand side. Okay, the editor on the right hand. You can say add a statement. So you can see the statement got added, right? You can filter the services S3. So S3 got selected. Okay. Now from S3, what actions you want to enable? So you will say get object over here. So you can see get object, and if you can hover on this and see what this is. So get object grants permission to retrieve object from Amazon S3. Okay. What is get object ACL? So there is a description for that. So I'll just select get object, and you can see get object being populated over here. Add a resource. So what is the resource you want to add? So S3 resource type is all resources or an object, right? So you can add the object over here, right? So I can mention my bucket name. So what is my bucket name? My bucket name is this. Okay, I'll add this, and I can add star also over here. Oops. So star is like this. Okay, this is done. I added the resource, so you can see the resource is added now. Okay, and I don't think anything else is needed. Principal is needed, but there is how do we add a principal over here? Okay, so principal, I'll just go and I'll just add a star over here. Okay, I'll just edit it manually. Okay, so this SID is the bucket identifier or the unique name for, sorry, not the bucket identifier, but the policy identifier or unique name for the policy. So this is given as a statement 1 over here, which is fine. You can edit it if you wish to. So here, and you can say, you can save the changes like this. So you can see the policy is added. Okay, or if you want to add the policy from here, I'll just copy this. Okay, and I can come over here and I can say edit, and I can paste the policy like so. Okay, so depending on from where you want to, like how you want to create the policy, you can basically create it and generate it this way. So the bucket policy has been added. Also the permissions have been updated, permission settings. Now we'll come over here and let us try refreshing this. So the moment you try refreshing, you will see hello over here because hello.txt has hello inside. And now with this, you can see how you are able to access the file from the browser. And this is not only from this account over here. If you open something incognito or something like that, so I'll just open incognito mode over here. Okay, and you can see you can access this file from anywhere in the world. Okay, so this everything in this particular bucket is now going to have public read access. What is public read access? Public read access is anyone, any person, anywhere in the world can get access to the file over here. So I hope you are able to follow along, and I hope this was useful and you enjoyed learning about S3. So do you know you can make use of S3 buckets to host static websites? Let me show it to you. Okay, so here you come to bucket, and here inside the bucket, once you come in, you have something called as properties. So click on properties, and here you will have different properties of buckets. So scroll down, and here you will see one property which is static website hosting. So you can use this bucket to host a static website or redirect request. Okay, now this is disabled, of course, so I'll go ahead and I'll enable this over here. Okay, and here what you can do is you have to specify the index document. Now we don't have a HTML file, right? So what I'm going to do is I'm going to get a HTML website created, a very basic one. Okay, and for that I'm not going to type out the entire website. I'm going to come over here to ChatGPT or any other AI tool you can make use of, and I'm going to say, hey, can you give me a simple one-page index.html which displays a greeting. Okay, and I'll also mention don't complicate, keep it simple. Okay, so it is going to generate this index.html for me. So you can see over here, it's saying greeting page and welcome to my page. So I'll copy this code. I'll come over here. Okay, and here I will right click and I'll create a new file over here. I'll create a new, I'll say new, right click. Okay. So I have an option for text document. So I'll just select the text document and later we'll change the extension. So I'll say index over here, index.html, and I'll just get rid of this txt over here. Okay. Do you want to change the extension? Yes, I want to change, and I'll right click. I'll say edit in Notepad, and here in Notepad, I'll just paste the HTML code that I had copied. Okay. And I'll just say Control S. So this is completely done. I'll just close this Notepad. Now, if you open this to the browser, if you drag drop this in the browser, you will see this is the website. Hello, welcome to my page. Okay. Now what I will do is I will get this uploaded over here. Okay. So I'll say index.html over here. Okay. This is the index document over here. Okay. And then what I will do is I will save this. Now keep in mind this index.html is not yet uploaded to S3. Okay. But I'm still saving the changes. Okay, the changes are saved over here, as you can see. And you can see here, I got the bucket website endpoint. So if you try to access this endpoint, you will see the website page being rendered. Okay, but we have not uploaded index.html. So I'll quickly open this in a new tab. Okay, and what I will do is inside the bucket over here, I will upload this index.html. Okay, so this is added now. You can see. Okay, this is uploaded. I'll say upload. So this is uploaded. You can see over here. All right, this is done. And now if you come to 1 second. So what happened? If you come to S3 bucket, general purpose bucket, and over here, if you go, okay, so you can see there are two files now, hello.txt and index.html. Now here you got this link basically for the website. So if you click on this, let's click on this. Let us see what it renders. You can see it rendered the index.html page over here. You can see. So our website that we just created has been hosted on S3 bucket. Okay. Isn't this amazing? So quickly recap of the steps that we did. We basically uploaded index.html, which is a basic HTML file. Okay. Of course, you can have CSS and everything over here as well. Okay. In the folder. You can create a complex website, that's completely fine. But I have just, for the sake of demonstration, I just have index.html. I'm making use of S3 bucket static web hosting feature. I enabled static web hosting. I mentioned the file over here, which is index.html. Okay, this is the default page of the website. And then I got this bucket URL, bucket website endpoint. I access this and I'm able to see the website being rendered. Okay, I hope you got to learn something over here and I hope this has been useful. Now let us talk about bucket versioning. Now what is versioning basically? Versioning is a way wherein S3 bucket keeps multiple versions of an object in the same bucket. So if you're using services like Dropbox, you normally get access to versions of your file. Okay, if you're making use of GitHub, you get the versions of your source code, right? So here in S3 also there is a feature. So go inside your bucket and go to properties, and here you will see this property called bucket versioning. And versioning means keeping multiple variants of an object in the same bucket. Okay, so I'll say, so here you can see first of all it's disabled, right? So I'll say edit and I'll say enabled, right? And I'll say save over here. Now the moment I save over here, and if I come to objects over here, I have hello.txt file over here. So let me select this, and here I'll just drag drop hello.txt. So let me drag drop hello.txt again. Okay, and I'm uploading hello.txt like so. Okay, so you can see hello.txt is uploaded now, and I'll go to my bucket now. Let me go to bucket. Okay, so within bucket now, if you go to the object over here, hello.txt, because this is a file I just uploaded. Here you will see versions tab, and if you click on versions tab, you will see this is the current version with this ID. Okay, and this is just uploaded. The earlier version ID was not there because there was no versioning enabled at that time. Okay, but you can click over here and see that version as well. Okay, this is the previous version of the file. Okay, so depending on when you enable versioning, you will have different versions of the file that S3 is keeping a track of. And the best part is you can restore old versions, undelete files, keep audit history as to how things have changed over a period of time. So all of that can be done with the help of bucket versioning. And this is indeed an important feature like you must be thinking about. It basically prevents and protects you against accidental overwrites, deletes, and if there is something important that you're working on and you don't want to lose your work, okay, with accidental overwrites or deletion, you basically have this feature to your rescue. And of course, I would like to mention that if you enable versioning, it is going to cost you slightly more because it is going to store multiple versions of the file, right? So here it is keeping track of multiple versions of the file, which means it is storing multiple versions of the file, and hence it is going to cost you a little bit more over here, right? So yes, this is something that you should be aware of, and I hope you are clear on this concept of bucket versioning. So now is the time that we begin talking about Amazon RDS. Now what is RDS? So it's a service which helps you store your data into the database, okay? And RDS over here stands for Relational Database Service. So Relational Database Service. That is what it stands for over here, okay? That is what RDS is. And what it provides is, so it provides SQL databases, okay? And if you have like SQL databases, if you want to store your data in SQL databases like PostgreSQL, MySQL, Microsoft SQL Server, you can make use of Amazon RDS and host it in the cloud, okay? Now, Amazon RDS is a managed relational database, okay? What does managed mean over here? Okay, so I'll just explain managed. So it's a managed database service. Now, what does it mean? So normally when you set up a database server, there are tons of things involved. Like for example, you will be installing the database software, you would be patching updates, you would be monitoring your server, you would be backing it up, right? You would be creating backups. You will scale up and scale down the storage depending on the need. So all of this you have to do in a server that you set up, right? But with managed database service, you don't have to do all of this. And with AWS, Amazon takes care of all of that. Okay, so installing database software, updates, everything. You just have to focus on your data and your application. Okay, so what this means is it's completely managed by AWS. And when you want to create or set up a database for your application, you just do few clicks on the AWS console, and then you have your database up and running in the cloud. Okay. And there are things like you can manage backups, you can like AWS automatically will back up your database. You don't have to do it yourself. Okay. But backups will be done. There will be high availability because you have a setting wherein you can enable multi availability deployment. Okay. And that will make sure like your database is highly available. You can scale your database anytime. You can secure it, and you can make use of multiple database engines like MySQL, PostgreSQL, Oracle, SQL Server. You can even make use of Aurora. Okay, so that is what Amazon RDS is. Now, what I will do is I'll come over here to our console, and here what we are going to do is we are going to create a simple instance of Amazon RDS, and let us explore this service as well. So you can search for RDS over here at the top. Okay, and you will see Aurora and RDS, and this is Managed Relational Database Service. Okay, so you will click on this, and the moment you click on this, you'll be taken to the console page wherein you are going to see like if you have any sort of DB instances running. Okay, so we don't have any sort of DB instances running. Now, if you scroll down a bit here, you're going to see Create a Database option. So just click on this, and the moment you click on this, you're going to see a form which will help you choose all the configurations that you need for the database. Okay. So of course, there are two ways in which you can create the database. One is standard create, wherein you will set all the configuration options, including the availability, security, backups, maintenance, everything. And easy create is to create the database with minimal configuration. Okay, so AWS itself will use recommended best practice configurations, and it will quickly get you up to speed. Okay, so you can choose standard create or easy create. I'll just keep standard create over here. We can see engine options over here. Engine options, there are different database engines that exist. Okay, so you have MySQL, Oracle, PostgreSQL. There are tons of options that are available over here. I won't say ton, okay, but there are a good number of options available. So I'll just scroll down and I'll show you all the other options as well. So you can see over here, show only versions that support multi-EZDB cluster. So you can basically enable that option. You can select the version of PostgreSQL. Okay, and you have different templates now over here. So what are you creating this database for? Are you creating it for production, development, test environment, or you are making use of free tier? So if you select production, you will have this kind of a cluster deployment or instance deployment that will happen. So write, read, endpoint, there will be standby. So this kind of a structure will be deployed. If you select multi AZ database cluster, this is how it will be deployed, and there will be 3 instances that will be done over here. Okay, so depending on your choice, you can choose, and here you have different options as well. Again, you can select your database cluster identifier, your username that you wish to have, and you can have the password as well. So you can create your own password over here, or you can have password managed in AWS Secrets Manager, which is like highly secure. Okay, you have DB instance, you have like storage and everything, you have connectivity details over here. So a lot of configuration. Okay, a lot of things. It's a huge form that you need to put in, and you can see the total cost over here. This is estimated monthly cost for me. Okay, the reason is I've chosen production setup over here. Okay, so here if you scroll up, here I've chosen production. If I choose dev test, that is going to update, and if I choose free tier, it is going to be free over here. So you can see single instance with single one deployment, and over here if you scroll down, it's going to be free for me. You can see there is no cost. Okay, so what I will do is I'll instead of filling in this long form for demonstration, I'll select easy create option over here. Okay, and I'll select MySQL over here, and MySQL is free, so I'll select free tier here. Database identifier, I'll enter. So database 1 is good. Master username is admin. That's fine. And here I'll say self-managed, and you can get your password auto-generate. Okay, and you can view your credentials after you create the database. Okay, so these credentials, like the master username, whatever you're setting, and the password that gets auto-generated, these 2 things you will need along with the RDS instance URL. Okay, so I can say create database. Okay, I'll create the database. So it will take some time for the instance to be created. We'll wait for a while. Now you can see over here, my database is created and it is configuring. So you can see the status changed to configuring. It is configuring the database and all. And you can see over here, RDS has created the database and master password during database creation. And it will be displayed in the connection details. So I have to say view connection details. And the only way to view your master password is to choose view connection details during database creation. Okay, so later on you cannot. So basically what you do is you click on view connection details and copy the connection details and save it somewhere. Okay, I won't be disclosing my connection details because it's sensitive and you are not supposed to share this information with anyone. So basically get your connection details and store it somewhere safely. So if you click on view connection details, this is what you are going to see. Okay, and my password is hidden. So I'll just copy all of this and I'll store it somewhere. So I've saved all this information now, and I'll just hit close over here. Okay, so here if you see the status, there is still like modifying status. Okay, it's not available yet, but you can see all the database information over here, database related information, right? So yeah, this is how you can get the database setup. Now it will take some time for database to be available, but that's completely fine. We are done with the setup. So now you can see my database is also available, and what I would do is I would try connecting an application to my database. So I'll come over here to IntelliJ IDEA. So I'm clicking on create a new project, and you can see this is what I'm filling in. Okay, Java, and instead of Gradle, I'll make use of Maven. And yeah, rest all is looking good. I'll select latest version of Java over here, and I'll say next over here. And here, this is IntelliJ IDEA Ultimate. So if you don't have IntelliJ IDEA Ultimate, you can make use of Spring Initializer, which is start.spring.io, or you can even create a Python-based application. Okay, the goal is just to show you how an application can connect to RDS instance. Okay, the application frontend can be anything. Like it can be Node.js. You can make use of Springboard. You can make use of Python. It's totally your choice. I'll make use of web over here. I'll make use of GPA. And I'll make use of, since our database type is MySQL, I'll make use of MySQL driver over here. I'll say I think this is it, and I'll say create over here. So it will create the entire process, set it up for me. All right, I'll come over here, and it is loading everything. Okay, now what I will do is I'll come over here quickly, and here in the resources we have application.properties. All right, and what I've done is here in form.xml file I have added things like MySQL connector. Okay, I missed one dependency, which is GPA. Okay, I have added GPA. So GPA and MySQL is added. Okay, MySQL connector is added. So what I will do is I'll add quickly database related connection details. So I'll say Spring. Data source and URL over here. Okay, so this is going to define the URL. Now URL is going to be in this format. Okay, GDBC. Okay, GDBC because this is the protocol. I'm going to say MySQL over here. Okay, and then after saying MySQL, I'm going to have the hostname added over here. Hostname followed by the DB. So hostname is basically our RDS instance hostname. So come over here. I'll just collapse this, and you will have this endpoint over here, the database endpoint. So come over here and just get this over here, and you can basically have a demo DB over here, something like this. Okay, so this is done. Now here I'm going to add a username over here. Okay, so I need a data source username. So this is the property. I'm going to say admin because admin was the username. I'm going to say password over here. Now password is also data source dot password. Okay, so data source password, and this is going to be the password that you had copied. Okay, when you created the database, and I'm going to say driver name over here, or so driver name. I think that might not be needed. I'll just specify dialect over here. Okay, so dialect. So this is the property GDBC. Okay, GDBC dialect, but it will be GPA. Oops, so this is not the right property. 1 second, so I'll just get rid of this. It's Spring. I'll say GPA dot properties dot I'll say hibernate dot dialect. So this is the property. Okay, and I'll say org dot hibernate dot dialect dot MySQL dialect, something like this. Okay, so this is done, and I don't think anything else is needed. Username, password, and everything we have. So password I'll add. Okay, so I'll just add the password. So password is also added. Now let me run this application and let me see what is happening. Okay, are we able to make a connection? What happens? Let us see the output. Okay, there's literally nothing in the database. Okay, but ideally it should be able to make the connection. Let us see if it's not able to. So now when I run the application, I get this kind of an error. Okay, I get this kind of an error. So this is basically happening because RDS is blocking the connection. Okay, it's not allowing the connection. Why is it not allowing? Because our database is not publicly available. So this is something we missed. So when creating the database, there is an option to enable public accessibility for your database, which of course after creating the database also you can do. So you have to make sure the database is selected, click on modify, and you have to scroll down over here, and here just below connectivity there is additional configuration. So you have to make sure that this database is publicly accessible. Okay, and then what you do is you continue and you modify. So you apply immediately, not in next scheduled maintenance window. You will apply immediately and you will say modify the DB instance. So this is going to modify the database instance for you. Okay, and if you go to database, okay, you have this connection. Make sure this is added properly over here in application.properties. There's no issue as such. Okay, and let me restart the application. Okay, let me restart the application. So let us see if it connects now. Okay, so now if you see the logs, you will see that it allowed this time, but it's saying unknown database DemoDB. Of course, it is going to say that because we are trying to connect to DemoDB, and DemoDB does not exist. Okay, so what we need to do is we need to get DemoDB created. Now, either you can make use of CLI to do this, or what you can do is you can basically connect using a graphical user interface. So I already have MySQL Workbench installed onto my system. So you can either install it or you can, make use of CLI. So I'll prefer this. So you can say create a new connection,
and here you will say RDS demo, like so. You can mention the host name. So what is the host name? We'll just copy the host name from here. Okay, I've copied this, and host name is over here, 3306, and username is admin. Password. So I'll just say password over here. I'll just add the password here. So I added the password by clicking on store in vault, and I'll say test connection. Okay, let us see if the connection is successful. So you can see connection successfully made. Okay, I'll say okay. I'll say okay over here. So this is RDS demo. I'll just connect it to this instance. So now what is happening is via MySQL workbench, I'm connecting to RDS instance. Okay. Now, if by chance you have not selected MySQL as the database engine, and if you have selected PostgreSQL, you have to make use of pgadmin. Okay. So there are different tools for different database vendors. Okay, or different database engines. Now here you can see sys is there. Okay, sys is there. So what I will do is I need to create a schema because I need to create the database, right? So the database name is DemoDB. So I'll just take this and I'll add DemoDB over here and I'll say apply. Okay, so this is applied. Finish. Oops, what happened? It's not allowing to create schema DemoDB. Okay, operation failed. So this is currently busy. Is that so? But here at the bottom it says changes applied. So let me do a refresh over here and let me see if this is applied or not. Okay, it seems it's not applied. Okay, so I tried executing this after a while and it worked. Okay, but the problem is I did not add the underscore over here. I missed that. So, okay, so I'll add the underscore here, something like this. Okay, and I'll say apply here. I'll say apply. Okay, so maybe there was some connection issue and maybe it was busy or not accepting connection at that time. Okay, so you can see there are a couple of databases or schemas that have been created. I'll delete the one without underscore, drop schema, and I'll say drop now. So this is drop now. Okay, and I have this one now. So I'll just do a refresh. Okay, so this will take some time. Maybe it's connecting to the instance, and our instance is very basic. Okay, it's in the free tier. Okay, so yeah, limited capacity, but it's working fine. We are able to connect, and I tried deleting this, but it will take some time, and it's deleted now. You can see. Okay, now let us run the application. So we have the database now inside RDS instance. Now actually it should work absolutely fine. So we'll wait for a while, and you can see there are no issues as such. It is able to create the connections, no issues as such. You can see over here, right? You can see. And from here, what I can in fact do is I'll add Lombok over here. Let me add Lombok here. Okay, so I'll say Lombok. Okay, Lombok is added into my project. Okay, now I'll come over here and I'll create a new Java class. I'll call this as student. Okay, and since I have GPA and everything configured already, I'll mark this as an entity over here, like so. And here I'll say private long ID over here. Oops. And I'll say private string name. Oops. So private string name. And okay, this is giving an error. So what is the error? Okay, it should have an ID attribute. It has ID attribute, but I'll mark this as ID and I'll say generation value. Generation value is strategy. So strategy should be identity. Okay, so this should be enough. And let me run this now. So we should have this student table being auto created now in our RDS instance, right? So let us see this. Okay, so you can see, okay, so you can see no issues as such. If you come over here, but if you come over here, let me do a refresh. I did a refresh and I don't see any sort of tables here yet. Okay. Okay, no sort of table yet. So let me also enable SQL. That will give some more clarity. Okay, so what I will do is I'll come over here. Okay, somewhere over here. I'll say spring dot jpa dot show SQL true, like so, and let me run this. Okay, so this should ideally work. I'm not seeing the table yet, so it's because maybe I am not adding a property over here. So I'll add a Hibernate property which will ask the database to be updated whenever there is any change in the entities. Okay, so what I can do is DDL, it's called DDL
auto. So Spring Hibernate TDL auto, and I'll just say update over here. Okay. So you could see different values there. Okay. You could see things like update the schema if necessary. So this is not present. So let me run it with update over here and let us see how it behaves. Okay. So ideally it should create this time. Let me see what happens. Okay. Connection is created. You could see the connection was created. And here, okay, query I'm not seeing printed over here. Connection was created. JDBC URL is being created. Everything is being created. Okay, now you can see tables over here. Okay, so I'm not sure if it was created with this run or it was created in the previous run. Okay, maybe it was created in the previous run and it took a little bit time to reload this. Okay, but neither whether it was created or not, we anyways had to add this property, because if we do any future updates to the entity, it should be reflected in the database. And you can see over here the columns and everything being added. So this is clearly coming in from our application. Now we can develop this application, we can add controllers, service, and it is straight away talking to RDS. Okay, it's not a good practice to hard code the database connection URL this way, including the username, password. So password I have not hard coded, but username and everything, it's not a good idea. Like URL also should not be there in the properties file. But since this is a demo, I'm just demonstrating things. Okay. And yeah, this is working absolutely okay. Now you can create controllers and play around with this, and it is going to give you all the data from RDS instance. And you can of course take this front-end like backend application. This is actually a backend application. You can take this and deploy this onto an Amazon EC2 instance as well. All right. So yeah, I hope this has been useful, and I hope you all have enjoyed this class. Now, if you're creating services on Amazon, it's also important that you delete everything that you're creating so that you don't get billed unnecessarily. Okay. So I'll select the database over here. You have an option to delete the database. You can see delete, stop temporarily. So I'll just stop it for now. Okay. So it's telling me I acknowledge that stopping the database only pauses the billing for instance hours, and DB restarts automatically on this date. So do you want to do this? Because you're stopping it temporarily and it will automatically start. Okay. So whether you acknowledge that or you don't acknowledge that, so you can basically, here you see it is stopping only for 7 days. So you can stop or you can delete it. So I would prefer deleting it right now. If I need another instance, I will create an instance later on. Okay, but I'll delete it right now so that I'm not billed unnecessarily. I don't want to, get billed unnecessarily. So I've deleted the database. What I can also do is I can go to S3, or I can go to EC2 over here, EC2 instance, and I do have EC2 instance also created over here. So I'm going to select the instance. Do we have instance running? No, we don't have anything over here. Do we have S3 bucket? So we have few S3 buckets, or one S3 bucket, I would say. I can delete that as well. Okay, so let me delete that, and you can delete the, okay, bucket must be empty before you delete it. So come over here, empty the bucket. Okay, so delete, loading the objects, and to confirm, I'll say delete. So you can see there are multiple steps if you're deleting something. Okay, there are multiple steps, and you come back over here, general purpose buckets. I'll select this, I'll say delete. Okay. And okay, bucket is not empty. How come it's not empty? It's empty, right? It's empty. So I don't know. Or maybe it was not empty at that time, but now it should be deleted. Okay, empty bucket. So let me see what's the problem. Okay, permanently delete. So I'll type in permanently delete and I'll empty this. Okay. So yeah, this is how it should be. So if you come over here, okay, if you select this, delete, this is being deleted. So I'll say enter the bucket name and I'll say delete the bucket. So bucket is also being deleted now, and the bucket is deleted. You can see over here. Okay. So RDS instance, S3 bucket, whatever you have, you should delete it. That is really, really important. Otherwise, AWS charges pay per usage. Okay. So AWS will assume you're using the services and it will keep on billing you. That is something that we don't want to have, and we want to avoid that, right? So be careful about these things. Also make sure you go and check different regions as well, where in whichever region you are working. Okay. Make sure you don't have any services in that region. Okay.
So now it's time that we begin talking about IP address. Now, what is an IP address? So IP address is nothing but Internet Protocol address. So IP over here stands for Internet Protocol. Now understand this. What is an internet? Okay, let's first talk about this first thing, which is internet. So what is an internet? So internet is nothing but a giant network of networks, right? So it is a huge network which internally has multiple networks within it. So this is one network, this will be second network, this will be third network, this will be fourth network, and within this network there will be machines who will be interacting with each other, right? So there will be machines over here like this, okay? Here also there will be machines, okay? So this outer part is the internet, this inner parts are the networks, and within these networks you have multiple machines. And when I say machines meaning it could be a smartphone, it could be a laptop, it could be a computer, okay? So it would have machines that can communicate with each other within the network. For example, your home Wi-Fi is a small network within your home. Your office Wi-Fi is a network within your office, and everyone connects to it and communicates to the internet. Okay, so that is how it works. So this is what internet is. And then you have protocol. Now protocol is nothing but a set of rules that defines how data is transmitted, addressed, formatted, and routed between all the devices within the network. So that is what internet protocol means. So IP means Internet Protocol. Internet is nothing but a giant network of networks, and protocol means, or protocol defines, or it's a set of rules that defines how data is transmitted, formatted, addressed, transferred, routed between multiple devices within a particular network. Now, we are talking about communication over here, if you notice, okay? So the devices within the network are communicating. So let's say there is one device over here, okay? Let's call it something. So I'll just get rid of this. Let's call it device A. And then you have a device B over here. Okay, so A is communicating with B. Now for A to communicate with some other device or any other device in the network, it should know its address. And address will define how one device reaches out to another device within a network. And it would want to reach out and connect with another device and communicate to transfer data or share something, right? You can think of this like you living in a city and you receive physical mails or physical parcels over here that are delivered by a postman. So for someone to deliver a parcel or some sort of an envelope to your place, he will need your address as to how he can reach out to you and send you something, right? Same goes for emails. If someone wishes to communicate with you or email you or WhatsApp you or whatever, so he is going to need your address or a way in which he can communicate with you. Similarly, here when you have two devices and if they want to communicate, they are going to need each other's address. And this address is known as IP address. So Internet Protocol address. And without IP address, the internet wouldn't know who is sending and who should receive it, okay? And it makes sure that whenever you are willing to access something or see some data or send some data, it is actually sent to the right device and not to someone else. Without IP address, this data would be lost. Now, when we talk about IP addresses, there are two kinds of IP addresses. So the first is IPv4. Okay, this is one type, and then we have another type which is IPv6. So I'll say IPv6. Now, what is the difference between two? Okay, so IPv4 is the old system of addresses. Okay, and if I have to give you an example of IPv4 address, okay, I would type in over here 192.168.1.1. So this is a simple example of an IPv4 address. Okay, so this is what it is. So it is 4 numbers separated by dots, and this kind of system gives with this kind of system IPv4, it's possible to have around 4 billion unique addresses. Now understand one thing about IP address: these IP addresses have to be unique, right? So for one device to communicate with the other device should have a unique address so that this device can talk to only that one and not someone else, right? So IP address has to be unique for every device, okay? And with IPv4 system or with IPv4, which is Internet Protocol version 4, it's possible to get around 4 billion unique addresses. So when I say billion, it's billion for B. Okay. So yeah, this is huge. But today, today the population has increased so much. There are so many devices that are connected to the internet. Like one person will have 3-4 devices, iPad, he'll have a tablet, he'll have a smartphone, he'll have laptop or a physical desktop or multiple devices. So he's going to have multiple devices that are going to be connected to the internet or to any network, and those are going to need unique IP addresses, and hence soon everybody realized that IPv4 might not be sufficient, and hence IPv6 was brought in. Now IPv6, with IPv6 you can have much longer addresses compared to IPv4. So here this is an example of an IP address in IPv6 format. Okay, so you can say it's much more longer, and with this, this number is big, and with this format, it's possible to have a lot of IP addresses, okay, which can basically fulfill all the requirements. Okay, so this is a new system, IPv6, and IPv4 is the old system. Now, if I have to talk about today a lot of them are on IPv4 only, but slowly they are migrating to IPv6. Now, this is the categorization of IP addresses based on the length and the format, but there is one more categorization based on, I would say, the visibility. Okay, so there is a concept, like one more concept. So let me just duplicate this. Okay, so there is one more concept of public and private IPs. Okay, so there is public and there is private. Now, as the name says, public IP means public and private IP means private, right? The name only says this is public IP and the private IP. So what does public IP mean? Public IP means it's global, it's visible to the internet, and everyone can see this IP address. Okay, so basically this IP address is assigned, this public IP is assigned by internet service provider, which is your ISP, and it is going to be unique across the whole internet. And private IP address is private, and it is supposed to be used within the private network, like your home or office network. You might set up a private network. So it's used over there and it is not visible to the internet, and it works locally. So this is about private and public IP. Now let us come to AWS. Okay, so here we spoke about IP address, public, private, IPv4 and IPv6. So how does all this, how do all these concepts relate to that of AWS? Okay, so let me come to that. So AWS has the concept of private IP. Okay, it has the concept of public IP, and it has the concept of something called as elastic IP. Okay, so let us talk about each one of them. So what is a private IP over here in AWS? So in AWS, private IP is a IP that is allocated to every instance that you create inside the AWS. Okay, it automatically gets a private IP, and of course, like I said, the private IP is used for communication inside AWS only, right? And it cannot be used to connect directly from the internet. Okay, so it's private, and that is why it's called private. And when we say public IP, so if you want an EC2 instance to be reachable from the internet, then you assign it a public IP. Okay, and you can also assign it an elastic IP, which I'll come to, but you can assign an EC2 instance that you've created, provided you want it to be reachable from the internet, you can assign it a public IP. And this public IP is going to map to the private IP of your EC2 instance. Okay, and then you have elastic IP. So what is elastic IP? Elastic IP is nothing but a static IP that does not change even if you restart the EC2 instance. So other IP addresses will change, okay, but elastic IP address won't change if you restart your EC2 instance. So if you have any sort of requirement wherein you want the IP address of the EC2 instance to be static, then you can make use of elastic IP address. Okay, so I hope this is making sense. So all these concepts are there in AWS, and for understanding these concepts, it was important that you understand the entire concept of IP address. So let us talk a bit more about networking and understand a few concepts. So there are a few concepts that we'll talk about. So first concept that we are going to discuss is the concept of VPC.
Now, what is a VPC? So VPC stands for Virtual Private Cloud. Okay. Now, what is a virtual private cloud? So let me explain this. So let's say you have a commercial premise. Okay, commercial, residential, or whatever sort of premise. For the sake of example, I'm going to talk about a commercial premise like a commercial office. Okay. Now, within a commercial office, can you directly enter and can you visit any department by your wish? No, there will be security checks, of course. And once you enter the commercial premise, you should have an ID card. If you don't have an ID card, so your ID card will be checked, right? And if you don't have an ID card, you will be assigned a temporary ID card or something depending on the protocol or the rules of the premise. And then you will have access to limited area. So for example, you can access the lobby, the common area, the reception, and you can get your work done for whatever purpose you have visited the office. If you are an employee, you can of course visit directly just with the ID card and you can get inside the workspace. Okay. But even after you are an employee, you cannot access departments like finance department or the server room. You cannot access that because accessing those sort of rooms or those sort of sections within the commercial premise requires special access. You cannot directly go and enter the finance department. You will have you would want the access for finance department. You will need the access for server room if you wish to visit the server room. Right. So these all things come into play when we talk about commercial premise. Now, when we talk about AWS, okay, on AWS you have multiple servers, you will have multiple instances running. So this is one instance. Okay, let's say this is instance 1. Okay, so there could be multiple instances, multiple servers, a lot of things that could be going on within an AWS account or on AWS. Right. Now there has to be some boundaries with which this is protected. So that is where this concept of virtual private cloud comes into a play, right? So VPC is like it's like your own private area inside the cloud. Okay. Now in cloud, there could be multiple instances, right? You have this instance, you have that instance. Okay. So if you want to segregate these two instances from the rest, okay, what you can do is you can set up a VPC. And then you can have these two instances within that particular VPC. So this area is nothing but a virtual private cloud. So this is VPC 1, for example. You can name your virtual private cloud or VPC over here. You can create VPC 2 over here. Okay. And you can add some instances or some resources over there. Okay. So within a particular VPC, you control everything. Okay. And you can think of you're setting up a private thing or a private area within AWS cloud. Now, few things that I would want to tell you about VPC is, so one person will have one account on AWS, and within one account, you can have multiple VPCs created. So this is VPC 1, this is VPC 2. Okay. So you can have multiple VPCs created within one account and they will be completely isolated from each other. They will be treated like two separate networks, but within a single AWS account. Okay. At the end of the day, what is VPC? So VPC is nothing but a separate network that you are setting up, right? It's a separate area, separate network, and you will have resources within that particular network. For example, here I'm showing instances, right? So within one account, you can have multiple VPCs set up, and these two networks could be completely isolated from each other. Okay. Also, if there are two accounts, so of course this goes without saying, if there are multiple people with two separate accounts, they are creating VPCs in their own respective account, they also will be isolated from each other. Okay. So that is something that I would want you all to understand. Now, when you create a VPC on AWS, okay, you will have to specify the range of IPs that you want to be associated within the VPC. So for example, here I'll mention range of IPs. Okay. So when you create VPC, you will have to mention the range of IPs that you want to be associated within that particular VPC. Okay, and this is something that you will have to enter on the dashboard. So now we are clear with the concept of VPC. Now let's talk a bit more. Now when it comes to VPCs, when it comes to networking I should say, when it comes to networking within AWS, there are quite a few concepts that come into play. Okay, so first one is VPC that we spoke about. We have concept of subnets. We have concept of route tables. We have concept of network gateways. Okay, or I should say NAT over here. Okay, and we have concept of security. Okay, so let us talk about each one of them.
So what are subnets first of all? Okay, so I'm just going to have or we can have two VPCs over here. Okay, so I'll just move this towards this side. Okay, I'll make this one a little bit bigger. Okay, now what are subnets? So VPCs can be divided into smaller segments. So let's say this complete thing is a VPC over here. You have multiple resources within the VPC. Now what you can do is you can create multiple areas within VPC itself. Okay, for example, if you think of commercial premise, okay, you have commercial premise over here. Within commercial premise, you will have multiple departments, multiple areas, right? This is the lobby, this is the reception area, this is the finance department, right? Similar way, you might want to have segregation, some sort of segregation within VPC itself. And this segregation or dividing VPC into smaller segments is known as subnet. So this is a subnet, and then you can have one more subnet over here. This is another subnet. Okay. Now subnets are also of two types. So this one is private subnet, another one is public subnet. Now within private subnet, you can have resources. So let's say we have an instance over here. So let's say this is one instance within this subnet, and this particular subnet is this particular subnet over here is private. Okay, let's say this is a private subnet like so. Okay, so if this is a private subnet, what will happen is whatever resources are there within this particular subnet cannot directly communicate with the internet. Okay, so coming again over here. Okay, so this is a private subnet over here. So first of all, VPC can be divided into smaller segments, I said, and those segments are called as subnets, right? Now subnets are of two types. One is private and another one is public. Now a private subnet is a kind of subnet whose instances cannot directly communicate with the internet. So for example, if you have a private subnet, and let's say if this is running an EC2 instance over here, okay, then this instance cannot communicate directly with the internet, because of course it goes by the name itself. Okay, this is private, right? So it won't communicate, it won't be allowed to communicate with the instance because this is a private subnet, right? And then you have another thing which is a public subnet over here, right? So this is public subnet. So public subnet is a subnet whose instances can directly communicate with the internet, and they will do it via internet gateway, which I'll be coming to. Okay, but for now, just understand public subnet is public. Everything, all the instances, all the EC2 instances that you will be running within public subnet can communicate to the external world, but within private subnet, this is not allowed. Okay. Now there will be IP addresses that will be assigned. Okay, so whatever instances are being created within the subnet. So let's say you create an EC2 instance over here in the public subnet. So it will have a private IP as well as a public IP, right? Public IP is optional, but private IP can be used. It is private, right? And it can be used within VPC or between the instances. And the public IP that it would have allows the instances to communicate with the internet. Okay, so that is what the IP address is, or how the IP address works and how the assignment works. So private and public both are the kind of IPs that you will be seeing on the dashboard when you create EC2 instances. Okay, so this is about subnet. So just reiterating, what is subnet? So whenever you divide VPC into smaller segments, it is known as subnet. Subnet are of two types. One is public and other one is private. So this is clear. Now let us talk about route tables, NAT. Okay, so first we'll talk about route tables. Okay, what are route tables? Before talking about, or first we'll talk about NAT gateway. Okay, not route tables. So I'll just reduce the size of this a bit. I'll just get rid of this from here. Okay, and I'll move this to the top, and I'll just increase the size of this. Okay. Now what is a NAT gateway? Okay, so NAT gateway allows the instances in the public subnet, private subnet, to communicate or interact with the internet, or to access the internet is what I should say. That is what NAT gateway is. So along with NAT gateway, there is also something called as internet gateway, which I just forgot. Okay, internet gateway over here, which I can say IGW. Okay, so these both are gateways. Okay, these two are gateways over here essentially. And with gateway, you decide who communicates with the internet and who does not. Okay, so NAT gateway. So here I'll just create a NAT gateway. Okay, so using a NAT gateway, what happens is private subnet instances will communicate with the internet. Now one question you will have is, hey, you just said that the instances in private subnet are private
and they cannot communicate with the internet, then why would you bring in NAT gateway, and why are you allowing them to connect to the internet? So there are few reasons wherein instances in the private subnet might want to communicate with the internet. Okay, there are few instances, so hang in there. So one instance is, let's say if you want to download some sort of dependency, you want to update the software, you want to install a package within that particular instance, you want to do something, or basically you want to bring something from the internet, like downloading, installing, cloning a Git repository within this instance, right? So in that case, you would need access to the internet. Okay, but you won't want the outside traffic to come to the instance in that case, right? So this NAT gateway allows us to do that. Okay, so NAT gateway allows the instances or resources in the private subnet to initiate outbound connection to the internet, like downloading updates, installing any sort of packages, installing softwares, and it prevents inbound internet connection. Okay, I hope this is making sense. So what is the speciality of NAT? Why is the traffic going through NAT in private subnet? Okay, in private subnet, the speciality of NAT is that it allows the instances within private subnet to communicate with the internet. Okay, and the communication is outbound. So instance 1 can communicate via NAT gateway to the internet. Okay, but someone outside, someone on the internet cannot communicate to instance 1 because the IP and everything is masked behind the scenes. It is masked by NAT gateway. So the outsider world won't know that there is an instance behind the scene. Okay, so this is NAT, and we have internet gateway as well. Okay, now what is internet gateway? So internet gateway is internet gateway is basically a component that allows communication between instances in your VPC or within the subnet with the internet. So if there is any instance in the public subnet that wishes to communicate with the internet to and fro, then you will make use of internet gateway, IGW. Okay, so over here, this is public, right? So it can communicate with the internet, and outsider can also communicate with this instance. So both way traffic is allowed, and that is what internet gateway is. Okay, so it basically enables, internet gateway basically enables the internet access to an instance in public subnet. Okay, but NAT gateway on the other hand is allowing only outbound traffic to the internet and not inbound. Okay, I hope this is making sense. And why are we doing this? Why do we have NAT? Because you cannot keep an instance completely private. Okay, you will need an instance, like there will be tasks where an instance might need some sort of software, it might need an OS update, something like that. So how are you going to do that? So only outbound traffic is allowed. IP address will be masked when this particular instance communicate with the internet. IP address is hidden via NAT, and it is not shared with the outside world, so that it's protected because it's private. Okay, so all those things are taken care by NAT gateway, and things are kept private. And outbound traffic is not allowed at all. So outbound is only allowed. Inbound is not allowed at all. So that is what these gateways do, and these two gateways serve different purposes. NAT gateway is generally for private subnet, and internet gateway is for the public subnet. Okay, so I hope this is making sense. Then let's come to the topic of route tables. Okay, now what is a route table? So route table determines how traffic flows within the VPC to and from the internet. Okay, so if this particular instance wants to communicate to the internet, what it's going to do is it is going to first go to route table. Okay, now in route table over here, so let's say this is a route table. This is the public IP over here. This is the so it will have an entry over here wherein if it wants to communicate with the internet, okay, this is the entry over here. Okay, so this entry is going to be within route table. Okay, so let me create a table sorts over here. Okay, so let's say this is a route table over here. I'll say route table. Okay, let's say this is a route table, and let me bring it over here. Let's say somewhere over here. Okay, so I'm showing it over here. Okay, because of lack of space, but this is completely okay. Or I'll bring it over here. Okay, here. Okay, so what will happen is, okay, now instance 1 wants to communicate to the internet. How is it going to communicate? It does not know, right? So it is going to make use of route table and internet gateway. Now how both are being used? Now route table, first of all, is a component that defines a set of rules. These rules are called as routes. Okay, That is why it's called as route table. It holds all the routes. Now what are routes? Routes are nothing but rules that control where traffic from your subnet or gateway is directed within. So basically, how communication happens within this VPC is what is being defined by route table. Okay, so let's say for example over here, this particular instance wants to communicate to the internet, and route table will have the entries in the form of destination and the target. Okay, so this is the destination. Okay, so if the instance 1 wants to communicate with the internet, it is going to come to route table, and there will be this kind of an entry. And what this tells is, if this is what instance 1, or this is what if you are looking for, then you go to the internet gateway. Okay, so from here it will come over here, it will see, okay, this is the entry. So if this is the thing, then I need to talk to the internet gateway. He'll go to the internet gateway, and then from there he'll get the internet access. So it is basically a router in between, which is doing the job of routing the traffic, okay, within the VPC. I hope this is making sense over here. Okay, so what is it having? It is having basically a set of rules, and how the rules are defined, it is defined in the form of destination on the left hand side, and then on the right hand side you have target. Okay, so that is what it defines. Now one question you might have, or people who are not familiar with networking, they might have, is what is this 0.0.0.0, and you are telling me that if the instance 1 wants to communicate to the internet, he's going to come, he's going to look for this 0.0, and he's going to talk to the internet gateway. What is this 0.0? So this 0.0.0, 4 times 0 slash 0, this is not an actual device or an IP. Okay, it is a special notation that means all IP address. Okay, and basically it tells that if it does not match any sort of route, so it's basically a wildcard is what I can say in simple terms. Okay, so it says, okay, so see, if instance 1 wants to communicate with something, it is going to have the IP. Right, let's say if it wants to communicate with some other instance, it is going to have the other instance IP, and there will be an entry in route table which will say like this IP, like IP source will go to IP target, something like that. It is going to have this kind of an entry over here, right? So this is the entry that it will have, right? So if it wants to communicate to some other instance, it is going to come over here. It is going to look for that instance IP, and then it is going to communicate. That is how the communication will work. But if it wants to communicate to the internet, it is not going to have any sort of IP. It is going to come over here. Okay, and if this is the entry over here, it means internet gateway. So that is how it is going to work. Okay, so any other traffic, this simply means that any other traffic or all traffic that is not destined for VPC itself should go to the internet gateway. That is what this line simply means. Okay, so I'll just remove the second line over here. Okay, and I'll add it over here. So this is how route table will function over here, right? And this is a public subnet. Okay, so I'll just extend this a bit. Okay, now here it can be multiple entries. Okay, I've increased the size of this. Okay, but here this is about the example that I gave is for the internet gateway, right? So instance 1 wants to communicate. So how is it going to communicate? It is going to come over here. It is going to look for the route over here. Okay, so something like this. And then this traffic is going to go to the internet gateway, and via there it is going to go to the internet. Now same works in the private subnet as well. So it is going to have a route table over here. Okay, so let me duplicate this. So this is the route table over here. So I just rejigged the diagram and just make it a bit more spacey and clear. Okay, so here I've added route table. Okay, and this is a NAT. Okay, so this is also route, so I should mention over here, this is route table. Okay, now the same thing, the same logic of route table that I explained over here works over here as well. So if instance 1 wants to communicate with the internet, it is first going to look for, it is first going to go to route table, and then from route table it is going to get NAT, and then it is going to talk to the internet. And this is how route table helps in routing traffic within a VPC. So this is about the gateways, which is NAT gateway, internet gateway, and route tables. Okay, now let's talk about security. Now when it comes to security, there is a concept of security groups. Now this is applied at the instance level. Okay, so if you want if you want to regulate some sort of inbound, outbound traffic at the instance level, you can do that with the help of security groups. So yeah, that's about these concepts associated with virtual private cloud.
You will hear these terms very often, and that is why it's important that you understand these terms really well and how things function when it comes to networking in AWS. So now is the time that we begin talking about CIDR. Now, what is CIDR? CIDR stands for Classless Inter-Domain Routing. Okay. Now, before I talk about this, I want to clear out few concepts so that when we talk actually about CIDR, you have a better understanding of what CIDR is. So I'm not going to jump directly to this term, because if you're a beginner, this term might seem a little bit confusing, complex to you, right? So what I will do is first let's talk about a bit about IP address and a structure of IP address. So here I've added a couple of things. Okay. So I've written IP has 32 bits. Okay. So this is an IP address here. This part you see 192.168.1.10. This is an IP address. If you're from a technical background, you might know this is how IP address looks and numbers keep on changing. Okay. So there are a lot of IP address, and I've taken this example. So IP has 32 bits. Right now, what does 32 bit mean? So 32 bit means that here 192. So every separator over here dot. So there are 4 numbers over here in this IP, right? 192, 168, 1 and 10. Now each number is represented using ones and 0. Why ones and 0? Because that is how computer understand things, right? So if you're talking to computer, that is how things are represented in the computer world, 1 and 0, right? So every number over here that you see in this IP address is represented using 1 and 0 in this form. Okay. And every digit over here, like every 1 and 0 is called as a bit. So 192 is being represented by 8 bits over here, right? So 8 plus 8 plus 8 plus 8 is equal to 32 bits, as you can see over here. Okay. So what are we concluding over here? IP address consists of 32 bits. This is important for you to understand. Now this IP address that we were talking about can be divided into 2 parts. Okay. The bits that exist in this IP address can be divided into 2 parts. One is the network bit and other is the host bit. Okay. Before I talk about network and host bit, I would like to mention one more thing over here. Okay. So this representation that I'm showing you over here is of IPv4. Okay. So in IPv4, IP has, okay, I have written hyphen has, okay, there is a typo. So IP has 32 bits in IPv4. Okay. So just to clear out the confusion over here. Now this IP has network bits and the host bit. Now what is a network bit? So network bit identifies which network a device belongs to, and host bits will identify the device itself within that particular network. Okay. So understand this. Okay. Why this is a network. Okay. And there are multiple devices. Okay. There will be multiple devices. Okay. Now this is a network, and we should have some sort of notation over here within the IP itself, or device should have some sort of notation wherein it can represent itself as a part of the network. So within IP, what happens is some bits are used to represent the network itself and some bits are used to represent the host itself. So the network bit will identify which network the device belongs to, and the host bit will make sure it identifies the device itself uniquely on the network. Okay. So for example, if I have to give you an example over here. So here, this IP example that we have taken, I'll take the same one. So if you have the IP with this definition, so 1.x, okay. So let's say here, first 24 bits are network bits and the rest are host bits. Okay. What this means is this part of the IP address, which is 24 bits. Okay. Because 8 3s are 24. Here you have this, each number is being represented using 8-bit, right? So this is 24-bit. So first 24-bit or 24-bit within this particular IP is, let's say it's being used to represent the network. Okay. And the rest of the part, which is the remaining 8-bit, is being used to identify the host. So if you have the IP over here, 192.168.1, so it means that it belongs to this network. Okay. And this host will also have the same IP, and this will also have the same IP. Okay. Only the host details will change. So for example, I'll just give you an example. So over here, this can be 10. Okay. Now this is also the part of same network. So first 24 bits will be same. Now this will be 11.
Okay, and this will be 1, 2. Okay, so X value will change, nothing else will change. So this is the concept of network and host bits. I hope this is making sense. This is very important for you to understand before we talk about CIDR and how IP ranges are being assigned in VPC and all. Now, once you're clear with these concepts, let us talk about CIDR. Now, CIDR stands for Classless Interdomain Routing, and it's a way to specify IP address ranges using compact notation. Okay, so why do we need this sort of notation to specify IP address ranges? Let me explain that. So you create a VPC. Okay, let's say you create a VPC. What is VPC? It's a virtual private network. It is of course going to have multiple devices or instances within it, right? And within a network, so this is a network. Let's say this is VPC itself. Within a network, you will have multiple devices, and each device will have an IP address, right? So which means that this network needs a range of IP address which can be used by devices or resources that exist within this network, right? And for doing that, we need this CIDR notation, using which you can represent the IP address ranges that a network will make use of. Okay, so let me be more clear and let me share how CIDR is represented. So I'll paste something over here. Okay, so this is the representation of CIDR. Okay, so let me pull this a little bit up. Okay, we'll take this above, and I'll take this a little bit above over here. Okay, so this is how CIDR is represented. Okay, so here. Okay, this is how CIDR is represented. So you have the first part, which is the IP address, and then you have the prefix length. Okay, and in between you have /. Okay, so this IP address is the base IP address of the network, and the prefix length is the prefix length which is indicating how many bits are being used by the network. Now let me add an example of CIDR over here. So what I will do is, let's say I want to mention a range for a network. So I'll say 192.168.1.10. Okay, so this is the base IP. Okay, base IP address, and then I'll add a / and I'll say 24. Okay, now this is CIDR. Okay, this is CIDR, and what I'm doing is, this is the base IP and this is the prefix length. Okay, which indicates how many bits are being used for the network representation. Okay, so here if I have to showcase, okay, this would be network bits. Okay, so network bits. So network bits will be 192.168. 168.1 will be network bit over here. Okay, and I'll reduce the size. And then you have, so instead of network, you will have this is host bits. Okay, something like this, and this will be 10. Okay, 10, something like this. So network bits is being represented by 24 bits over here. So this is 24 bit in length, right? Remember this diagram. So every number has 8 bits. So there are 3 numbers. So network representation is being done by 24 bits. That is what you have mentioned over here, 24 bits, right? So this is what is translating over here. And host bits is 10 over here. So it could be 10, 11, 12, and like that it can go on. Okay. And any device that has this IP address, or it starts with this IP address, any device that starts with this IP address is considered as the part of this network over here, which you are representing with this notation. So I'll just replace this with this diagram over here, okay, or this image. Okay, so you can see this over here. Any device with this is considered a part of this network over here. So I would also mention that this part, which is prefix length, which is after the /, this is also sometimes referred to as a net mask, which just indicates how many bits are being used for the network portion. Okay, and which is 24 over here. Okay, now I would also want to talk about how you can calculate the number of IPs in a that can exist within a network. Okay, using this representation. Okay, so there is a formula for that. So this is the formula. Okay, so number of IPs is equal to 2 raised to 32 minus prefix length. Okay, so in our case over here, okay, we have 24, which is the prefix length. So 32 minus 24 what will it be? So 2 raised to the power of 8. That is what the output will be, which will mean that 2 raised to the power of 8 is so 2 raised to. So 2 raised to the power of 8 is 256. 254 in my opinion. Yeah. So with this notation or with this CIDR notation, you will get 254 IPs within the network to use. I hope this is making sense. So we are just subtracting the prefix length that we have mentioned over here, and you get whatever number you basically raise that to 2, and you get the output. So I hope everything until now is pretty clear. Okay, this can be a little bit overwhelming for beginners, but I'll just give you a gist again. Okay, so we were talking about CIDR, and to understand CIDR, it's important to understand IP addresses as well. Okay, so I'm talking about IPv4 address, and an IP in IPv4 notation has 32 bits. Okay, and this is an example of an IP address over here. And if converted to binary, you can see over here, each number is represented using 8 bits over here, and which sums up to 32 bits. That's how we got 32 bits. Now, an IP address has 2 parts. This number is used for representation of 2 things. I'm sorry. So this number over here is used for representation of 2 things. One is the network part, another one is the host part. So some parts or some bits in the IP are representing the network, and some are representing the host itself. So here we saw this example of a network. Within network there were multiple devices, and this network, so every device that had this IP over here, which is 192.168.1, was part of this network. So network representation was being done by 24 bits over here, and the host representation was being done by 8 bits, which is the latter part or the last part of the IP. And you can see over here how the host part was unique, but the network part was same for all. Now, one question you might have is, why do we need this network part and host part in an IP address? Why does this exist at the first place? So the answer for this is routing, basically. So when a internet packet or when a data packet or any sort of information travels across the internet, routers use network portion to decide which network should we send this particular thing to, right? And based on this network representation, it decides, okay, this is a network that it belongs to, and then it will come over here, and then within this network, which device should it go to? Okay, so this latter part will be used then, and it will be delivered to that particular device. Okay, and it also helps for organizing the devices, and it's basically more efficient. That is what it's there. Now coming to CIDR, CIDR is basically used to represent over here. So here you can see it is represented using 2 parts: IP address / prefix length. IP address is the base IP address of the network, and prefix length determines how many bits are being used for network representation over here. So I'll just mention representation over here. Okay, so that is what it used for. And here we saw an example over here. So 192.168.1.0/24. So here what it means is this first part is used for network bits, and the later part, which is 8 bits, is being used for the host bits. And any device with this IP address where X is not defined, X can change, okay, based on the device. But if this part is common, then it's considered to be the part of this network. And what happens is, when you define CIDR range, okay, you should also know, or you would want to get an idea of how many IPs can be used within that particular network. Okay, so for example, if you define this as a CIDR range, with this CIDR range, you can have 254 IP addresses, right? So it's 2 raised to 8, and this is a formula. I've deducted the prefix length, and I got 254. Now, I would also want to talk about online tools that are free to use and that illustrate CIDR, subnetting, and network structure, especially for beginners. So I would like to highlight this website over here, which is judis.de/ipcalc. Okay, so it takes an IP address, netmask, and calculates the resulting broadcast and network. It gives you a basically idea of how many IPs are going to be there if you just don't want to calculate it yourself. So let's say I enter the IP address over here as 10.0.0.0, and if I mention the netmask over here as 24. Okay, so you can see over here. Okay, so this basically, this address that I've mentioned over here, is the host address. This is the starting point of the network. Okay. Then I have the net mask, which is nothing but the prefix length. Okay. So here it is being represented as net mask. Okay. So this is the prefix length, and this means that 24 bit are used from the IP address for network representation, leaving 8 bits for the host. Okay. So here, if you see, okay, you get something called as address over here. Now, what is this address? So this address basically is so you can see over here, this is the binary representation of the starting address. Then you have net mask over here. Okay. So this shows which bits are in the network and which bits are network bits essentially, and which bits are host bits. So here you have mentioned 24, right? So here, like first 3 numbers over here, first 3 numbers are network bits, and then the rest is the host bit. You can see. So this is represented using network. You can see over here, this is represented using 1. Sorry, not network, but 1. Okay. And then you have wildcard. So wildcard is the inverse of net mask over here, and it is showing which bits are for host over here. So this, all zeros are for network, and then this part is for host over here, because out of 24, 8 bits are left. Okay. I hope this is making sense. So this is just inverse of each other, net mask and wildcard, just to give you a clarity which bits are being used for network and for the host. Okay. Then you have network over here, and this is the identifier of the subnet. Then you have broadcast. This is a special address that is used to communicate with all the hosts in the network. So that is what has been mentioned over here. Host min over here. So host min and host max over here. So these 2 things form the range of reusable, or sorry, not reusable. These 2 form the range of usable IP address. Okay. So within this network, the hosts can have the IP addresses ranging from 10.0.0.1 to 10.0.0.254. So it can start from 10.0.0.1, 2, 3, 4, something like that. Okay. And it just keeps on going. And then you have total 254 IP addresses to use over here. That is what it's showing you. Okay. The total 254, because the net mask is 24. Okay. That is how it represents. I hope this is making sense as to how this calculator works. If you convert this to 16 over here, which means now only 16 IPs or 16 bits will be used out of this for representation of network. So which means you will get more IPs within the network. So if I say calculate, you can see over here, now I get roughly 65.5 thousand IPs within this particular network. So you can see here only 16 bits are being used for representation of network, and the rest 8 are being used for representation of the host, right? So you got more bits within, basically for hosts within the network. I hope this is making sense. So the moment you got more bits for representing the host within the network, you can have more devices. Okay. So I hope that is making sense. And that is why you can see over here, host min is 10.0.0.01 and 10.10.255.254, which equates to 65,534 combinations. And these are the number of IPs, unique IPs that you can have within this network if you are creating a network with this CIDR. I hope this is making sense. And by our formula, so this is 16, right? So if you come over here by our formula, let me replicate this. So it will be 2 raised to 32 minus 16, right? So it will be 16, which will be the same number, which was 65534, I guess, right? 65534. Yeah. So this will be the number. Okay. Using our formula. So I hope this online tools also give you some good clarity. These tools are there. They are free to use. Okay. You can make a note of the URL over here. These are free to use and they help you calculate in real time. Okay. So if you're lazy, you don't want to calculate and you want to deal with all this calculation, you can make use of this. You get a range and everything. And based on this, you can design your networks. So I hope this helps. Okay. And here I've also added the key points that we have discussed so far. Now, one question you will have is, okay, I know what is CIDR. I know VPC. I know how networks work and how IP ranges can be assigned and how I can mention the IP ranges. But how does it relate or how does it come together on AWS? Okay, so yes, let's start talking about AWS now. Now on AWS, whenever you create a network or whenever you create a VPC, so this is the VPC that I will define. Okay, let's say this is my VPC. Now, whenever you are defining the VPC from the AWS dashboard, you will have to enter the CIDR block. Okay. Now, CIDR block meaning here you can come to this tool, you can mention the base address and the net mask over here. Okay, and you can calculate, and you will have to plan things a bit. Okay, now this tells you that there can be these many host IP addresses within this particular network if you create. Okay, so whether you want to have these many IPs or how you want to structure your network. So based on that, you will define, and what will happen is here, let's say I'll duplicate this, and let's say I defined a VPC with the block of 10.0.0/16. Okay, so this is going to result in approximately, so the number was 65,000. Okay, approx 65,000 hosts within this particular network, right? Or I can get the exact number, 65,534. Okay, so it will be 534. So these many hosts can be there in this particular network. Okay, and then within this VPC, if you create subnets over here. So let's say there is one subnet here, there is another one here. Now here, each subnet can have the unique IP range, okay, within the VPC. So for example, over here, okay, not this one, but here, what I can do is I can replicate this, and here you can have this subnet being represented with this IP, and you can make this as 1, and here you can say 24. Okay, so this can be one subnet. Okay, and then you can have another subnet which is similar, but the IP range changes over here. Okay, so this way you are creating 2 subnets over here. Okay, and you can see over here it will have 256 unique or 254 unique IPs within this particular network over here. Okay, so this is something that you can do. Okay, so basically VPC is the large network that you will have over here defined using CIDR. Okay, and you will define the CIDR size. So here, the second prefix, you will have that based on the number of hosts needed. Okay, then you will have small networks inside, which is subnets, and you will make sure that right ranges are assigned to subnets. Now, when you are assigning ranges to subnets, make sure that IPs should not overlap between multiple subnets. That will create problems. So that is something for you to take care of. Okay. Also, I would like to correct one thing, like in one of the explanations I had mentioned over here, usable IPs is equal to 2^32 minus prefix length. Okay. So this -2 was also you have to subtract 2. So 2^8 is 256, but you are subtracting 2 over here, right? Here also you are subtracting 2. Its otherwise the value is 65534. So this will be 2^8 minus 2 over here, like so. Okay, and this also will be same. So I actually made a mistake over here. Okay, so this is something that I wish to correct, and based on that, you will make use of this. This is how you will like carve out your VPC and design your network based on the knowledge you have got so far. Okay, and you can of course make use of this tool over here. So for example, the subnet that we are creating, we can say 1 over here, and you can add 24 over here. So for subnet also you can do this calculation, and you can see over here, you are getting 24 hosts over here within this particular subnet 1. And if you update this to 2, the number of hosts will be same because the net mask or this particular value over here, prefix is not changing. Okay, I hope this has been useful so far and you have been able to connect everything to AWS, and I hope you have some decent clarity on this. So CIDR is used to define network or IP ranges over here within a particular network. That is what CIDR is used for. And the notation, this is a notation, but if you understand this, it can be overwhelming at first in the beginning. But once you understand this, how you are calculating stuff and all of that, it becomes a cakewalk.
Welcome back. So now is the time that we go hands-on with VPC and we set up, create VPC, create subnets, we set up the gateways and see how everything works together. Okay, so what I'm going to do is I'm going to come over here, okay, to AWS. Or first of all, let me give you an overview of what we are going to create. So here you could see this diagram. Okay, this is the diagram that we are going to simulate, and this is the architecture that we are going to build. Okay, so first of all, I'll tell you like the outer thing over here is the region, and this is the AWS region. Okay, the region resides like AWS has different regions, right? North Virginia, Mumbai. You can select the region. Okay, so within a region, we are going to create a VPC. Okay, this is the CIDR range for the VPG. Okay, this is the CIDR, and within this VPC, you are going to have two subnets. One is the public subnet, and other one is the private subnet. And this will be the CIDR for both. Now, within both, we have EC2 instances and the private subnet. So, the instances or whatever resources you create within private subnet, of course, it is going to need the internet access to update operating system, install packages and all of that. Okay. So, I am going to enable one-way communication to the internet using the NAT gateway. So, you can see EC2 instance in private subnet is communicating via NAT gateway to the internet. So, here we are communicating with the internet, right? And this is only outbound communication. So inbound, if someone wants to communicate to the private instance, he won't be able to, because this instance IP address will be masked and it won't be shared with the outside world. So this is only one-way communication that is happening through the NAT gateway. And then we have EC2 instance, which is communicating or which is residing in the public subnet, and it is communicating using the internet gateway to the outside world. Okay. So this is the entire structure that we are going to simulate, and we are going to understand how we can bring this entire thing to life. So what I'm going to do is I'm going to come over here to the AWS dashboard. First thing first, we are going to select the relevant region that we need. Okay, so I'll select Mumbai over here. Now once we select the region, what I'm going to do is I'm going to head over to VPC. So VPC is a service, as you can see over here. Okay, so select this VPC. Now your VPC dashboard will look something like this. On the left hand side, you're going to see different stuff like virtual private cloud, your VPCs, your subnets, route tables, internet gateways, and all of these options we have over here. And here you have resources by the region. Okay, so here you can see I already have one VPC. Okay, if you go to your VPC or you click on VPC, you're going to see one VPC already existing over here. Is this the VPC that I have created? No, this is a VPC that you will find in any new AWS account or any account on AWS. Even your account, if it's new, you're going to find this because this is a pre-created network by AWS covering the entire region. Okay, and you can see over here, this is the CIDR of this particular IP of this particular VPC. So this is a CIDR. Okay, now it is also going to have the public subnet over here by default created. So here you can see these are the subnets that exist along with some CIDR ranges being assigned. Okay, then you have route tables. You will also see a route table exist, and if you go inside the route table, you're going to see destination and target over here, status active. Okay, you can see this is the destination and this is the target over here, status is active. Okay, and if you go to so you can see the subnet associations over here as well. Okay, where this is being associated, you can see the internet gateways. So you can see one internet gateway being created over here. Okay, and NAT gateways, if you go over here, there are no NAT gateways found. Okay, now if you go to VPC here, if you click on this, you will see something called as resource map, which is going to give you an idea. Or so if you click on this info, it will tell you, it shows the relationship between resources inside of VPC and how traffic flows from subnets to internet gateways, NAT gateways, internet gateways, and gateways endpoints. So basically it's showing the flow of entire traffic. This is very helpful to understand what is happening inside a particular VPC. Okay, so you can see over here, this is our VPC. Here you can see subnets. These are 3 subnets that exist within this VPC. And there is one route table over here, which has 3 subnet associations and 2 routes total. And then here you are seeing internet gateway. So these all are being connected to the internet gateway. Okay, you can see the CIDRs over here. Okay, and flow logs. So there is nothing in the flow logs. Okay, so this is by default. If you see something like this already being created in your account, don't worry. One thing to know is these components are pre-created by AWS and they are per region, in every region. Okay, so we are going to begin our setup. What we need to do is first we need to set up and create the VPC. So here on the right hand side, just enter create VPC, and here you will see 2 options, VPC only, and then you can see VPC and more. So when you click VPC and more, you're going to see everything like you can see the entire like you can create everything over here along with the preview. So you can even see the preview over here. Okay. So let me give you a gist, or what I will do is I'll say VPC only. So if you create VPC only VPC will be created. And what you will have to do is you will have to create subnets, internet gateway and everything manually. Okay. And if you select this, you get a very nice view over here. You can see over here. Okay. So here we'll go ahead with this approach. Okay. Or alternatively, you can select VPC only and then you can go manually to the other options over here like subnets, route tables and all of that, and individually create components. But I'll just go by this approach. So here you can see name tag auto generation. So you can enter the value for the name tag. So I'll say project demo over here, something like this. Okay. You can add a hyphen if you wish to. Okay. Then it's asking me for the CIDR block over here. Okay. Now what is CIDR block? So of course, this is going to determine the starting IP and the size of your VPC using the CIDR notation. So if you take a look at the diagram that we have, CIDR notation is 10.0.0.0./16. So that is what is entered over here. If you don't want this, you can modify this accordingly. And you can see a preview over here that you will get approx these many IPs, 65,536 IPs using this CIDR block. Okay. So we have to scroll down now. And here it is asking us no IPv6 CIDR block. So whether it's asking basically whether you want IPv4 or IPv6. So I'm just saying I don't want IPv6. That is something fine. Tenancy. So here we need to select the tenancy. So this dedicated means you will be assigned dedicated resources by AWS. But if you choose default, you will be given shared resources. So I'm just going ahead with default. Now scroll down. Here you have availability zones over here. So what you can do is you can spread your VPC across two availability zones for high availability over here. You can see this is for high availability. So if I choose 2 over here, you can see AP South 1A is the first availability zone and this is the second availability zone. Okay. And if you choose 2 availability zone, you have to make sure you create either 0 number of public subnets or 2 number of public subnets. So I'll choose 1 availability zone. I'll keep things simple. Okay. And the number of subnets that we want to create, public subnet is 1 and private subnet also 1. If you want 0 or something like that, you can do that. Okay. But here one subnet, private subnet is something that we are creating over here. Okay. Now, if you come over here, it is auto assigning the CIDR blocks for public and private subnet. But if you want to customize this, you have an option to customize it over here as well. So for public subnet, I can enter the CIDR block as 1 and 20 and not 20, I'll enter 24 over here. Okay. And for private, I'll enter something like, so this can be 2 over here and 24. Okay. So this is public and this is private, and we have 256 IPs being allocated for public and private. And these CIDR blocks I'm getting from here. Okay. So these are 2 defined. I've added these. So 1 public and 1 private is being added. Now, if you scroll down, you also have NAT gateway. Okay. Now, when you create a NAT gateway, be sure that you are being charged for NAT gateway. Okay. There is a charge for NAT gateway, and that is why there is a $sign. So if you want to create one, you can create one. I can say 1 in AZ, and here you will see 1 NAT gateway appear over here. So where is the NAT gateway? Okay. So 1 second. So NAT gateway, and so you can see this one with NAT over here. This is the NAT gateway. Okay. And you can see, so if you hover on this, you will see private. This is project demo. So this is the subnet. Okay. So first this is a VPC. This is one subnet which is private, and from private subnet there is the call is going to the route table, and then from route table it will either go to the NAT public like the NAT gateway or the S3. Okay. Now the next option you have, so here you are also seeing an entry for S3. The next option you have for VPC endpoints. Okay. So what you can do is you can enable S3 gateway over here, and this could be used to improve security by accessing S3 directly. Okay, so if you want to do this, you can select this, otherwise you can do none, and the entry for S3 will be removed. But it's recommended to have S3 gateway over here. Okay, it can be used for backup and all purposes over here. So you can see over here, VPC enable you to connect to supported services like S3. Okay, there is no additional charge for using gateway endpoints. Okay, but you will be charged for the NAT gateway, but that's okay. So here you have this, and then you can select DNS options over here if you wish to. One more thing I would want to mention about VPC endpoint is that if you this should be enabled generally, it's a good practice. If you want private secure access to AWS services or without going through the internet. Okay, otherwise if you say none, you'll have to go through the internet. So this is for the private subnet and not for public one. So you can see this is being attached only to the private one. Okay, and then you have DNS options. So what does this DNS option do? So it allows instances in the VPC to resolve AWS hostnames and AWS based DNS resolution. So that is something you can do. So for example, when you launch EC2 instances, usually there are IPs, right? So if you click on enable DNS resolutions, the DNS names can be used. For example, EC2 dot something and then .compute.aws Amazon AWS.com. So they are just like DNS names. You can add like tags over here if you wish to. Okay. Otherwise, you can just preview the information. So you can see the preview over here. We have VPC. Okay. You can say show details over here. And within VPC, you have these two subnets. One is private, one is public. Both are in the same availability zone. Then you have route tables too. One route table is for public, another one is for private. And then you have network connection. So for network connection, this is the internet gateway, which is for the public subnet. And then you have this one NAT gateway for the private subnet. And this is the S3 endpoint, right? That is being enabled here. So the moment I say create VPC, okay, before creating VPC, you can even preview the source code over here. So this is preview code means these are all the commands that will be used. Okay, so if you are making use of something called as AWS CLI, you can get these commands and trigger it from the CLI, and the same thing will be created. Okay, so this is something can be done. What I'm going to do is I'm going to say create VPC, and the moment you create VPC, you will see you can see a lot of things being created. Okay, it will take some time for everything to create. So it took few minutes to basically create everything. Okay, there was a wait time when it was creating the NAT gateway and waiting for NAT gateway to activate. Okay, so NAT gateway took some time to activate, and then the rest of the resources were created. Now, if you want to see your VPC, you can go over here. Okay, and you can click on your VPCs, and you can see VPCs, your subnets. These are two subnets that are created for you. You can see. Okay. And you can go to route tables. These are two route tables that have been created for you. One is for private subnet, other one is for public subnet. You have internet gateways. This is one internet gateway that has been created for you. And then you also have NAT gateway, which has been created for you. You can see it over here. Okay. Now, if you are not following this approach, so for example, if you go to create VPC, you have this option of creating VPC and more in one go. If you go with VPC only approach, so of course the creation process is same. It's just that you have to juggle between multiple tabs. For example, you will create VPC over here. Okay. You will enter CIDR, everything. You will enter over here. The same configurations. Then you will come over here. You'll have to define subnets. So you will manually create two subnets over here. You can like select the VPC over here. For example, this is a VPC. Okay. You can specify the subnet name, the availability zone, in which availability zone you want, the CIDR, and you can also mention details over here, and you can say create the subnet. So that is something you can do over here manually. So you'll create two subnets, then you will come to route table. You will create a route table basically like this. Okay, you have to select VPC and add the route table like so, and then you will have to come to internet gateway. You will create the internet gateway over here like so. Okay, and then you will also create a NAT gateway like so. It's very simple. You have to just select the subnet, and connectivity type will be private, and one elastic IP will be allocated over here. Okay, these two things are done. Then what you will have to do is you will have to come over here and go to route table, and you will have to add the association over here. So right now, since we created everything together, okay, the associations have been added by default. So you can see over here for private, this is the private route table for the private subnet. So here you can see the association has been added for NAT gateway. Okay, you can see it's been added, and also for public subnet you will see. So this one is public. you will see entry has been added for internet gateway. So you will have to edit routes over here and you will have to add a new route like so. Okay, so these all things need to be done manually, but I choose to make use of that UI because we were already familiar with the approach, right? So just reiterating, you will go in order over here, right? And the order will be first you will create the VPCs over here, then subnets, then internet gateway you will create, then you create the route table, then NAT gateway, and then basically you will have to come to route tables and you will have to route both the things. So basically you will have to create a route for within the route table of private subnet, you will have to create a route for NAT gateway, and you will have to go to the route table of public subnet and create a route for the internet gateway. That is something you will have to do manually. Okay. Once that is done, you can basically now create resources. So for example, I'll come over here. You can go to EC2 over here. This is EC2. Okay. And just make sure you come over here. You launch an instance. Now, when creating an instance over here, whatever you select over here, you enter the name and everything. Okay. If you scroll down, you have an option to select the network. And you can see this is the default network that it has been selected for. So you have to edit over here. You can say not this default network which was already created by AWS. I want to select my own VPC, which is this one. And then you will have to choose the subnet over here. So you have options. So within this VPC, you have two subnets. One is the public and the private. Okay, so you can choose your subnet. Do you want to auto assign public IP? So if it's a public subnet, you would want to get a public IP. It's a choice if you wish to. If you select private, okay, this will be disabled. Okay. And then you will create a security group which will define like the inbound and outbound rules for EC2 instance. So all that you will do. So when creating resources over here, EC2 instances, you have an option to select the network settings, and within that network settings, you have the option to choose which subnet and where you want to place this particular instance. Okay. So these instances that have been shown over here, EC2 and all, these can be added. Okay, and once these instances are created, you can add a entry in the route table for the internet gateway, like so. Okay, and once you add that, okay, this will be added. Okay, now one thing I would want to tell you over here, okay, you create subnets. So here, if you come, you create subnets manually. For example, I'm just giving you an example. Okay, there are a couple of things I want to mention. So you can create a subnet manually. So let's say you create a subnet. Okay, and you want that subnet to be public subnet. You give the name for the subnet as public subnet. Okay, let's say I added the name over here, public subnet, availability zone I added, CIDR block I added, and I created it. Now, is that subnet public? Just by giving the name over here and setting the CIDR availability zone, is that subnet public? No. The answer is yes, you are creating a public subnet, but that subnet is not yet public. When will it be public? The moment you add a route over here in the route table that connects that subnet to the internet gateway, that is when. So if you come over here, okay, route table, this is for the public. So here you can see the moment you add this over here, okay, that is when this subnet becomes public, because now you are routing all the unknown traffic via internet gateway to that of the internet. So that is when this subnet becomes public. Okay, by default, the subnet is not public. This is something that you should know. Now, once you've created everything, you can keep this and you can take it to your project. Okay, but if you don't have a project and you are just creating for the learning purpose, it's advisable that you delete all the resources from AWS. Okay, because see, VPCs and subnets, you won't be charged for that. It's free. But things like NAT gateways, you will be charged for that. So it's better you delete. And I generally prefer deleting things, okay, after I create. Okay, so you can see all these resources you have created, like VPC, S3 endpoint, subnet, a lot of things has been created. So let us delete everything so that you can also follow. So first I'll go to the NAT gateway. I'll select this NAT gateway and I'll go to actions and I'll say delete the NAT gateway. And it will ask me for the confirmation. So it will ask me to type in delete. So I'll type in delete and so I'll type in delete and then I'll say delete. So it's deleting. It may take a while over here. Now you can go to elastic IPs over here. So you can see this elastic IP is being used by our project. So what is elastic IP? Elastic IP is nothing but a fixed IP that is being allocated. And since we added NAT gateways, it's possible that NAT gateway was using this elastic IP. Okay, so we'll have to wait until the NAT gateway is deleted. And once it's deleted, we'll have to come over here. We'll have to say actions, and I'll have to say release IP address. Okay, so it will tell you, tell you that it cannot be deleted. Why? Because there is an association with this. Okay, so this is the association ID. It's giving us the ID over here. Okay, if the resources is associated with NAT gateway, EC2 instance or network interface, please delete those resources first. So that is what we are doing. We are deleting NAT gateway first. So we'll wait for a while until NAT gateway is deleted, and then we'll come and release the elastic IP. Okay, but until then, what I will do is I'll come over here to route tables. Okay, and let us get rid of the routes. So I'll select these two route tables. I'll say delete the route table. Okay, route tables have associations and cannot be deleted. Okay, so let us go over here, and I'll say edit routes. So I'll remove this, and I'll say save. Okay, and I'll get this deleted, this route table. Okay, it still has association. Okay, so it is associated to the VPC. You can see over here. So I'll have to probably go to the VPC, select this over here and here. So I should not delete VPC first. I should come to internet gateway. We have internet gateway that can be easily deleted. So I'll just delete this. So I'll detach this first from the VPC. Okay, I'm not allowed to do so because NAT is still being deleted. Okay, maybe we'll wait for the NAT to be completely deleted. Let me see. Is this being deleted? Yes, it's being deleted. Can we release the elastic IP? Let me see. Release elastic IP. Release. Okay, so the elastic IP is released. You can see. So NAT gateway is now deleted. Okay, this entry will go away. This entry will go away. But I'll come to internet gateway. I'll delete this over here. Detach. Okay, so cannot be detached as there are some mapped public. Okay, so this NAT it's still showing over here. Let me refresh. Okay, so it's the moment I refreshed, it checked whether NAT is deleted, and now it is allowing me. So I'll say detach over here. I'll say detach internet gateway. This is done, and now I can basically go over here. Okay, I'll delete this internet gateway. So I'll say delete something like this. So internet gateway is gone over here. Okay, now I'll go to subnet over here, and I'll delete these two subnets. So let me delete this, both the subnets. So I'll say delete. Okay, these both are deleted. Subnets gone. Route tables, can we delete route tables now? Okay, what is the problem? Okay, this won't be. So before deleting route table, so let me check over here. So within this I have some custom routes, so I'll just get rid of those routes. Okay, so I'm just getting rid of those routes. Oops. So I'll go at edit routes. I'll remove this route over here. Okay, this is done, and I'll choose to delete this route table. Okay, so delete this. Okay, this route table was empty, so it got deleted. Does this have anything? No, it does not have anything. So basically all the routes should be removed, and then this should be deleted, and that is why it was not allowing us to delete the route table. So route table is gone. Now you come to VPC, and if you go over here, let us see the resource map. So you can see there is one route table still there. Okay, it's not showing as deleted over here, but we have actually deleted this. Okay, and this is still there. So I'll just click over here. Okay, and this, okay, it should be deleted now. So let me check over here. I'm on endpoints. Okay, so this is the endpoint over here. So if you scroll down, private link and endpoint, this is the endpoint that was created for S3, right? We had created this. So I'll delete this VPC endpoint as well. Delete. Okay, this is gone. And now if you come over here, okay, how do I refresh over here? There's no refresh button. Okay, maybe I need to do manual refresh. So I'll just do the refresh for entire page. So you can see this is gone, network connections. So this preview or the resource map of VPC is the best way to know which resources exist. So route tables we have deleted, but still here in the preview, you are going to see this entry. Okay, and I realize this entry is of the main route table. Now if you try deleting this, okay, so if I go over here, let me go over here. Okay, if I try deleting this, let me try deleting this. It won't allow me to delete. Okay, so route tables are main route tables for VPCs and cannot be deleted. So this is one thing that you should be aware of. So every VPC has one main route table. So AWS will always prevent its deletion. Okay, and now the question will be like, how will this be released, right? Because this we have not created. So when you clean up VPC, okay, ignore the main route table. This main route table will be automatically deleted by AWS itself. Okay, so what I will do is, this is our VPC. I'll just come over here. I'll say delete VPC from here, or you can alternatively do it from here as well. You can select the VPC and you can say delete VPC, and you can type in delete over here, something like this. So you can see that VPC is also deleted now. Now everything is cleaned up, okay, and we won't have anything over here. Okay, so this will also get cleaned up. You can see the route table was deleted the moment I refreshed. Okay, so this is about the creation of VPCs and cleanup, and basically there were lots of concepts that we did hands-on, and we saw everything being created on AWS. Now the UI of AWS keeps on changing every now and then, so don't worry if you find few elements here and there. So depending on the video, depending on when you're watching this video, okay, you might see some elements here and there. So AWS keeps on improvising things, but don't worry if you see things here and there. Okay, there won't be any major change. But yeah, building this was fun, and I hope you had fun too. So now is the time that we begin talking about AWS CLI. Now AWS CLI stands for Command Line Interface. And usually what you do is, whenever you're making use of AWS, you make use of console home over here. Okay, this is the AWS console. And here you basically make use of this console to set up resources on your account. But there will be scenarios wherein you don't want to make use of the UI interface. You might want to make use of command line and manage AWS resources via command line. So AWS has a tool for that. So it's called CLI. So here we'll go to products. We'll go to developer tools over here. And here you have command line interface. So you can either navigate it this way, or if AWS has changed the UI, you can search for AWS CLI and you should be taken to this page. Okay, you can search for AWS CLI on any of your favorite search engines. So if you come over here, you will see over here, okay, the command line interface is a unified tool to manage your AWS services. And with this one tool to download, with just one tool to download and configure, you can control multiple services from the command line and even automate it through scripts. So things like creating EC2 instances, getting the list of EC2 instances, starting the server, all of this can be done using the command line instead of going to the console. Okay, so this can integrate really well via scripts or with the scripts. Okay, so you can read more about this over here. Okay, you can see this is the command over here that you can run, which is AWS help. They have command. So I'm here on Windows. Okay, I'll head over to the terminal. If you're on Mac or Linux, you can just open the inbuilt terminal that you have with your operating system. Okay, so on Windows, this is PowerShell, and I'll just type in AWS help over here. Let us see if we have this installed onto our system. So I don't have AWS, so this AWS command is not recognized, which means CLI is not installed onto my system. Okay, so to get this set up onto our system, what we will have to do is we'll have to come over here. We'll have to click on get started. And when you come on get started, this is a bit of documentation about the CLI over here. Okay, you can check the prerequisites if you wish to. Here there is about the AWS CLI, what it means. Now when we talk about prerequisites, these will be the prerequisites that you can go through. Install and update. So we are going to install and update. Now here you are seeing a warning. Okay, so AWS has released CLI version 2. And if you're on version 1, it is having the instructions over here for you to migrate to version 2. But we are going to make use of the latest version, so we don't have to worry about that. If you scroll down a bit, you will see AWS CLI install and update instructions, and these are segregated based on the popular operating system. So if you're on Linux, you can click over here and follow the commands over here. Okay, so here you can make use of command line installer, command line, basically if you're on ARM, snap package. Okay, so these are multiple ways in which you can do things, and everything is given step by step over here for Linux. In fact, for all the operating system, but we are talking about Linux over here. So you can just follow this guide. For Mac also, it's pretty straightforward over here. So you can see this is the requirement over here, supported macOS version. Okay, so if you are making use of the latest version of CLI over here, it is supporting 11 plus.
And then you have something called as GUI installer. So you can just download the package file from here and you can get it installed using the interface. Okay, so this is for Mac. And if you are so basically you can run it like this. So these are the run instructions over here, and then to verify that that the shell can find and run AWS command, you can run this command, which AWS. Okay, so this is going to print this over here. Okay, and you can even get the version. All right, so this is for Mac. You can even make use of command line over here. You can see all the commands have been given, straightforward command line. If you want to install for all the users or on your machine, you can follow this. If you want to just install it for the current user, you can make use of this. Okay, so you can follow this guide. This installation is pretty straightforward, I would say. We are going to try this out for Windows. So as on Windows, as you can see here, okay, here you can see over here, this is using the MSI installer, and alternatively you can run these commands. Okay, you can run these commands. On Mac over here we had so if you make use of GUI, okay, you had an option to run this as well using this. Okay, so you just have to run it and it's installed. It was pretty straightforward, and same goes for Windows as well. So what I will do is I'll just download this package and I will simply run it. So I've downloaded the package, and you can see this is the welcome screen if you run it. Okay, it's just like any normal installer that you would have on Windows while installing any other software. So I'll say next. Okay, I accept the terms. I'll say next. Okay, and here it is going to show you some information where it's installing and all. So you can see it's installing over here on my system. Next, and then I'll say install. So we'll wait for a while until the process completes. So it will take a few minutes. So you can see the installation is complete and I get the confirmation, and I'll just say finish. And now I'll come back to my PowerShell instance, and here I'll just run AWS help again. Okay, so it's still saying it's not recognized. So maybe I need to restart the terminal. Okay, so I'll just quickly restart the terminal, or I'll just open a new tab of the terminal rather than restarting, because that instance is not picking the new installed software. So you might have to restart your terminal. Okay, now let us run AWS help, and it should work now. You can see, right? And I can even type in. So here you have this command, okay, AWS-version, which gives you the version of the software installed. So here I'm going to print this. Okay, you can see this is the output over here, and you can see this output matches the one that we are seeing over here. Okay, so congratulations, you have just configured the AWS CLI. So once you do this, you think you are ready to make use of CLI? Absolutely not. So you have just installed AWS CLI, which is the software or the tool onto your system. But you have not authenticated yourself with this tool, right? So it's just installed on a machine and it does not know who you are, or it does not have access to the account. So if you, let's say, want to run some AWS specific command. So right now you're just checking the version and you're running the help command and the version command. It's working fine. But with AWS CLI, you can create S3 buckets. You can get the list of all the S3 buckets. So let us try running one command. Okay, I'm going to say AWS S3 ls. So this command gives you the list of S3 buckets in your AWS account. So we have not configured this yet. Okay, we are not ready to use, but let us see the output of this command. So if I run this, okay, you will see it says unable to locate credentials, and you can configure the credentials by running this command AWS configure. So we need to configure our CLI first with our account. So for that, we will come over here, and here you can see after getting started, there is something called as configure. So come over here. Okay, I am not sure. So I don't make use of this documentation to configure the AWS CLI, but there should be some good amount of options. Okay, maybe it's sounding a little bit complex over here. So what I will do is I'll just give you my steps as to how I configure AWS CLI. Okay, now when you configure AWS CLI, it is going to ask you for a few things. Okay, so first thing is it is going to ask you for AWS key ID. Okay, then it will ask you for a secret access key. And then it will ask you for a default region name and default output format. So these 4 things you're going to need. Okay, so you come over here to the console. We'll have to go to IAM, and here I assume you have signed in using a IAM user account. Okay, so this is a IAM user for my account. If you scroll down, here you will have access to security credentials. So if you are a user, you will have access to the security credentials. Go to security credentials, and here you will see all the security credentials for your account. So just scroll down, and you're going to see different things. So here this is for multi-factor authentication, and here you have something called as access keys. So here you can see use access key to send programmatic calls from the AWS CLI, AWS tools, PowerShells, all of this. Okay. So you can say create an access key over here, and it is going to ask you why you want to create a access key. And here there are some best practices. Avoid using long-term credentials like access keys to improve security. Okay, so it's saying don't make use of this because you should use it only if it's needed. Okay, don't just use it and create access keys for your account, because if it's shared publicly somewhere, if it gets leaked, then anyone can gain access to your AWS account. So remember, these keys that we are creating are not supposed to be shared with anyone. Okay, so I'm just going to select command line interface over here. Okay, and here I'm going to say next. Okay, I understand the above recommendation and want to proceed. I'll say next. So it is going to tell us the description. So I'm going to say Windows demo over here. You can add like any sort of description value, which will tell you the purpose of this access key, for which it was created and where it will be used, so that in future, if you have to get rid of any access key, you can select and get rid of access keys. And then I'll say create access keys. I'm not going to share the access keys over here, okay, because this is sensitive information. So I'm going to keep it with myself. But when you create access keys, you're going to get the access keys on your account as well. Now I've created the access key on my AWS account. Now one thing you should know is when you create access key, that's the only time you get to see your access keys. Okay, then later on you cannot see your access key. So you have to copy it and save it at a safe location. And this is just for security purpose, that AWS does not show you your access key the next time you try to access. So if you want an access key again, you have to create a new one. That is how it works. Okay, so I have my access keys saved on a secure place. Now what I will do is I'm going to run a command over here. I'm going to say AWS configure. So I'll say configure like so, because I'm being asked to configure. And the moment you say configure, you will be asked for AWS access key ID. Okay, so the AWS access key ID that you got from the console when creating the access key, just copy and paste that over here. So after running AWS configure, I was asked for these 4 things. Okay, I've not recorded that because this is sensitive information. So I've added my key ID that I got from the AWS console. I've showed you how you can get it from AWS console. I've added the secret key over here, and you are asked for default region name over here. Okay, so you can choose the default region name. I've selected AP South 1. I'll show you how you can get this region name, and the default output format is JSON. You can choose JSON, table, text, or whatever you want to, but I prefer working with JSON. Generally, developers prefer JSON only. Okay, and default, so these 2 things okay, this thing I've told you, and now I'll show you how you can get your default region name. Okay, now default region name is the region name in which you wish to have, in which you wish to do things, okay, via the CLI. And this is a default region name, default one. Okay, so here if you come to the console, you will see the list of regions over here, and here you will see this code, this thing. So AP South 1 is Mumbai. If you're from United States, if you want to make use of North Virginia, you can make use of US East 1. If you're from Canada, you can make use of this. From Europe, you can make use of this. So just get the appropriate region for you that is closest, okay, and just make use of it and add it over there. The moment you do this, you will you won't see any sort of confirmation, but you will have AWS CLI configured onto your system. So now I do have AWS CLI configured onto my system. And what the CLI tool does is, after you do this, after you run AWS configure, and if the configuration is successful, the details are saved in files inside your computer as to who the user is. Okay, so on Mac there is a AWS credentials folder where it's stored, and somewhere in C drive where you have installed AWS on Windows, okay, it is going to store the credentials over there. Now you can verify the setup by running the same command which we tried to run early on, AWS S3ls. And this time it is not throwing any sort of errors. Okay, so we don't have any sort of buckets that are created in our AWS account, right? So we are not seeing any sort of output over here, which means there is nothing to show, right? If you want to create, you can do that from here. You can do a lot of stuff. So the fact that we did not get any sort of errors, it means that we don't have any sort of buckets created over here. Early on when we ran the same command, we got an message wherein you should make use of create. Not create, AWS configure. You should make use of configure, which is AWS configure, and get things configured because it's not configured yet. So brilliant and congratulations. You now have AWS CLI configured onto your system. And if you've completed this step, okay, pat yourself on the back. Okay, you are ready to interact with AWS resources from your system. So now it's time that we begin talking a bit more about the CLI. So what I would do is I would come over here in the CLI documentation that we were on. And here you have like AWS CLI examples. And here you can see different examples for making use of, AWS CLI with different services. So you will have to expand this guided command examples over here. Okay, you also have command examples over here. Okay, so for example, under command example, if you want to see for Amazon EC2, you're going to see the examples over here. Okay, so you can see over here, create. So if I search for, create over here. So you can see over here, create image. There are tons of examples over here. You can see create. If you say launch over here, so you can like launch template version, launch template. You can search for run -instance over here, run instances. So you are going to see something like this. Okay, this is the command that will help you run the instance into the default subnet. Okay, so we can do all these sort of things. You have things for S3 as well. Okay, so you can search for Amazon S3. Okay, I can't seem to find it over here, but it's there over here. Okay, you can see route 53 Amazon S3 over here. So you can do tons of things over here as well. Create a bucket. So this is the command basically will help you create the bucket. Okay, so you can see S3 API, and you are essentially creating the bucket. So what I would do is I would come over here. You can either follow these examples, scroll up, or I would follow S3 command example, like guided command examples. Okay, and we can start with S3. So you can see high level S3 commands, prerequisites, and all of this. Okay, so you can see quite a few examples over here. Delete buckets, move objects, copy objects. So this way you can copy the objects from a bucket or a local directory. So if you have something on a local directory and if you want to copy it to a bucket, you can do that using this command. Okay, so there are quite a few. So you can see on the same page here we have the command to create the bucket. Okay, you have AWS S3 MB target and the options. So I'll copy this. Okay, and you can see the examples as well. Okay, you can see the example. Okay, so I'll just copy this example over here. I'll come over here. I'll paste this. Okay, so this is the bucket name. So I'm saying S3 MB S3:2/. This is my bucket name. Now, if I want, I can modify this bucket name, but I'll just keep it like that only because this is a dummy bucket that I'm creating. Okay, and then I can also mention the region over here. So if you don't mention the region, it will get created, in the default region. But if you want to specify the region, you can specify it using this region flag, and you can come over here. Okay, if you go to AWS, you're going to see this region over here. Okay, AP South 1. So I'll just copy this region and I'll add it over here. And I'll also go to S3 and let us see if we have any sort of buckets in this region. So we don't have any sort of bucket. You can see it's asking us to create bucket, in fact, right? But let us try creating a bucket with this command. So I'll just press enter and okay. So an error occurred. Access denied. The requested bucket name start when calling the create bucket operation. So it's telling us that the bucket name starts with the reserved prefix. Okay, so maybe I'm not supposed to use this. I'm supposed to use test. I'll also add some random numbers in between over here so that the bucket name is unique over here. Right, so I've added this and let me press enter now. Okay, so you can see this bucket is created over here. We got this confirmation. Okay, so if you come over here now and if you refresh, okay, so you can see over here on the left hand side, okay, general purpose buckets, and you should see this bucket being created. You can see, There's a bucket that we have right now. Okay, and now earlier when we were running this AWS S3 ls command, you were not getting any output, but now if you run this, you will see the bucket name listed over here. Okay, and this will be the same bucket name that you have created. Now you can see over here, this is listed. Okay, this is the bucket that we have created. Okay, now if you come over here, this is done. All right, you can also get rid of the bucket if you wish to. So here in the documentation itself that we were looking at, I just saw look at different commands, and here there is delete buckets as well. Okay, so AWS S3 RB. Okay, and you can see this example as well, AWS S3 RB, and you have to specify the bucket name. And if you come over here, okay, AWS S3 RB, this is our complete bucket name. So I'll just copy this with this S3 tag. Oops. So I'll just say S3 RB. RB stands for remove bucket. And if you run this, it will remove the bucket. You can see over here. Now, if you go over here and if you do a quick check, so where is the refresh button? So you can see over here, you don't have any buckets. So this is indeed working fine. Okay, you can see the power. You can imagine the power of AWS now, right? There are tons of commands. Okay, if you so not the power of AWS, but the power of CLI is what I meant. Okay, you can imagine the power of CLI. If you want to copy something from your local directory to a bucket, you can do so. You can sync objects over here. Okay, so it synchronizes the content of bucket and the directory. Okay, so this is something. These are frequently used options for commands over here. So this is the entire documentation. You can try out different commands, and these are this is a CLI reference over here for different sort of commands over here. Okay, but this is right now for S3. Okay, you can play around with S3. I'll also show you EC2. So here you can see if you go to EC2, okay, there is a video. And EC2, of course, we know what EC2 is, and it starts with key value pair, or key pairs is what I should say over here. Okay, so to access EC2 instance, you need a key pair. Okay, and you can create the key pair, get it downloaded onto your system and connect it. So this is the same key pair that we have that you can use even for doing SSH, right? So you can create a key pair. You can see over here, this is the command over here. Okay, and output will go over here in this particular file. So what I would do is I would copy this command over here. Okay, this is command with query option for PowerShell. So for PowerShell, this redirects to default UTF-8 encoding. That is what it's saying. Okay, which cannot be used with some SSH client. So you must convert the output to output by pipping it to the out file command. Explicitly set it to ASCII. Okay. So I understood what it's talking about. So here it's saying like this command, if you run on PowerShell, it is going to default to UTF-8 encoding, which cannot be used with some SSH clients. So if you plan to do SSH over here, just make sure it's encoded to ASCII, which we are doing over here. Okay. So anyways, you can pick any of the command. I'm not going to do SSH right now over here, but I'll just paste this over here. You can see my key pair and queries key material. Let us run this and let us see how this works. And if I do ls over here, so you can see this is the key pair that has been created. Okay, so the key pair is created, okay, successfully. Now what I will do is I will run the command basically to create the instances. Okay, so you can see over here, if you're connecting, so this command will be needed if you're running on Mac or Linux. Okay, so after you create the key pair, this command will be needed. Okay, because generally on Mac and Linux, whenever you have any sort of file created, it does not have the right permissions. So the chmod command will give it the right permissions of the private key file so that only you can read it. Okay, so this is a command for that. So if you're on Mac or Linux, just use this. You can make use of this to display your key pair. I'm not going to display my key pair. Okay, but here we can come to now EC2 instances, and here you will see the command basically to launch and allow us to launch the EC2 instance. So what I'm going to do is I'll copy this command. Okay, copy it, come over here, paste this. Okay, now here you will notice it needs image ID, right? It needs image ID over here. So this image ID you need to get. Okay, now this image ID you need to replace and mykeypair.pem. So mykeypair.pem is called, that's a file name that we have on a local machine as well. Okay, but we need the Amazon machine image, AMI ID. Now before running this command, I suddenly feel we should have got the AMI ID first, because getting the AMI ID also requires us to basically You can get it from UI, okay, but I wish to get the AMI ID first. So what I will do is I can open a new tab of PowerShell here itself. So here now to get the command, I have switched to the Google's AI mode, okay, because we need to get the command to get the AMI ID, okay. So I'll tell Google to, or Google AI Gemini, I'll tell it to give me command to get Amazon owned image IDs, okay, with image names sorted by latest version at top, okay. And it is giving me this, okay, so it will give me this command, okay, it's in multiple lines over here, so I don't want it in multiple lines, give me in one line, give me command in one line, something like this, okay. So you will get the command like this in one line. I hope this is correct, okay. This output is in text, okay, so we need the output in table format, so it says output in text, okay. So what I will do is I'll paste it over here. Instead of output in text, I'll say output in table format, like so. And okay, one problem it did, owners it has mentioned as self, so we are not getting any output. So I'll have to modify this. Despite telling it that I want Amazon owned image, it added owners as self. So I want Amazon to own this image. This should be Amazon based images, and I should get a list now. So let's wait for a while. Okay, so you get this image, okay. You can see there are so many images that we have. You can just keep on pressing enter over here, okay, and you can see the image, okay. Why is this data this way? Okay, so just press enter, okay. So you can see there are so many images that are coming in, okay. You can make use of any image. Ubuntu based images are coming as well. You can see deep learning, Ubuntu Pro, any sort of images you can pick, okay. So you can pick any one, okay, and you can get the image ID from here, okay. So I'll pick some this one, okay. So this is one way of getting the image IDs, or you can even get it from the console, okay. So let me show you how you can get it from the console. So you can say search for EC2, okay, and here, so here you can say launch an instance, okay, and here you can see whichever AMI ID you select. So for example, if I selected Ubuntu, okay, free tier eligible, you can see this AMI ID, okay. So you can simply copy this based on your requirements, or you can make use of the command like I've shown you, okay. So we'll switch over to this terminal, okay, and if I come over here, okay, so here I'll paste the image ID, okay. Key pair name is same. Subnet ID you can mention over here, whichever subnet ID is there, okay, but I'll just press enter. Probably I'll get an error, okay. Subnet ID does not exist, so maybe let me skip this subnet ID and let me see over here if you see any sort of error, okay. Okay, security group also does not exist. So these all things you can create over here. First you have to create security groups, subnets, and then you have to mention it over there, okay. My key pair, so does this key pair exist? It's mykeypair.pem. So I just press tab and got the actual file name, and now I'll press enter. Okay, when calling run instances, the key pair does not exist. Is that so? So let me check it again. Okay, so I realized like .pem should not be there in the key pair name, okay. It should not be the file name, but it should be the key pair name. And now you can see this kind of an output over here, okay. So which means that the creation of the instance is done over here, okay. I'll just press Ctrl C over here, and if you come over here, let me see over here EC2, and let me go to the instances tab. You can see this is the instance that has been created. This is the instance ID. It just got created, and if you come over here, you should see the instance ID. So you can see owner ID and everything over here, okay. I'm not able to find the instance ID, maybe because before that only I terminated the command before it printed the instance ID. But here you can see all the details, and this is the exact instance that has been created, okay. So you can see it's now in the running state. You can see over here, right? It's now in the running state. Now here you can come and you can say AWS describe AWS EC2 describe instances, like so, and it will give you the details of all the instances. You can see it will describe all the instances, Okay, you can stop any instance over here. So if you come over here on the browser, we have this documentation where you can see EC2 instances. Okay, so launch your instance. So you can launch your instance this way. We already saw. Okay, if you scroll down, you can add a block device to your instance. You can list your instances. You can see AWS instances is what we saw. Okay, the following command filters the list to only T2 micro instances and output only the instance ID. Okay, so this is the command which will apply the filter as T2 micro and it will only give you the instance ID. So I can copy this command and let me run this. Rather than getting this entire JSON, okay, I would rather get the instance ID only. So you can get the instance ID like this. You can see this is the entire query. So AWS EC2 describe instances will give you the entire dump or the entire JSON that describes the instances for all the instances. You can make use of filters and you can say you can filter the data and you can only get the instance ID over here. You can see. So you're filtering the data first to micro instances and then you're making use of this query option over here to just get the instance ID. Okay. So that is what you're doing. And then you can see over here, you can describe any of the instances like this. You can filter things over here. Okay. You can terminate the instances. So I'll copy this command. We can terminate it. So I'll add this over here. And here you can add the instance IDs. So I'll copy this instance ID like so. And you will paste it. And you can say terminate. The moment you say terminate, you can see the previous state, current state is shutting down, the previous state is running. And this is again the entire JSON, okay, which you see. Okay, so it's shutting down now and you can come over here and if you do a refresh, it was running early on, now it's shutting down. Okay, so it's basically getting deleted. Okay, you can reboot the instances. There are tons of commands that you will see over here. Okay, change the EC2 instance type with bash scripting. So you can use all of this in bash scripting as well. And you can manage all of this using scripts, right? Same thing you can do for IAM as well. Okay, IAM thing I'm not going to show you because I understand you get a gist now, right? So you can create a group using this. You can mention the group name, right? You can create a user like this. Okay, if you can make use of the create user command or if you want I can execute this command. Okay, so if you come over here, just confirm if this is shutting down. Okay, this is shutting down. So maybe I'll come over here. I'll just duplicate this. Okay, I'll have that EC2 tab open. I want to check whether it actually shut and I'll delete the instance because I don't want to get charged or billed for anything. All right. So just make sure whatever you're creating using command line for learning purpose, you just delete them. Right. So I have these few users over here. All right. And you can see I have user groups over here, image uploaders. What I can do is I'll paste a command over here. Let me paste one command which I copied. I'll create a group called my IAM group. Okay. Let us see if this gets created. You can see this is the data that gets printed along with group ID. If you refresh, you'll see my IAM group over here. Okay. Now, if you come here, you'll also see create user over here. So my user is the user that is created. So you can run this. Okay. You can see if you come here, if you go to users and if you refresh, you'll see my user being created, right? Isn't this good? And then you can add the user to the group using this command. So you're saying AWS IAM add user to group and then you're specifying the username and the group name. So this user will be added to this group. Okay, so you can run this. Okay, and initially it was not added in any sort of group. Okay, because it was just created. But now you can see over here it's 0 group. But if you refresh this, it should come 1 group over here. Okay, if you go over here, okay, you can see it's part of this group now. Right? Initially, it was not the part of this group. And then you can get the group name, get the group detail. Okay. And you can verify whether IAM group contains my user. So you don't need to switch over to console to see if the user has already been added or not. Okay. All the operations that you can do from the console, from the UI can be done from the console as well. Okay. So you can see over here, you can see users being added and this is the group details. So this is the one user that has been added. Okay. So that's the thing. And yeah, you can do a lot of other things. You can attach the policy. You can like create a policy like this. You can see, you can do a lot of things over here is basically what I mean to say. All right. You can also deal with other services on AWS, like you can create VPCs. Okay. You can allocate elastic IP. You can, associate elastic IP with an instance. You can create a subnet. You can create a new VPC. So AWS networking related concepts, you can do a lot over there. Okay, and somewhere over here, if you let me see if I can get the link to the entire reference guide over here. Okay, so I found the command line reference over here. So if you come to this Amazon CLI page, you can see this command reference. Click on this and you should be taken to this page where you can reference everything. Okay, so for example, EC2, if you search for EC2, you can see EC2 and all the EC2 related concepts, all the EC2 related commands will be listed over here. You can see all of this, right? Tons of commands. You can click on this. You can learn more about any of the command, the options, what each option means. You can play around, right? So yeah, this is the reference, CLI reference that I would recommend you check out, because there's literally everything that you can do from the UI. You can even do it from the CLI. The CLI is that helpful. Okay, and it's really useful when you're working in an environment where you don't have an interface, like you're working on a Linux machine and you just have access to the terminal. So, you as a developer will be expected to make use of AWS CLI, and it's very common these days to make use of CLI. Okay, I hope you all had fun and you understood everything.
So it's time that we begin talking about serverless. Okay, now what does serverless actually mean? Does it mean without servers? Not really. Okay, so it just means you have your application running on servers, but you are not managing your servers. So let me explain this in a better way. Okay, so whenever you deploy your application to a cloud, okay, you will have to manage your servers, right? There will be servers, for example, if you're deploying on AWS, so you will have EC2 instances that you will have to manage, right? You will have to patch updates, you will have to make sure that they run the latest software, you will have to scale, you will have to monitor whether servers go down or any sort of issues are there. And servers, you will have to do this if you are at scale, and you will also have to do this if you are not at scale. So whether you are at scale or not, you will have to do this. This is not an exception with servers. Okay. Now, how does serverless helps with this? Okay. So serverless, when you go serverless, you are not managing servers over here. So I added a text over here. Serverless doesn't mean no servers exist. Okay. In serverless, servers still exist. So when you go serverless and when you start building your application in a serverless manner, it does not mean that there is no servers. Okay, it simply means that you are not managing it. And having things run in serverless environment, there are a lot of benefits. Okay, because servers are running behind the scenes, you never see them, or you don't configure them, and you are only focusing on your code and the triggers. So triggers meaning the API call or the event and everything that you have set up. Okay, so that is what serverless is. Okay, so this is the simplest distinction between serverless and the normal ways. Okay, so you can compare it with staying in a hotel. So let's say you are staying in a hotel. Okay, so hotel I would say is a serverless approach, and if you're buying and renting a house, that is a normal approach. Okay, so renting the house. Okay, so if you're renting the house, what you would do is you would pay for the electricity bills, you would manage electricity, plumbing, repairs, any sort of repairs that happen. That is something that you would do if you're renting a house. Okay, but when it comes to staying in a hotel, you don't take care of all of this. You just pay based on what you use, and yeah, electricity and everything is taken care by hotel itself. Okay, so in the same way in serverless, you don't manage OS, you don't manage patches, scalings, software updates. You don't manage server, you just code. Okay, and here in server, like normal server model over here, where you have to manage servers, you pay per hour of usage for the servers. But over here in serverless, generally with AWS, you pay per request and the execution time. So you pay per usage basically, or per request that is being executed on the server. That is what you pay for. Okay, now here in serverless environment, you have to manage the scalability of the application. It is manual, and you have to do the auto scaling setup and all, right? But serverless will auto scale instantly based on the demand. So that's the difference between these two. Now quickly what I would do is I would come over here to AWS. Okay, now AWS has a service that helps you run your application or run your code in a serverless environment. So here if you go to products, okay, and click on compute, you're going to see EC2. Now EC2 is the way wherein you get virtual servers and you get full control with compute resources. but you will see serverless over here, the serverless category. So here, this is instances, and here you have serverless category wherein you have something called as Lambda. Okay, so Lambda is a service like AWS Lambda. This is a service wherein you can run code without thinking about servers or clusters. So that is what the tagline is. Okay, and it has a generous free tier as well. It gives you 1 million requests free per month with AWS free tier, and you can click on this to know more about AWS free tier over here. So this is a pricing page for Lambda. Okay, so if you go over here in pricing page, you will see over here. Okay, I don't see any information about free tier, but here you can see this is how you are built. Okay, based on the region. So you can select the region you want to. Okay, and if you scroll down, okay, so I don't see any information on the free tier, but anyways, it just told us that there is a decent free tier that is there for you. Okay, so yeah, this is AWS Lambda, and I hope you have a sense of what Lambda is and what serverless environment is. So in EC2, you would basically need a full server. You will manage the full server and keep it running continuously. But in Lambda, you would just have the code and you would get it run on demand. Okay, that is what you would do. So I hope this has been useful. So now what I've done is I'm here on the AWS console and we'll try getting a Lambda. Okay, so you can search for Lambda over here and select the Lambda service over here. And you can see over here, lets you run code without thinking about servers. So you only pay for the compute time that you can consume. There's no charge when your code is not running. Okay, so your code is there on AWS Lambda. You only pay when your code is executed, which is the compute time. There's no charge when your code is not run. So understand this, okay? With Lambda, you can run your code virtually. You can run code virtually for any type of application backend service with zero administration. So there is no administration over here, right? And how it works, you can see over here, you can write this kind of simple function. This kind of simple code over here, which is Lambda function. You can write it in Python, Node.js, Java, .NET. You can see Ruby, and you can even have custom runtime if you wish to. Okay, so popular languages are covered already. Okay, and you can have the benefit. So if you're a Java developer, you can see this is how you run Lambda over here. Okay, and you can just say run over here, and you'll see hello from Lambda. Okay, here if you run this will also give you hello from Lambda. Okay, so if you do next over here, Lambda responds to event. So if you go next, you can see over here, if there is any sort of event, you can configure Lambda in a way where this code is executed. So if there is any sort of analytics being sent, any sort of backends you have, data processing that you wish to happen, you can trigger an event to Lambda and it is going to execute it for you. Okay, and next is scale seamlessly. So if there are these many invocations, then the cost increases. Okay, so that is how it basically works. Okay, so this is just a demonstration of how Lambda works. They have created it beautifully on their page. Okay, and you can see over here, it scales up, scale down automatically to handle your workloads, and you don't pay anything when your code is not running. Okay, so this is about Lambda. You can scroll and check different sort of things. This is a pricing over here. Okay, you can take a look at the pricing, and you can go to AWS Lambda pricing as well, and you can get the pricing right now. Okay, get started for free. Okay, so yeah, this is Lambda, and we'll come over here. We'll say create a function. So you have to create a Lambda function basically to begin with Lambda. Okay, and there are multiple options to create the function. So you can author a function from scratch. You can write your own code and upload it over here. Okay, or you can make use of a blueprint. Now, what is a blueprint? So with blueprint, a blueprint allows you as a developer to basically make use of ready-made or pre-built functions from AWS. So these are pre-built functions. So you can see over here, hello world function. This is a hello world function template that has been created by AWS. You can even have container image. So you can select a container image if it's uploaded or if it's added on Amazon ECR. Okay, so if Amazon ECR is Elastic Service Registry by Amazon, okay, it's basically used to have host the Docker images. So if you have Docker images pushed over here, you can add the container URI, function name, and it will start over here. Okay, so we can make use of blueprint. I'll say hello world function over here. I can say my first function or something like this. Okay, you can choose the runtime. So runtime is Node.js 22. Okay, you can select any runtime over here based on your requirements. And yeah, this is one thing that I want to talk about. Execution role. So when Lambda executes, it's basically going to need some sort of permissions, right? For example, if Lambda is tasked with doing something on S3 bucket, so it will need permission to access S3. So in such scenarios, there can be a role that can be created with the required permissions for Lambda. Okay, and that is what it is talking about over here. Okay, if you scroll down, this is the Lambda function code. So the boilerplate that we have selected has this code over here. So you can see over here, it is expecting 3 keys over here in the event object. Okay, and it is logging it in the console. That is what it's doing. Okay, so you can come over here and you can just say create function. The moment you see this, or the moment you say this, okay, it is actually going to create. So you can see creation of service role. The role has been created. Okay, and this function creation is happening. So first the role was created. Okay, automatically we didn't create it. Okay, and this is created in the IAM console. You can come and see over here. Okay, if you go to roles, you can see this is the function role, right? So you can see executable role, and if you come in role, this is okay, which one was that? So it was this one. Okay, first function role, my first function role. Okay, so if you come over here, my first function role, this was the role that has been created. And now if you come over here, okay, it's saying set up a local environment. So you have the option to set up a local environment as well, so that you can update the Lambda function code and do all of that. Okay, so you can see over here, it has a button which says open in Visual Studio Code. So let me see what happens if I do open in Visual Studio Code. Let me see that. I have Visual Studio Code already installed onto my system. So it is going to open Visual Studio Code. Let me open this. Okay. And okay, so would you like to install AWS Toolkit extension from Amazon Web Services? I'll say install and open URI. Okay, so it's telling me this is the extension that it is installing, Amazon Web Services. I'll say trust the publisher because this is from Amazon itself. So I trust the publisher. It is installing it. It is going to get the source code and it is going to open it over here. You can see. So do you trust the authors in this directory? So you can see this is where it has temporarily set up the Lambda function for me. Okay, this is the directory. So I'll say trust the authors. Yes, trust the authors. And here you can see. Okay, so this is created and this is the code basically. This is the code basically that is written in the Lambda function. We have not written it, but it came in from the pre-built. It was pre-built actually. Okay, so I'll just minimize this. Come over here. I'll say dismiss. Okay, and here you can see this function overview. So this is a diagram as to how your function is interacting. So if there is any sort of trigger, any sort of destination, all of that will come in this diagram. You can see the template over here. This is a template code. If you scroll down, this is the code for your function over here. So now over here, you are seeing this option to test. So I can say test over here. Okay, so there needs to be a test event before you test a function. So there is no test event created. So I'll say create a new test event, and you can say my event. Okay, and you can enter the value over here. Okay, so you can see the template is being used, hello world, and there are 3 values being passed. Key 1, key 2 and key 3, and this key 1, key 2, key 3 will be used over here. So this entire thing will go in as the event object over here, and then key 1, key 2, key 3 will be printed onto the console. Okay, so I'll save this, saving the test event because this is what we need. And what I will say is I can save this. Okay, event already exists, so I'll say invoke. Okay, so you can see now over here, let me see the event. Okay, so you can see the event value 1 is equal to value 1, value 2. So this is coming in from here. You can see this is what is coming in, right? Value 1, value 2, value 3. So you can update this value as well. So I can say value 1, 1, 2, 2 and 3, 3. Okay, and I can just say invoke. So you're going to see the output over here. You can see this output, right? And you're seeing the response as value 1 over here because you are returning the first key over here. Echo back the first key. So that is what is happening, right? And there is also a log which says loading the function and all of that. Okay, so everything is working fine, as you can see over here, right? Everything is working fine. And yeah, we just created our first function, first Lambda function that is serverless, and it is executing on AWS Lambda. Now you have some code running with the help of AWS Lambda in the cloud, right? Now, of course, you would want to call it with the help of Postman. So how do you do that? So for that, come over here to your Lambda function. And how do you come to Lambda function? So here in functions, so if you come to Lambda, okay, you would see one Lambda function, and go inside, go to your function, and then under configuration, okay, here you will have function URL. So you can say create a function URL, okay, and here it will ask you for the authentication type. Okay, so whether you want this URL to be authentication or authenticated or not. Okay, so use function URL to add HTTPS. Okay, so this is about function URL, but this is about auth type. So I don't want any sort of authentication type over here, right? So if you can make use of authentication type if you want, but I'm not making use of it. I'm just keeping this as public. Okay. And I'll say save over here. Okay, I don't have any other settings to be added. I'll just say save over here. So the moment I say save, you get access to this sort of URL, okay, which you can come to Postman, okay, and you can create a new request. I'll add it, okay, and then so we will have to call this. So let me call this, okay. So I got null as a output over here, okay, but 200, okay. So it's because maybe my function is not deployed. So I'll come over here to code, and I have not deployed it yet. So I'll just deploy it. Okay. So the moment I press deploy, okay, 200, okay, but the body is null. Okay. And probably I know why this is happening. Okay. So it's still giving null. The reason is because the return type or return value that we are getting from the Lambda, it has to be a proper HTTP style response, which includes the status and the body separately. Okay, so what you can do is you can come over here, okay, and here when we are returning event.key1, okay, so I'll just get rid of this event.key1. I don't want to get, okay, and I'll increase the coding area. I'll simply add this code over here, okay. So you can see over here, I'm returning status code. Headers I'm mentioning as application JSON, and within body, I'm JSON.stringifying the message over here. Okay, just take a look at this code. Okay, so this is how, so I'm mentioning, so this is a proper HTTP style response that I'm giving over here rather than just returning the value. If you just want to return the value, you can add it under the message over here. Okay, but if you're using Postman, this is what would be expected. Now, once you do this, you will have to deploy. Okay, so because you have undeployed changes, so I'll deploy this first because the function has to be deployed. Now things are deployed. So now I'll come over here and let me trigger this. So now you can see hello from Lambda function URL. You can even pass in the body parameters. So you can come over here raw JSON, and if you remember, we had a test created. So if you go to test, okay, here the test we had created. So what the test event that we created will be under test over here, and you will get the execution details over here like this. Okay, whenever you test anything. So this is another way of making use of test, and you can add it over here and you can run this. So now this is being used, and you can return this with the response if you wish to. Okay, or you can test it like this as well over here. So if I test it, okay, this is in browser testing, so I'll get see message hello from Lambda function URL. Okay, so this is something that I have done over here, and this is working absolutely fine from the Postman. And we now have a URL. Okay, what we have now, we now have a URL, and we are suddenly calling it from Postman. So this is the power of Lambda function. Okay, there is a lot that you can do with the Lambda function. We are running it in the browser. There is no auth. Of course, you can add authentication and all of that. Okay, that can be done. There are ways to do that. But right now, we just wrote some code in the cloud, and we are exposing that code as a REST API. Okay, it's written in Node.js, JavaScript, but it can be written in Python, Java, you saw, whatever languages were there. I hope this has been useful so far. So now here we are in the Lambda functions dashboard. Okay, and I want to give you a gist about API gateways. So yes, over here, okay, you created a function URL, and you can basically call this function URL from Postman or anywhere, right? But there is something called as API gateway, which you can make use of, and you can map the API gateway to the Lambda function. Now, you would say that, hey, creating a Lambda function URL also gives you access to a URL that you can call,
and API gateway will also give you a URL that you can call. So what is the difference? Okay, so I'll give you some gist over here. So Lambda function URL is the easiest way wherein you just do one click and you get a URL. It is good for testing, quick prototypes, personal projects, because the authentication and the security options you get over here using this function URL of Lambda. Okay, this is very basic. You don't have much options over here in terms of authentication and security. But if you want more control, you want to have authentication mechanisms, advanced authentication mechanism like JWT, you want to have rate limiting, custom domains, request response mapping, all of that. And these all things would be needed when you're building something that is production grade, right? Or when multiple clients would make use of your Lambda. So in such cases, API gateway becomes handy, right? So what I would do is I would just come over here and we would search for API gateway. And you can see over here, this is a service on AWS. So API gateway. So you can see over here, Amazon API gateway is a fully managed service that makes it easier for developers to create, publish, monitor, and secure API. So you can expose your Lambda function with the help of this API gateway that is by Amazon. Okay. Here in the same region, I'll say create an API. Okay, before I create this, here you can even check the pricing. You can click on learn more about pricing and you can learn more about API gateway pricing. Of course, they have a generous free tier for API gateway free pricing as well. Free tier as well. Okay, but yeah, if you want to check and you're curious, you can check over there. But it's usually free to begin with. Okay, and it's included in free tier. So I'll say create a new API. I'll scroll down. There are multiple types over here. You can see this is a HTTP API. Okay, this works with Lambda HTTP backend. It's a WebSocket API. Okay, this also works with multiple things. REST API. Okay, you gain complete control over request response along with API management facility. You have private REST API. Okay, and this is a REST API that is only accessible from within a VPC. So it's secured, right? So I'll just say REST API. I'll say build over here, and I'll call this as my first REST API. Something like this. You can give whatever description you want, and I'll say I want the IP to be of IPv4 type. Okay, I'll say create an API. Now, the moment you create an API, okay, you will see this sort of a UI over here. So wherein you have to create resources under this API. Okay. So yeah, this is basically a URL, okay, that you are getting. Now understand this, Lambda does not have a URL by its own. You can assign it a function URL. You can create a function URL and get a URL assigned. But having an API gateway and having methods and everything created, like resource methods, everything created, and having it mapped to Lambda is way better than having a normal function, URL. Okay, so here what I'm going to do is I'm going to add a new, so here we can add a new resource, and here I'll say under the root path, I'll say, let's say contact. Okay, added contact, and I'll say create a resource. You can enable course also. So you could notice there was an option to enable course over there. Okay, so you could have enabled that. So here you can see cross origin request sharing. So if that's the requirement, you can enable that, but this is created over here, contact. Okay, this is contact. Now what I will do is here, I'll create a method. Okay, now here you can select the method type. So you can see whatever API has, like delete request, you have to define the request type essentially over here. Whether it's a delete request, get request, head options, patch, post, and put. Okay, so I'll select post over here, a post request. And do you want to integrate it with Lambda function, AWS service, VPC link, mock, or HTTP? Okay, so I'll just select Lambda function because that is what we are doing. If you scroll down, so it is asking you to select the Lambda function name. So you can come over here and you'll see this function appear automatically in the auto suggest. So we only have one function, but if you have many functions, you'll have to type in over here and the list will get filtered. So I'll just choose this. Okay, integration timeout. This is the integration timeout. And then you have some more options over here. So what is the authorization over here? Do you have any sort of authorization? You can select like authorization of AWS IAM. I don't want any authorization. URL string query parameters, URL query string parameters. You can add that as well. HTTP request headers. You can add that. Request body. You can add that if you wish to. So I don't want to add all of that. Okay, I'm just creating an endpoint. I'll just say create a method. Okay, and you can see over here what you have got now. So you can see you have got this sort of the URL. Okay, so this is the entire URL over here. So now this much is created. So I'll do deploy the API. Here you can see the deploy API button, and here it is asking you for the stage. Okay, so you can create any sort of stage if you wish to. Okay, stage as in you can call it dev, prod. Okay, so I'll call it dev over here. If you don't want any stage to be there, you can select no stage, but I can select dev. You can create a new stage called prod over there. Okay, and you can say deploy. So now you can see over here that this URL, so you can see here the invoke URL has been shared with you. Okay, so you can copy the invoke URL, come over here and replace this URL with the invoke URL. Okay, and it should work the same way ideally. Okay, 403 forbidden. What's the problem over here? Okay, is it expecting any sort of authentication over here? Okay. So here, one more thing I would want to try. So I was just checking what the issue is. It says missing authentication token, but I realize I have get request over here. Let me change this to post and check what happens. Okay, it is still giving the token issue. So here, let me come to resources. I need to call contact over here, right? So I'll say /dev. Okay, and I'll say /contact. Okay, so let me say send. Okay, now you can see it's working fine. Can you see this? Right, it's working fine. Okay, now, and now you are able to get the response over here. So this is a response we are generating from the Lambda function. Okay, and you can see /contact, and this method was not right. Okay, and that is why we were getting that kind of error. But this is working fine now. And one more thing you would see over here, like it is throwing this entire body along with status code, headers, and everything. And this is something that you have written over here. So this was needed for when we had the function URL, right? So this was needed. So you can revert to the previous code over here that you had. So I'll just uncomment this and comment this. So I commented this and I just uncommented this one, and I'll just deploy this. Okay. So I'm updating the function. The function is updated now, and now you won't see this entire JSON. You will just see the body, which is this much information. Okay. So when working with API gateway, okay, you can see the just value 11 is coming. Okay. Now if you update the value to new value like so, and if you send this, you're going to see new value. So whatever you are sending in over here is what you're getting over here. Key 1 is being returned. Okay. I hope this is making sense, and I hope you have some good clarity about API gateway. Okay. Now understand one thing. When you want to call a Lambda over the internet, you can't directly hit it with the browser or Postman. Okay. Or you can, provided if you have a function URL created. Okay. But that's not always the right way to go about. Okay. It's a good practice wherein you have an API gateway and you can map the API gateway to that of the Lambda. Okay. And here what we did is we created the API gateway. We have mapped it to Lambda. We have created our own resource, which is /contact. We have even created our stage over here, which is dev. So tomorrow, if you have a new stage, which is prod, you can have that as well. And here we have our own method, which is post. Okay. And whatever changes you are doing over here is now basically being reflected. So whatever changes we do in the Lambda is being reflected over here. Okay. So how this entire thing is working is, first, at the first level, you have what you have. You have Postman. Okay. This is Postman. Now Postman sends a HTTP request to whom? API gateway. API gateway is the one who is intercepting the request that is coming in from Postman. Okay. So API gateway intercepts, then API gateway is triggering the Lambda with your JSON as event body. Okay. Triggers Lambda with JSON as event.body. That is how the trigger is happening. Okay, let me expand the size of this a bit. Okay, so that is what is happening over here. And then Lambda basically, so Lambda is processing then. So Lambda is processing. So Lambda processes the request and then it is returning the JSON back. So it is returning the JSON. Okay, so it returns JSON.
Okay, now this JSON or this JSON that is returned by Lambda is intercepted again by API gateway, and then API gateway communicates with the Postman, and Postman shows the response. So Postman, okay. So here the response comes to Postman. So this is how the entire flow of the entire request works. I hope this is making complete sense to you all. Okay, and I hope this has been absolutely useful. Remember, whenever you are making changes to your Lambda function, be sure to press deploy. Okay, I've faced, like, there have been scenarios wherein I'm wondering why I'm not seeing the changes, and I realized, like, okay, I've missed pressing the deploy button. So deploy button is one thing. Okay, make sure you're calling your API with the right methods. So maybe if you have a resource created using post request, and if you're trying to make an API call using get, that won't work, right? That is going to throw an error. So these sort of things, be sure to keep a track of. So now we can talk about the AWS Toolkit extension in Visual Studio Code and how you can make use of it to update and code your Lambda functions. So here you'll see open in Visual Studio Code option. Click on this, and this will just open the Visual Studio Code for you, and it will open this project as well, and it will ask you to install an extension. Okay, now I've already done this. Okay, so it won't ask me to do the same, but if you say open in Visual Studio Code, it will get this code in a local temporary directory on your machine, and it will ask you to install the extension, and then you are good to go. Okay, and also you can configure the AWS CLI locally. So if you have this configured, you can also deploy your Amazon function to Visual Studio Code without making use of, not Visual Studio Code. You can deploy your Lambda function locally that you have coded locally to AWS Lambda remotely. Okay, and this is using the AWS CLI. There are commands to do that, but I'm going to talk about Visual Studio Code. So here you can see this Visual Studio Code, and I have already got this configured. So here, this is AWS Assist. Okay, AWS Toolkit, not AWS Assist. And here you will also get a README file. Okay, so here you can see what a README file says. Welcome to Lambda local development. Awesome. Okay, you can edit your Lambda function and save it. Okay, you will be prompted to deploy when you are done editing. If you come back later, you can come back later, and if you have more changes to make, okay, you can make use of terminal and favorite package manager to add the dependencies to your project. That's fine. Now you can manage the Lambda function this way. Okay, so there is an AWS Toolkit icon over here. So this is AWS Toolkit icon on the left sidebar, and you can come over here. You can make sure you're connected to the desired region. So here I'm connected to Mumbai. Okay, and here under Mumbai you can see, like, there are different services. So EC2, are there any EC2 instance over here? So you will see all the services. Under Lambda you can see this function here. Okay, you can see this file that is open here. Okay, that is what it says. Okay, now if you make any sort of change over here, so let's say if I make event.key1, or let's say if I comment this out and if I update it to this, okay, I've made the change, I'll save this. Okay, now it says, would you like to deploy these changes? I can say yes, deploy. Okay, or even if I don't deploy, if you say deploy from here, it will deploy to AWS Lambda. If I don't deploy from here, I have another option wherein I can come here, and you can see over here, save and deploy your code. Right, this is on my function. Save and deploy your code, and you can see it is uploading archive file to Lambda. So what it's doing is, it is zipping the entire project, entire file, and uploading it to Lambda. So you can see now, if you come here and let me refresh the code. So where's the refresh button? Okay, I don't see a refresh button here. Let me refresh this entire page maybe. Okay, rather than searching for the refresh button, it's best. Okay, so the function code has been updated and deployed in another editor. To discard your local change and get the latest deployed version of the code, choose accept. To make a copy of your changes, first choose ignore and save the local version of your set. I'll say accept. Okay. The moment you say accept, you will see the changes are visible over here. These are the changes that you did here locally. Okay. You can even revert the changes. Okay. So if you update the changes over here, so let me update the changes here. So now let's say I made use of this editor, and I uncommented this one. Okay, and I deployed from here. Okay, where's the deploy button? This is the deploy button. So I deployed changes. Okay, this is deployed. Now if you come over here, okay, here you will get a prompt that, hey, there is a new version of this function remotely, would you want to pull that one? Okay, something like that. So let me refresh over here. You can see there are changes to your function since you last edited locally. Do you want to override your local changes? I'll say override, and you will see the changes we did in the cloud editor are back over here. So this is how you can make use of this. Of course, you can even zip the function, and you can upload the function. Okay, so you can right click. Okay, right clicking won't work maybe. So let me reveal this in File Explorer. So you can see this is in File Explorer. I can zip this. Okay, I can say compress to a zip file. Okay, this is added to a zip file, index.zip. I can come over here and I can upload it from here, or zip file. I can select that zip file. So you can see I've navigated to the directory. I'll select index.zip. I'll say open. Okay, and you can say save over here. Now you can see this function will get deployed. So whatever changes you did, you can even manually do this. So what you can do is you can copy this code. Okay, if you don't want to make use of this extension that I just showed you, this extension, which is AWS Toolkit. Of course, this is a great extension, I would say, but you might have some different preferences. Everybody has, right? So if you don't want to make use of this extension, you can create a replica of this function locally. You can create a replica of this file in any folder, and you can zip it and upload it this way, or you can even make use of a CLI. So commands. So first command will basically zip the code. It will create a zip file, and the second command will basically push the zip file to Lambda, and it will get it deployed. That is also something that can be done. Okay, I hope this has been useful, and I hope you have been able to follow along so far. So here on dashboard, I want to talk about a few options that are available. So I'll go to the Lambda page. So I'll click on Lambda over here, and this is the main dashboard for Lambda functions. So you can see over here, this is basically giving you some stats. Okay, amount of storage, how many Lambda functions you have created, top 10 functions. Okay, invocations, concurrent executions, and all of that it is giving you. Okay, account level metrics, everything. So you can get a snapshot of everything that is happening in your account with regards to AWS Lambda over here. Okay, this is done. Here you have something called as applications. Okay, so if you create any sort of application, which is basically a high level grouping of resources like functions, API, and storage, if you're building a whole app, you will see all of that over here. Okay, this is a list of the function over here. Okay, so you can see the function here. Then you have code signing configurations over here. So this lets you enforce only signed code packages that can be deployed. Okay, and it is useful in enterprises basically that want to prevent unauthorized code uploads. Okay, so you can only upload signed code packages. Event source mapping. So this allows your Lambda to connect to an event source that pushes data automatically. For example, SQSQ or DynamoDB stream or Kinesis. And this way, Lambda runs without you calling it manually. So basically on occurrence of some event, you will have your Lambda triggered. Okay. Then you have something called as layers over here. Now layers is basically reusable code libraries that you can attach to multiple Lambda functions. So you can create a layer which is reusable, and you can attach it to multiple Lambda functions. For example, a logging library or any sort of shared sort of code that you wish to have, shared SDK. Okay, and creating a layer will save you from duplicating the code across multiple functions. So that is where this layers comes in. Then you have something called as replicas. So replicas basically show the distributed versions of your function running closer to the users. Okay, so that is what it does. And here you have step state machines, step function state machines. So here you can basically chain multiple Lambdas together into workflows like a flow chart. Okay, it is great for multi-step process, like upload a file, process it, save it to the DB, and then notify, something like that. Okay, so these are some options that you would see, but this functions tab is mainly where you would see your Lambda function reside. I hope this was useful. Hey there. So now it's time that we begin talking about few concepts that I have listed over here. We'll talk about each one of them one by one. And if you're a beginner, don't know about what these concepts are, don't worry, stick till the very end because we are going to cover everything that we need from a beginner friendly standpoint. Okay, so let us pick, so we are going to talk about Docker, AWS ECS, AWS ECR, and AWS Fargate. Now, first let's talk about Docker. So what is Docker? So before I talk about Docker, let me give you a overview of what used to happen before Docker was there. Now, I'm just giving you this overview and explaining Docker for those who don't know what Docker is, because everyone who is watching this might not know what Docker is. So before Docker, what used to happen is, if you are working in a team and if you share your development files with someone else or in the team to run that same project on his machine, okay, you used to hear this term very often. So that other person will say, hey, it's the project you shared is not working on my machine, okay, and you will reply that, hey, it works on my machine. So this was a very common thing that you used to hear before Docker. Even you might be hearing this today, okay, but Docker solves this problem and you can use Docker as a solution there. I'll explain how. Okay, so you're working in a team, you have a project that you're working on and it's working on your system, and your friend asks or your teammate asked you to share this project with him. So either via Git or either via Drive or something like that, you share that project with him. He runs it on his system and it is not running on his system. And your reply, he's going to tell you, hey, it's not working on my system. And you're going to tell him that, hey, but it's working on my machine, So what used to be problem over here? So problem over here used to be that apps depend on specific OS settings, libraries, software versions. There are tons of things, the environment in which app is running in, right? So when you're working on a project, you might have installed some dependencies of a certain versions. You might have certain settings in the operating system that you have. Certain libraries might be present, might not be present. There, you must be running it, and it is working on your system. But when you share it with someone else, that same environment might not be there with him. He might have a different software version, or he might not have a software version at all. So if I have to give you an example of a Java-based application or a Python-based application, let's say you're running a Java-based application onto your system. So on your system, let's say it is running using a Java version 24, which is the latest. Okay, you're using Java 24. Okay, but if you give this to your friend, okay, and your friend might not have Java version 24 and he might have Java version 21 installed. Okay, so this is a mismatch, and what would happen is the app is expecting Java version 24 to be there, okay, but he is having Java version 21 and he has no idea. He's running and he's getting an error. It's not running on his system, right? So this is just one example that I've given. There would be tons of other things, like a few libraries are not installed. There are specific OS related settings that might not be there. Okay, so this was a problem. Sharing your projects and everything with someone else was a problem, because you also had to share the list of things. So hey, you install Java version 24. I'll have to tell my friend, you install Java version 24, you install this, you install that, and everything, right? But with Docker, what happened is you could package all of the dependencies along with the application into a thing and into a box, you can say, and you can share it with anyone, and it would run the same way it's running on your system on someone else's system. Okay, so that is that was a problem Docker solved. So what is Docker? Docker is nothing but a tool that lets you package your app and everything it needs into a portable container. Okay, I repeat, it's a tool that lets you package your application along with everything it needs into a portable container, and you can share that portable container with your friends or whoever you wish to, and it is going to run the same way on others' machine the way it's running on your system. Okay, so this is what Docker is. So I've added the definition over here, which I said just now. Okay, so this is what Docker is. Now Docker has a few concepts, and one concept is the concept of image, and then you have something called as a container. Okay, so let me explain in simple terms what image is. So see, you want to share your application with someone along with its dependencies, like everything that it needs, the right side of environment. Okay, so what you're going to do is you're going to create a blueprint. Okay, and that blueprint is going to be image. Okay, it is going to be called as image. And what is this image going to have? It is going to define everything, like how your app runs. Okay, what all your app has, what all runtime environment it needs, the libraries, the dependencies, the configuration.
it is going to have everything. So this is nothing but a blueprint that is going to define the right set of environment for your application along with your application. So image is going to define your application along with everything it needs, right? And then this image, you can run this image. To run the application, you will have to run this image, okay? And that is what is known as a container. So image is nothing but like a recipe or a blueprint you can think of for a container. And then when you run this, you have container and your app is running within this container. So it's like a smaller version of you can say operating system, very small version, very light version. You cannot pack operating system like this and give it to someone, right? So it's very lighter version of what your application just needs to execute, right? Like if your application needs Java 21, so you're going to mention that in the image. If your application needs Python as well, you're going to mention that. Any sort of settings, you can mention that. Any sort of jar files, you're going to mention that, and you're going to create an image out of it. Once the image is created, you need to run the application, right? So you will be running the image, and when you run the image, the app runs inside a container, and that is called a container, right? I hope this is making sense. Now what happens is, images can reside on your local machine, okay? But there are a lot of public images that are available. So usually what happens is, if you have Docker, you can run PostgreSQL, you can run MySQL, you can run a lot of things, right? And there are publicly available images for the same that have been created by the respective vendors, right? So you don't need to install a PostgreSQL if you have Docker installed onto your system. You can just pull an image. You can take an image and you can run the image of PostgreSQL, and PostgreSQL will be running on your system. So what happens is, see, you can host your images. The point I'm coming to is you can host your images. And where would you host your images? So you can host your images to share it with the world, right? And you can host your images on a registry. Registry. So registry is a place. It's like a storage place for your Docker images. So if you are creating some images, let's say you're working on an open source project and you converted that into a Docker image and you want to share it with the world, so you will host it on a registry. Now it's not like all the images that are hosted on the registry are public. Okay, you can even have private images defined, right? So you can have, so in simple terms, understand or to define registry, it's a storage place for your Docker images. Images can be public as well as private. If you make it public on the registry, it is going to be available or visible to the entire world. If it's private, it will only be visible to you. Okay, so that is what registry is. Now this is the official website of Docker, as you can see. Okay, it's docker.com, and you would see over here it's prompting me to download Docker. Okay, and here if you come. This is the Docker desktop. If you download Docker desktop, this is what the UI you see, and you can see containers, images, all these terms that I've explained, right? You can see all this over here. So you can create images, and then if you run the images, they run as containers. You can see view all your running containers or an application over here, right? And you can see over here, what is Docker? Accelerate how you build applications, share and run applications. Okay. So this is the Docker website. You can explore this. It's very popular these days and a lot of organizations use it. Okay. Almost like every organization I see in my network is using Docker. Okay, so that's how popular it is, and there are lots of demand for this kind of technology. Okay, then you have Docker Hub. Now Docker Hub is nothing but a Docker registry. It's a registry where you can host the images. Okay, so you can see over here. Easiest way. Okay, if you scroll down over here, you can see all the images. So you can see Docker official image. If you click on this, you can see these are all official images like Nginx, Redis, Postgres, Ubuntu, Python, MySQL. These are all official images on Docker registry. So if you want to make use of RabbitMQ, for example, there is an official image for this. So you need to install Docker desktop onto your system. Okay, I'll install Docker desktop onto my system, and I'll just get this image onto my system. Okay, so I'll just open this in a new tab. And if you come over here, you can see this is the official image, and there are versions over here of this image. You can see all these tags. So latest tag is one, Alpine is one. Okay, these are all tags basically that has been given. These are all different versions, and you can pull this images onto your system. Okay, you can see there are 1 billion plus pulls for this particular image over here, right? And you can run it this way. So this is the command to run the RabbitMQ instance onto your system. Okay, so everything is there over here. You can just take a look and explore this. So this is about Docker. I hope this is making sense. Okay, what I will do is I will take this over here, okay, and this thing on this side, okay, so that we have some room over here. Okay, now let us talk about the next concept, which is ECR. Now what is ECR? So if I have to define ECR simply, you can think of ECR as Docker Container Registry on AWS. Okay, and it stands for, the full form of ECR is Elastic Container Registry. Okay, that is what it stands for. Okay, so it's basically a Docker Container Registry. It's a way to host your images on AWS. So like we saw Docker Hub, we have Docker Hub where you can come and host your images. So that like the same way you have ECR, which is an AWS service. It is by AWS, and you can come and host your images there as well. Okay, so that is what ECR is. Now then you have something called as ECS. Now what is ECS? So ECS over here is nothing but Container Orchestration Service. Okay, and ECS over here. Okay, so it stands for Elastic Container Service. So I'll just write in over here, Elastic Container Service. That is what it stands for. So what is the meaning of Container Orchestration Service? Okay, you know, if you have multiple images that exist, and if you want to run multiple containers, you can make use of this to run your containers in the cloud. Okay, so ECR lets you host your images. You can host and store your images on AWS using ECR, and you can run your images using ECS, Elastic Container Service. So this is a registry. This is the service that helps you run this. Now I hope this is pretty much clear. And then you have AWS Fargate. Now what is Fargate in that case? So Fargate is nothing but, so AWS Fargate. Fargate is nothing but a launch type for ECS that runs containers serverlessly. So yep, I've added the definition here. Launch type for ECS. ECS meaning Elastic Container Service. So when you are trying to run, so see, understand the process over here. Okay, let's say you have in an application. It can be a Python application, it can be a Spring Boot application, any sort of application you want to containerize. You containerize that on your local machine. You have the image created. Okay, now that image runs successfully on your system. Now you want to take it to production. So what you're going to do is you're going to first store it on a Docker registry, right? And if you're going ahead with AWS for your infrastructure, it's best to make use of ECR over here, which is Elastic Container Registry. So what you would do is you would push the image. Okay, so let's say this is your app over here. Okay, what you would do is you would push your image to ECR. Okay, so your app is containerized and it has it is basically pushed to ECR, and your image is residing on ECR now. Now what you would do is you want to run this app, right? So the image that you've created contains your app and the environment, right? So you need to run it. So what you would do is you would take help of ECS over here. Okay, and ECS would come into picture and it would do the job of running the image that you have stored in ECR. Okay, now when running your containers, there is a launch type. So how you want to run the container? So whether you want to run it with the help of virtual server, which is EC2 instances, or you want to go serverless, what do you want to do? Okay, so do you want to have server? Do you want your containers to run in an EC2 instance in the server? If you want to do that, then you can choose. So when you start running or when you create a ECS service, you will be asked for the launch type, like how you want to configure this and how you want to run this. Okay, when you define the task and service, when you actually are running your containers, you will be asked for the launch type. So you can select AWS Fargate, or you can select EC2. If you select EC2, it means you manage these servers. Okay, but if you don't select EC2, you can select Fargate. It means that your containers will run serverlessly. So AWS Fargate is nothing but a launch type for ECS that runs containers serverlessly. And serverlessly meaning there's no server. Okay, there's no server to manage, I should say. I'm sorry, there's no server for you to manage. Okay, server will be there in the hindsight, but you are not managing it. Okay, AWS is taking care of it. That is what AWS Fargate is. Okay, I hope all these terms are clear, because these terms are important. Okay, whenever you are learning something, you would hear these terms very often when you're working with containerization and AWS. So Docker, AWS ECS, AWS ECR, AWS Fargate. So Docker, what is Docker? Docker is a tool or a platform that lets you package your app and everything it needs into a portable container. Okay, you package your app into an image, and then when you run the image, it runs as a container. And what you can do is, if you can store the image on a registry. There are multiple kinds of registry that exist today. One is Docker Hub. Okay, and the other one, like there are different vendors or different companies have their own registry. For example, Microsoft might have its own on Azure. Okay, AWS has their own on Amazon, and Google will have their own on GCP. Okay, so ECR basically is the Elastic Container Registry, which is a Docker registry for AWS, on AWS for Docker images. Okay, so you can have your Docker images over here, and then you can when running your Docker images, you can make use of ECS, which is Elastic Container Service. And when running your containers, you will have an option to choose if you wish to run them serverlessly. If you choose that, okay, AWS Fargate, so you will be making use of AWS Fargate in that case if you choose to run it serverlessly. So I hope all of this is making sense now to you all. Now here I am in the AWS console, and let us explore ECR registry. So here you can search for ECR, and it should show you over here. So you can see over here, it is showing me ECR, Elastic Container Registry, fully managed Docker container registry, right? Now if you search for Elastic Container, you will see Elastic Container Registry and Elastic Container Service, right? So this is for Docker, like storing Docker images, and this is for running those images. They both are separate. Let's talk about registry first. So I'll go to registry, and you can see over here, share and deploy containers software publicly or privately. Okay, so it shows you over here, you write code, you package it, okay, into Docker image and send it to ECR. And from here, you can run the containers on ECS, EKS, or, ECS and EKS both reside on Amazon Cloud. Okay, EKS is nothing but Kubernetes service, Elastic Kubernetes service, but we are talking about ECS. So ECR and ECS is what we are talking about. So now over here, you will see the benefits. You can explore this over here. Okay, there is a pricing as well, so you can click on this and know the pricing if you wish to. Okay, and it's a part of free tier as well, wherein you get 500 MB per month of storage for your private registry for 1 year. Okay, so this is something that you can leverage if you're learning. So come over here, what we will do is we will create a registry. Now over here in this registry, we need to store an image, right? So if you have a local image or a local application that you're working on, then so let's say I'm a Python developer, I'm working on Python application, so I can convert it into a Docker image. I can make a Docker image out of that application and I can push it to ECR. So for that, I need a repository. Now repository is like a place that you're creating in the cloud within ECR, wherein your wherein your images will be stored. Okay, so that is something you can do. So this is a private repository that I'm creating. Okay, and which image should we store over here? So if you're a Spring Boot developer, you can containerize your Spring Boot applications and push it over here. But what I'm going to do is I am going to take some public image that is already existing. So here I'll come in, and here on Docker Hub, you have this image of Nginx. Okay, this is the official image of Nginx. So what I will do is I'll make use of this image over here. So what I will do is I'll come over here, ECR here, and I'll call this Nginx. Sorry, not M. This is Nginx, and I'll call this as sample. Okay, something like this. Okay, so Nginx sample is what I have called my repository. Image tag is mutable.
and here this is the encryption setting. I won't alter any of them. Okay, I'll leave everything else to default and I'll just say create. Now this repository is created. This is the URI over here. Okay, now before now one thing I forgot to mention is you should make sure you are in the right region over here from here. Right, so you need to make sure you are in the right region. Okay, and remember the region in which this is being created. Okay, because if once you're done learning, you should know where your registry is being created so that you can go and delete it later on. Otherwise, you will be charged for that. Right, if you're not in the free tier, you will be charged for that, and if you finish your free tier, you will be charged for that. Right, beyond free tier. So it's important whatever you're creating, you delete it. Right, so this is something that I've created. Now go inside over here. You will see there are no images over here, of course, because we've just created this. What you can do is you can click on this view push command and you will get all the commands basically for Mac as well as Windows over here. Okay. So what we will do is we are not pushing an actual app over here, but we will get the Nginx official image on our local machine and we will push it to ECR using the set of these commands. Okay, that's what we are going to do. So what I'm going to do for this is we are going to need Docker on our system. So if you don't have Docker, quickly come to docker.com and download Docker depending on your operating system and install it like any other software. It's just a normal software that you install on your system and you will see this kind of an interface. So open Docker desktop and you will see this kind of an interface. I already have a couple of containers created, a few images. Okay, so I play around with Docker a lot. I use this software a lot and that is why I have it already onto my system. Open PowerShell or any terminal on your operating system. So just open it like this. And what we will do is we will get the image first of all. Okay, so just see over here, it is trying to retrieve the authentication token. It is trying to build the image using this particular command over here. And then once it completes, so basically it is tagging my image to that of repository. So what I'm going to do is I'm going to come to PowerShell. Okay, and since I have Docker desktop installed, I can run Docker commands over here. You can see Docker commands. I did not get any sort of errors. So first of all, I'm going to say Docker pull, and I'm going to pull the image onto my local machine, right? So you can see over here, this is the image over here, and what is the name of this image? So this image name is Nginx, and I need latest over here, the latest version of Nginx, right? So what I'm going to do is I'm going to say Docker pull Nginx latest, something like this. Okay, I'll say enter. And now what this will do is this will pull the latest image of Nginx, and it will take some time depending on your internet connection speed. So it is pulling this entire image onto your system. And as soon as the image pull is complete, you will see the image over here in the images tab. So you can see this Nginx being created over here. Okay, this has been pulled locally. Now what I will do is here, if you see all the commands that we are getting, okay, here first of all it is retrieving the authentication token and authenticating our Docker client to the registry. Okay, so that is something we can do. So I'll just get this, I'll just copy this and let us do this. Okay, so I get this error. So when I executed this command, it did not work. Okay, and after doing a little bit of research, I found that this command is outdated in the latest version of CLI. I don't know why it's coming over here in that case. Okay, but it's there on the dashboard, and if you get any sort of error, do a little bit of research and you might be able to solve it. Okay, so how I solved it is I ran this command, the latest one over here. You can see this. So here I ran this, but I got an error because the region name was incorrect over here. And then I ran it with the right region name. So you can see this over here, AWS ECR get login password -2 times AP South 1. This is the region. Okay, -2 times region. You mention the region and then you log in using username AWS and password STIN. Okay, and you mention this. Okay, this is your ECR. So login has been succeeded. Now we don't want to build a Docker image. So if you have an application, you can build the Docker image like this, but I don't want to build a Docker image, right? I want to tag it instead. Okay, so I'll copy this one. Okay, this next command, and I'll come over here and I'll paste it. And instead of calling it Nginx sample : latest, I'll say Nginx latest. Okay, because so you know what you're doing is you are tagging your Docker image with this name. So this name basically, which is the name of the ECR repository is being added as a tag to your image. Okay, so you need to mention the current image name and the tag you want to add. Okay, so what is the current image name? Current image name is Nginx latest, because that is what we have pulled over here, right? So Nginx latest is the latest image, is the image that we have. So I'll just mention enter and you will see it being tagged. And now what we will do is I'll just say docker push and I'll get it pushed. Now before pushing, you will see that there are 0 images. Okay, but let me push this. Oops. So I'll just say push and we'll wait for a while. So now what happened is we got the image onto a local machine. We added the right tag over here and then we pushed it to the ECR. So we have not modified the image or we have not done anything. We just got the image, a public image from the Docker registry, which is of Nginx, and we are pushing it to our own created ECR repository. And you can see it's pushed over here. Okay. And here it's pushed, it's giving the confirmation. Now if you come over here, let me refresh, you can see one image has been added over here and this is the image URI, so you can copy it. Okay, I hope this is making sense as to how you can start pushing the images to the ECR repository in AWS. Okay, now I'll just reiterate over the steps. Okay, first step is after you create the image basically. So whichever application you are running, whether it's Python, whether it's Node.js, whether it's Spring Boot, whichever application you are running, first containerize that application locally. You will have the application containerized. Okay, you will have an image and that image will have a name, right? Then what you do is you need to log in, you authenticate yourself over here with ECR. So here, that is what I've done, authenticated myself. You'll get this command from the dashboard itself. That is what I did. And then come over here and say docker tag and mention the image name. So here the image name in my case was Nginx latest. This was the image name, right? So I've made that image name. I'm making use of Nginx docker tag Nginx latest, and I'm mentioning the image name over here. Sorry, not the image name, the name of the ECR basically that is being created. Okay, this is something that I got from the dashboard over here. Okay, this is what I'm doing. Okay, so I've tagged the image with this ECR and then I just did docker push and I mentioned the repository URL and the image name over here. You can see this. And the image got pushed over here and you can see this is what the command was. The image got pushed and you can see the image over here. So I hope this is making sense and I hope you have now a good understanding of ECR. Now after you have an image on ECR, the next step is to run it, right? So what you can do is, let me duplicate this tab a bit, okay, and I will come over here and I'll search for ECS over here, which is Elastic Container Service. Okay, so let us go over here. Now this is what Elastic Container Service is. Here you can run fully managed containers. You can see it's highly scalable and everything. It's easy to run, stop, manage containers in a cluster. So you will see this term quite often, cluster. What is cluster? So cluster is nothing but a logical group or an environment where your containers can run. Okay, you can think of it as a place where your containers are running. Okay, and inside a cluster you can run many tasks and services. Okay, so there are a few terminologies when it comes to talking about ECS, and we'll talk about those terminologies as well. But for now, you can take a look at ECS over here, and you can see over here serverless option. So ECS provides a serverless option with AWS Fargate. Okay, and using AWS Fargate, you can run your containers in a serverless mode. But if you want to also have servers in place, you can make use of Amazon EC2 instances as well. And when you're creating and provisioning clusters and when you're creating task services, you will have an option to choose which way you want to or which approach you wish to run with. Okay, whether it's serverless with Fargate or with EC2 instances. So all of that we'll be taking a look at. Okay, you can see all of the other features as well. Okay, so here what I'm going to do is I'm going to say get started here, and there are no clusters, right? So what is the first thing we would do? We would create a cluster. So I would say create a cluster. Okay, and here it is giving a default name. Okay, so you can I'll just stick to this name. If you want to edit it, you can edit it if you wish to. Okay, now you can see over here for service connects, I'll just stick to default over here. Infrastructure. Okay, now this is where you will configure your cluster
as to how your containers are supposed to run. Okay, so you can see over here, you can choose AWS Fargate for going ahead with serverless mode, or you can add Amazon EC2 instances. So you choose either of the two. So for AWS Fargate, you pay as you go. Okay, and for EC2 instances, there will be some manual configuration. So I'll just choose AWS Fargate. Okay, so what is AWS Fargate? AWS Fargate is a launch type for your containers, basically over here, wherein you run your containers in a serverless mode by checking this option. Okay, you can read more by clicking on this info button and you'll see some documentation over here, right? So this is fine over here. Now, if you scroll down, I don't think we need to select anything else. Okay, I'll just say create over here, right? So the moment we do create, okay, this creation is in process and this will take a bit of time. Okay, so we'll wait for a while until this process finishes. So when creating the cluster, I got this error. Okay, and this error says resource handler returned a message, invalid request provided, create cluster in unable to assume service linked role. So this is very important, unable to assume service linked role. Now understand this, ECS over here, this is Elastic Container Service. It's a managed AWS service, right? So ECS, to run the containers on your behalf, it also needs to talk to other AWS services, right? It might need to create a load balancer, or it might need to do anything to run all of this, right? So it needs certain roles and permissions, and that is what it is telling. It is not able to assume this service linked role. So please verify that the ECS service linked role exists. Okay, so what we need to do is we need to head over to IAM, and in IAM we need to check if this role exists. So I'm going to come over here, IAM. Okay, let me open this IAM in a new tab, and here I will head over to the user, admin courses. So this is my user. Okay, and here, sorry, not user. So I'll have to come to roles over here. Okay, so basically we'll need a role. So if you come here, you need to see this, or you need to search for this name over here, AWS service role for ECS. And this should exist because this is defaultly created. It is created by default by AWS, and under trust relationship, you should see that this role exists. Okay. Now the problem is we are still getting this error over here that we saw, right? Ideally, it should not have happened. But let me try this again. Let me try creating the cluster again. It could be possible that there might be some sort of cache. Okay, and it did not allow me to create. So I'll again try creating this. I'll make sure AWS Fargate is selected. I'll say create, and let us wait for a while. Okay, so my guess was right. Okay, probably there was some temporary issue. And right now you can see this cluster is created. Okay, so sometimes this might happen wherein you're trying to create a cluster and you get this error. Okay, just wait for a while after you access Amazon ECS. Okay, there might be some backend tasks running or something like that, and there might be some sort of cache that might make that error happen, which we just saw. Okay, so yes, this is created. Now this is a cluster, which is like an environment where our container is going to run, and it is Fargate based over here, right? So now if you go over here, okay, inside, you're going to see some things over here like services and tasks. Okay, of course there are tons of things like infrastructure, metrics. You can see a lot of things, schedule tasks, configuration, tags, and all of this. But under services, let us talk what services are, because we are going to create a service. We are also going to create a task. So what is a task first of all? So here you need to create a task, and that task is basically defining a running container or a group of containers. So you basically are defining the blueprint of what all containers you wish to have running in this particular cluster. So that is what you create a task for. And then you have services over here, which is like a manager at the top, and it ensures that a certain number of tasks are always running, and features like auto scaling, load balancing, restart on failure, all of this are taken care of. Okay, so service is basically making sure that everything is running fine, and task defines as to how and what things run. Okay, so what we will do is we will start creating these. So first I'll create a task. Okay, so I'll say run a or there should be a task definition over here. Okay, task definition. So on the left hand side you can see task definitions. right? So go over here because you need to add a task definition to create a task. So I'll say create a new task definition. I'll just get rid of this. I'll say create a new task definition, and you will see a page like this. So here I'm going to say Nginx task over here. Okay. And here we are specifying the infrastructure requirements again. So I want to have the launch type as serverless, okay, which is making use of AWS Fargate. I'm not making use of Amazon instances, EC2 instances, right? So I'm not making use of AWS EC2 instances. I'll just select Fargate and I'll just scroll down task roles. I'll just leave everything as is. Okay. Now here you have container details. Okay. So you need to mention, or 1 second. So there is a role requirement as well. Task role, create a new role. Okay. So there is no task execution role. So I'll just skip this. Okay. Now coming to container over here, we need to mention the container name over here. Okay. So container name basically is the name with which your image runs in the cluster. So I'll mention Nginx. Okay. Nginx over here. You can mention any name. That's completely fine. And then over here, you will mention the repository URI, or this is the format in which it comes. And if your image is hosted on AWS ECR, so you can click on this, okay, and here you can choose the repository. So Nginx sample is the repository that we had created, and then you can select the image over here. So one repository can have multiple images, so you can select which image you wish to add over here, okay. And you can say use image tag latest. Okay, so the image will come over here, and then you scroll down. Okay, I don't think there is anything else needed over here. Just make sure like the container port is mapped to 80, because within the container our application will run on port 8080. Okay, and this might be different for your application. So if you are running a Spring Boot application and if you are running it on a certain port, so you have to make sure you do the port mapping over here. Okay. Scroll down, nothing else over here. Okay, nothing else. So nothing else is needed over here. We'll leave everything else to default. Okay, and I'll say create over here. So this task definition will be created. Okay, and it's basically a blueprint for running containers. Okay, so this is created, task definition. Now what we need to do is, once task definition is done, I'll go to clusters. Okay, within my cluster, I will come over here and I'll say create a service. Okay, so I'll say create a service, and we'll see this this page over here. Now here we need to select the task definition family first of all. Okay, so I'll select the task that I've created, which is Nginx task. Okay, and here this is the service name that it has auto created. And if you scroll down, it is basically asking me to choose the compute options. So I'll leave all of this to basically default. Okay, you can modify this if there are any specific deployment requirements for you all. But if you come over here under networking, since we want to make sure that we are able to access the Nginx page from the browser after deployment, if you come over here, you have to make sure that public IP is turned on. Okay, should be turned on. Now scroll down over here. Okay, from here you can choose the right VPC and all, but I'll just leave this to the default ones. Okay, if you have any specific VPC created, you can add that. Then you scroll down and say create over here. Now once you create this, okay, you will see the service creation will start and deployment is in progress. Okay, so we'll wait for a while until this completes. Now after waiting for some time, you can see it is still showing me in progress. Deployment is in progress. But I can see service is active over here and task is also running over here. This is a task that is running. Okay, using the task definition. So service is now making sure that our deployment is up and running. So I've still not got a confirmation. So probably there are some background tasks that are still going on. So I'll wait for a while again. So now is when I see a confirmation. This actually took few minutes, okay, to complete. So everything is done, and now you can see over here that it has been deployed successfully. Now what I can do over here is you can go to tasks. You can see task running. That's fine. You can go inside a service over here, and inside the service you will see different tabs. So you can check like everything around your application. So you can see the health over here. You can set alarm over here. All of this you can do. Okay, and you can see what all tasks are running. Like we could see outside. You can see the logs as well.
Okay, so if you want to see any sort of logs, you can see that over here. You can take a look at the deployments over here. Okay, and then you have events. So what all happened over here? Okay, the list of events that happened. So when it wasn't ready, when a task was started, all of this. If you go to configuration and networking here, you should see something called as public IP. Okay, I don't see a public IP over here. Okay, public IP assigned. I don't see a public IP here, but it should be in this tab. Not over here. Okay, I'm in the wrong place probably. So I'll go to services. I'll go to tasks. Here within the task, I should see this public IP. Okay, so public IP comes within the task. Okay, so come over here. I'll just get rid of these messages. So public IP, you can say open address. And if you click on open address, it should open in a new tab. Okay, or you can just copy the IP address and paste it in the browser. So now we should see a welcome page for Nginx. And if we don't see the welcome page, there is probably an issue that the page is not accessible. So the service is definitely running in the cloud on Fargate. Using ECS, but okay, it's not able to reach this. So there is probably a security sort of restriction that has been added. So what I will do is I will come over here. I'll go back. I'll go to service. Within service, I will check this. I'll go to configuration and networking, and I'll go to the security groups over here. So let us check the security groups. Okay, so there might be, okay, so we'll have to add an inbound rule over here. Okay, so I'll say edit, I'll say add a rule over here, and I'll say all TCP requests from anywhere should be allowed, and I'll save the rule over here for this particular security group. Okay, all traffic should be allowed from anywhere, and that is what I've done. And now if you try to access, let us see. Okay, you can see now it's working fine. You can see welcome to Nginx. This is working absolutely okay, right? So yes, this was good, and I would highly recommend that the changes that you did over here for all the traffic, okay, all the traffic, the thing that you created, please delete that. So this is the one that I had created, like from anywhere is what I had mentioned over here. Okay, so this was the one. So I'll just get rid of this and I'll say save rules. Okay. So I've updated the security groups now, and again now this page should not be accessible. Okay, so I'll tell you the reason why I reverted this change over here, because this VPC might be used for any other service, and this inbound rule basically is opening up all the traffic to via this particular service group. Okay, it's opening up all the traffic, so I don't want that to happen, because if I use this VPC somewhere else, sorry, not this VPC, but this security group somewhere else, then it will create a problem. So I just reverted to the old change. The goal was just to see that this is deployed and it is working absolutely okay. You can see it was accessible through the browser. And if you have the application, anything that you have deployed over here, okay, you should also see that running with this. Okay, so I hope you have been able to follow along and you could understand as to how you can run your containers using Fargate. Now, once you're done understanding this, it's important that you clean up like all the clusters, services, tasks that you have created. Okay, so what I would recommend is you come over here to services, you get rid of this service, you delete this service. Okay, because AWS is going to bill you for the usage. Okay, it cannot be stopped while it's scaled above 0. So if you see this issue, what you do is you go to services. Okay, so inside services, so one second. So here, if you come, you go inside services. If you see this sort of error log, click on update service, and here instead of where you have desired count, okay, so desired count is desired tasks. So here I'll update this desired task to that of 0, and I'll say update over here. So the moment you update, the service is updated. Okay, now come over here to services. If you see tasks, okay, you will see this is stopped now. Okay, you can see last status was running, so this will be stopped now. But if you come over here, this needs to be deleted. So I'll say delete the service. I'll say delete, like so. Okay, and I'll say delete, and the service is gone. So service is gone. This task will also be deleted. So I'll say stop all. Okay, so stop all tasks over here. This is done. Okay, so no task to stop. So this is already stopped. That is absolutely fine. I'll also get rid of this task definition. I don't
Okay, is there a way to delete this? Okay. I don't see an option to delete this, but that is fine. So you go to cluster and get rid of the cluster. So over here, I'll just delete this cluster. Okay, so you need to type this over here, the delete and cluster name to confirm. So the cluster will also be deleted. Now, if there is any sort of load balancer or anything that is created, that also needs to be deleted. So meanwhile, the cluster is being deleted. I'll also come to ECR over here. So Elastic Container Registry. Okay, search for ECR and come over here. And you have the image hosted over here. So get rid of this as well. Okay, because you will be charged for host or storing images on AWS. Okay, so just do this and come over here, and then you should see there are no images over here. Okay, and if you come over here, was this deleted? This cluster was deleted. So if you come over here now, there are 0 clusters, 0 namespaces, no task. Okay, task definition is there. Okay, this I don't see an option to delete this, but that is absolutely okay. Over and above, what I would recommend is you should head over to EC2 console and also check for, here if you come, you should check for elastic IPs. If there were any elastic IPs that were created during the creation of, clusters. And if they have not been deleted, you should delete it from here. You can check for load balancers over here. If there are any load balancers, if there are any, please delete it. They would cost you money. And yeah, this is it. I think there should be target groups over here as well. I don't see the target groups option. Okay, that's fine. So target groups, there is no target groups. Okay, so elastic IPs are not there, target groups are not there, nothing is there, only task definition is remaining. So come over here and here just go inside task definition, inside task, and here you will see action and deregister. So just deregister this one. And the moment you deregister this one, you will have an option to delete. So you can delete it. So task definitions don't cost money. You can have task definitions there. Okay. But I'll just delete it so that there is a bit of cleanliness over here. So task definitions are gone. Okay. So we have cleaned everything and now we won't be billed for anything. I hope you have been able to follow along and I hope this was useful.